Hi guys, a very good morning everyone. Very good morning everyone and welcome on your demand to the signal and system revision also. Okay, the revision marathon for signal and system, but as I told you, the exam date is close. The exam date is close, and that is why we have planned to take up this revision, okay, this marathon, okay, so that you also revise up the subject, but parallelly you cover a 51 important questions of the subject, the 51 important questions of the subject signal and system. Okay, so definitely 51 questions of technical subject, that will be definitely going to take time. So that is why, just take it as a marathon session. It's going to take some time, but okay, I would like to cover up concepts through questions. Very good morning everyone. Come on, keep joining. Everybody keep joining. Just a second guys. अभी 11 हो रहा है. Yes dear. Very good morning. Come on everybody, quickly keep joining and update your friends that the session is now live and they can also join up the session quickly, okay, for the entire revision now. Yes, good morning Priyanka, good morning Mr. Saint, morning Sachin, morning Dreamer, Srijan, Payash, morning Raju. Okay ji, okay. So dear, time to get started. Slowly. Revision marathon through 51 most important questions. This is a regular introduction that you are all aware about. Okay. ठीक है Srijan, we can plan for communication as well. Very good morning Monica. Okay ji, ठीक है. So guys, like all other sessions, you will be getting the PDF for today's session. You'll be getting the PDF for today's session, and that again in my Telegram group. Okay, whose link also I will share you directly in the chat box. And if you want, you can just directly join using this name. Okay, and you'll get the today's PDF with whatever question and concept we are discussing. Okay. So yes, guys. Next important update for you is that on the BYJU'S exam prep app also there are several free live classes going on. So this last 4-5 days we planned some important revision with respect to non-tech like maths and aptitude. Okay, yesterday I already taken that 3-year PYQ session of aptitude. So today 30th of January, okay, important last 3-year PYQs of engineering maths will be covered by Dheeraj Sardana sir, and that's going to be on the app at 6 PM. So that will give you a clear-cut idea of how the engineering maths level has been in the last 3 years and what are the major areas that have been targeted in the exam. And then guys, Wednesday, 31st of January, that is tomorrow, okay, 7:30 PM, Abhinav Negi sir brings to you a free interactive live workshop on the BYJU'S exam prep app. How to crack GATE in the first attempt. How to crack GATE in the first attempt. Okay, join this, okay, to boost up your strategy, to boost up your preparation for the GATE examination. Right. Yes, definitely, Mr. Saint. Okay, good morning, Status, Vasant, Niku. Good morning, Tithi. Okay. So, yes, guys. So, let's get started. Okay. Now, the idea is, I am telling you, we'll cover up required theory, required concepts and all. Of course, we will not have that much of time to go into derivation, but all important concepts we'll brush up definitely. Okay. Morning, Vinay, Vaibhav, Mukula, Jayesh. So now, I just felt that, at this point of time, just around 10 days left for the ECEE examination. Today we are talking about signal and system. That is just 10 days left for the ECEE examination. Okay. And at this point of time, I just felt that students would be clear about fundamentals part at least. Students would be clear about the fundamentals part at least. So, what we are covering today, let me give you a very honest, thing in the beginning only. What we are covering today, okay, is the heart of signal and system. I mean, definitely. Okay, what we are covering is what the signal and system is completely built up of. And today we are going to cover up, okay, all type of transforms. Okay, we are going to cover up, okay, the different transforms. Okay, assuming that foundation part you are clear. Foundation part you are clear about. Okay, is that okay? Is that nice to go like that? continuous time Fourier transform. Then I will also include continuous time Fourier series. Okay, we will be talking about Laplace transform, we will be talking about Z transform, we will be talking about DTFT, and we will be talking about the DFT. Okay, I have made up the 51 questions comprising of these areas, assuming that fundamentals and all, okay, you might have prepared by this time, or you can prepare it through any other source quickly. But this is where actually, these are the areas where questions come. Okay, fundamentals is required, but direct question from fundamentals, they don't come that frequently. Okay, but this is the area where questions keep on coming very frequently. Okay, very, very frequently. Okay, very, very frequently. Okay, yeah, DTFS will also be, we can include, okay? DTFS also, no issues, okay? Right. So, to be honest, this is what, our target will be for today's session. Okay, so that, rather than studying every topic just roughly, let us understand this properly. Okay, let us understand this properly. Okay, so DTFT for EE, not much important, but very basic. So, now, if you are comfortable up to this much, na, see, DFT is very important for EC. Okay, DFT तो EC वालों को बहुत अच्छे से पढ़ना चाहिए. You expect a 2-marker question here. Okay, but if you're a EE student, if you're clear with this question, DTFT will automatically be clear. I mean, the approach of problems will be clear. So don't skip it. That's what I will say. Skip मत करना इसको, ठीक है? चलो then, start करते हैं dear. Okay, which of the below Fourier transform pairs are correct? Now let me first start as a revision. I will tell you all the required theory here, but let me first start actually as a revision. Let me see how many of you know, because some of the pairs are normally that you must be knowing. Onto some of the case we will apply the property. Onto other cases we will apply the property. Okay, then I will revise what is required here, what properties are required, what is not required. Okay. For EE point of view, Nana Prakash, I'll tell you here, EE point of view, two topics are very, very important. Okay, Fourier transform, okay, Z transform. Majorly, इससे तो बहुत question आते हैं. I mean, majorly. I mean, you have to study all, but CTFT and Z transform for electrical point of view, very important area. ठीक है. For EC point of view, okay, this much, including Fourier series, and this much, very important, including Z transform also. EC के लिए थोड़े ज़्यादा topics important है. They keep on having the distribution. Come on. So which of the options are correct? Let me first see how much you tell, and it is a MSQ question. I start with multiple select question. It is a multiple select question. And some of the answers are very common pairs. So now, before I tick mark, let's get started with some revision. Okay, let us get started with some revision. So I'm telling you, question plus revision. It's not only 51 question and answer. Okay, otherwise the session jaldi mein hoga. I'm telling you, session will be long because I will revise also. Okay, but revision very quickly. So we all know the basic definition of Fourier transform. Okay, we all know the basic definition of Fourier transform. Okay, that is given by integral xt e power minus j omega t dt. Okay, and then inverse Fourier transform will be given by 1/2 pi integral x omega e power j omega t d omega. We write down xt and x omega as Fourier transform pair, commonly represented by double-sided arrow. Okay, double-sided arrow means xt has the Fourier transform x omega has the inverse Fourier transform xt, or we also represent it by this double-sided arrow. Okay, double-sided arrow. Okay, then what are the conditions for the convergence of the Fourier transform? Okay, the most important condition for the convergence of Fourier transform, that it should satisfy the following Dirichlet's condition. The most important mathematical point being xt should be absolutely integrable. Okay, that is integral mod xt dt should be less than finite. Integral mod xt dt should be less than infinity. It should be a finite quantity. What not clear, Vasant? Okay, integral mod xt dt should be finite, right? Okay, at the same time, just to remove the randomness of the signal, this will be defined. इस पे बहुत ज़्यादा भी आपको focus नहीं करना है, but just let me tell you that xt should have a finite number of maxima minima within any finite interval of time, and xt should have finite number of discontinuities, which each of the discontinuities is finite. Okay, vision not clear means? Vasant, please elaborate what exactly is not clear to you. Okay, then what are the important properties of Fourier transform that you should focus? Okay, number one, linearity. If two signals are added, their Fourier transforms will be also added. So x1t, I assume Fourier transform x1 omega, x2t has the Fourier transform x2 omega. Also, scaling also applies. Linearity is always a combination of what? Scaling and additivity. Scaling means if the signal is multiplied by a1, Fourier transform is also multiplied by a1. Okay, similarly for the next a2. Then these two parts are added. The Fourier transform also added. This is basic linearity property. Okay, then we have the time shift property. So whenever there is shift in the time, there is a phase term. Okay, there is an exponential phase term. Okay, in the frequency domain, e power minus j omega t naught. Whenever you write down a complex term of the form, r e power j theta, okay, this r is known as what? This r is known as the magnitude of z, and this theta is known as the angle of z, also known as the argument of z, or also known as the face of the z. Okay, so whenever we have a e power j theta term, the theta is known as the face. No, camera clarity I think is okay. You just check your setting, because I have the session running with me parallelly. Vashant, refresh. It is totally clear, right? It is totally clear. एक बार आप refresh कर लीजिए. There isn't any issue, because मैं भी parallelly watch कर रहा हूँ session को to read your comments. ठीक है. So whenever there's a time shift, there will be an exponential term, phase term, a complex exponential term in the time domain, e power minus j omega t naught. If you make it plus t naught, this will also e power plus j omega t naught. Okay, time scaling x of at 1 upon mod a x of omega by a. This also means that if you try any value here, suppose कभी-कभी fundamental points आ जाते हैं. Suppose if I take 2t, if I take x of 2t, now what is x of 2t? X of 2t means compression. Okay, whenever mod a greater than 1, it is compression. So you are compressing in the time domain. Similarly, when you put the value of a here, it becomes how much? 1 upon 2 x of omega by 2. So when you come in the omega domain, x of omega by 2, here mod a less than 1, that will represent expansion. Okay, so whenever there is compression in the time domain, there is expansion in the frequency domain, and vice versa. If there is expansion in time, there will be compression in the frequency domain. Okay, clear? They'll go opposite. Compression here, expansion there, expansion here to compression there. Okay, next, time folding. Just put a equal to minus 1 here. So when I put a equal to minus 1, I get x minus t as x minus omega. If there is a folding in time, there is a folding in frequency. Then the duality. Okay, then the duality. Duality को अलग से समझ लेते हैं. Duality, I'll explain you by this pair. So we have xt, and we will have questions on duality also very soon. Okay, having the Fourier transform x omega. If xt has the Fourier transform x omega, okay, then what is the Fourier transform of capital XT? I mean, if this was a time function, and for any time function we can calculate Fourier transform. So if this is made as a time function, if this is converted to omega equal to t, I get x of t. Okay, and for that x of t, what is the Fourier transform? That is given by 2 pi small x. Okay, that original time domain function. Okay, where you will put t equal to minus omega, 2 pi x minus omega. That is why Fourier transform pairs are dual in nature. If A has the Fourier transform B, then B will have the Fourier transform like A. Okay, they are Fourier transform dual of each other. Okay, so 2 pi x minus omega, that is what is the important duality property. Then conjugation, x conjugate t has the Fourier transform x conjugate minus omega. Okay, then differentiation property, d by dt will have d by dt of xt having the Fourier transform j omega x omega. If you take nth derivative, that will be j omega power n x omega. ठीक है? Then integral minus infinity से t x tau d tau will have the Fourier transform x omega by j omega plus pi x0 del omega. Okay, frequency differentiation, or also known as t times property. This is frequency differentiation, also known as the t times property, multiplying a signal xt by t. Multiplying any signal xt by t. Okay, the Fourier transform is j d by d omega of x omega. Differentiation coming up in the frequency domain. So I've brought the complete table for you. Okay, ये पूरा revision आपके लिए हो जाएगा. I mean, you will have the entire notes also when I share you the PDF. Okay, so every property, every important Fourier transform pair will be there for you, and of course the 51 questions that we solve with the solution will be there. Time shift corresponded to exponential term, phase term in the frequency domain. Similarly, the frequency shift, if there is a frequency shift, okay, then there is going to be exponential term, that is a phase term in the time domain. E power j omega naught t xt is having the Fourier transform x of omega minus omega naught. X of omega minus omega naught. Please take care that in frequency shift sign will be opposite. If it is x omega minus omega naught, it will be e power plus j omega naught t. Right? Convolution. Okay, when two signals are convoluted in time, okay, they will be multiplied in Fourier domain. Okay, frequency domain, x1 omega into x2 omega. Multiplication in time, dual of it. Okay, multiplication in time, convolution in frequency. 1 upon 2 pi x1 omega convolution x2 omega. Modulation, xt cos omega naught t. Okay, whenever xt is multiplied by cos omega naught t, any cosine signal, its spectrum will be shifted to higher frequency. So what is the spectrum of xt? X omega. But now it will be shifted to higher frequency, x omega minus omega naught plus x omega plus omega naught. Once right shifted, once left shifted, and amplitude whole divide by 2. And amplitude whole divide by 2. Okay, some very very important symmetry property जिस पे questions आते रहते हैं. Okay, symmetry property. In general, a signal may be complex. Its Fourier transform resultant will also be complex. Okay, if the signal is real, Fourier transform will follow conjugate symmetry. These have simple derivations but not required right now. Okay, the Fourier transform will be conjugate symmetric. What is this conjugate symmetry, dear? Conjugate symmetry says that x of minus omega will be x conjugate omega. That means the Fourier transform for negative values of omega can be obtained by taking the conjugate of the positive values. Okay, x omega ka whole conjugate. That is what conjugate symmetry is. Next important, if signal is real and even, Fourier transform also real and even. If the signal is real and odd, Fourier transform will be pure imaginary and odd. Okay, if the signal is conjugate symmetric, iska dual dekh lijiye. If the signal is real, Fourier transform conjugate symmetric. But if the signal itself is conjugate symmetric, the Fourier transform will be real in nature. The Fourier transform will be real in nature. Okay. Then there can be some mathematical application other than the property. The questions can be of mathematical application like area under the curve. We know the formula of Fourier transform now, and in this formula put omega 0. X omega is integral xt e power minus j omega t. So if I put omega 0, e power 0 is 1. You are left with integral xt dt. What is integral xt dt? Is the area under the curve. Okay, it is the area under the curve. Questions mein aayega duality once again when I take it. It is the area under the curve. So now dear, okay, there are some signals whose area mathematically will be very lengthy. Integration process will be very lengthy. We can use the Fourier transform there at omega equal to 0. That is at the DC frequency. So x of 0. What is this x of 0? This is the Fourier transform x omega calculated at DC. Omega equal to 0, and that will give you the area of the xt. And similarly, if I use the inverse Fourier transform formula and in that I put t0, so I get integral x omega d omega, that is area under x omega divided by 2 pi is x0. So if you want to write down integral x omega d omega, तो ये कितना हो गया? That will be 2 pi x naught. Okay, area under x omega, area under the Fourier transform in omega domain, that will be 2 pi into x naught. Okay, then Parseval's theorem. Okay, the Parseval's theorem, again energy questions can be related to Parseval's theorem. Energy is given by integral mod xt square dt. Okay, that is the basic formula that you study in the time domain, the energy of a signal. But as per Parseval's theorem, it is also equal to 1 upon 2 pi integral mod x omega square d omega. 1 upon 2 pi integral mod x omega square d omega. We will take question on this also. Similarly, for a power signal, okay, the power in the time domain, for a periodic signal especially, the power in the time domain is 1 upon t, okay, energy for one time period, that is 1 upon t integral minus t by 2 say t by 2. Integral minus t by 2 say t by 2 mod of xt square dt, but that is given by summation of mod ck square. Sir, what is the ck? Fourier series coefficient. Okay, so for periodic signals, we define the Fourier series also, and that I will cover up after this. Okay, so there this will be useful, but as a continuity of Parseval's theorem, मैंने बता दिया है. CK Fourier series coefficient, we will go to that also. Okay, now what are the important Fourier transform pairs? What are the important Fourier transform pairs? Okay, that you should normally know. See, like I have a question given to you, find the Fourier transform, we will calculate. Okay, questions on Fourier transform, we will solve the question, but there are some pairs which you should know directly. Not everything you will derive. So if you have really prepared the subject, there are some important signals whose Fourier transform should be known to you. Should be known to you. So for example, impulse. Unit impulse has the Fourier transform x omega 1. Okay, not only Fourier domain, guys. Any transform, whenever it is impulse, the transform will be 1, whenever, whatever transform we are discussing. Then duality say 1 having the Fourier transform 2 pi del omega. Okay. Then e power minus at ut has the Fourier transform 1 upon a plus j omega, one of the very common one. E power minus a mod t, 2a upon a square plus omega square. For both of them, a should be positive as per Dirichlet's condition. Otherwise, the Dirichlet's condition will fail. Okay. Agar xt की बात करें, then if it is t e power minus at ut, this is derived using txt formula. Not deriving right now, but txt wali property बताई थी. That turns out to be 1 upon a plus j omega whole square. Right. Unit step 1 upon j omega plus pi del omega. Okay. Unit step, which is the integral of x delta t. Okay, it is represented as integral of impulse, and that is how its Fourier transform calculated. Signum t 2 upon j omega. Signum t और unit step का relation भी याद रखना. Signum t is given by 2 ut minus 1, and accordingly its Fourier transform is also calculated. Okay, ठीक है. So 2 by j omega e power j omega naught t, the complex exponential signal will have the Fourier transform 2 pi del omega minus no omega naught. If you know for e power j omega naught t, you can also write down for sine and cos. So cos omega naught t pi del omega minus omega naught plus del omega plus omega naught. Okay, sine omega naught t pi by j del omega minus omega naught minus of del omega plus omega naught. Very very important, rect of t by t. Okay, Fourier transform sampling function t sampling omega t by 2. ये अगर आपको सिंक के फॉर्म में लिखना है, this is also equal to t sinc omega t by 2 pi. Why so? देखो, we know that whenever I say sampling theta function, sampling theta is known as sine theta by theta, and if I define the sinc theta function, that is known as sine pi theta divided by pi theta. So if you want to convert from sinc to sampling or vice versa, sinc theta is equal to sampling pi theta. Correct. Sinc theta, sin pi theta by pi theta means sampling pi theta. तो sinc theta है sampling pi theta. तो अगर sampling को sinc में convert करना है तो divide by pi आ जाएगा. So I divided by pi, and we can also write this in the omega domain, in the f domain. Okay, so this also now becomes t sinc of omega upon 2 pi is f. T sinc of ft. Okay. T sinc of ft. Okay, rect t by t. What is rect t by t? Standard definition है guys. A rectangle having the total width of t. A rectangle having the total width of t, that is minus t by 2 say t by 2. Okay, and having the amplitude 1. Okay, I've taken only one into rect, having the amplitude standard value 1, and it is a rectangle. Okay, from minus t by 2 say plus t by 2. Okay, similarly triangle. What is tri t by t? Tri t by t is a triangular signal which is having the total width 2t. Total width triangle में 2t लेते हैं, minus t से t, and triangle has the height 1, unit height. If there is some coefficient like 2, so I can take the height 2. Okay, but right now we'll take the height as 1. And there is a triangle from minus t say t. Total width 2t. Total width equal to the 2t. And the triangle has the Fourier transform given by t sampling square omega t by 2. T sampling square omega t by 2. Okay, then by duality, we know that rectangle has the Fourier transform sampling. The sampling will have the Fourier transform like rectangle by the duality property. Okay, even Ashok. If you only say rect t by t even, okay, see, it's very clear from here, na? ठीक है. Now, sampling AT की बात करें अगर, तो that will have the Fourier transform like rect, solved by duality pi by a rect omega by 2a. Similarly, sampling square AT will have the Fourier transform pi by a tri omega by 2a. Okay, and Gaussian pulse e power minus AT square will have the Fourier transform root over pi by a e power minus omega square by 4a. E power minus omega square by 4a. ठीक है. Now, out of them, see, these can be remembered by practice only. Okay, practice से ही आएगा sync. But now let me highlight, out of the properties also, my dear, which of the properties are really more important in terms of question? In terms of question, let me come up here. This one is going to be important. Okay, time shifting is moderately important. Okay, duality is very important for questions. Differentiation moderately important, integration भी ठीक है, frequency differentiation more important here, then frequency shift also okay, convolution, multiplication, modulation पे ये sampling वगैरह में इस पे अच्छे question बन जाते हैं. Okay, so then these symmetry properties are anyways important, I told you. With respect to the Fourier transform pair, okay, तो ये तो सारे याद होने ही चाहिए, that is why I have presented the list. Okay. So some properties are more important, so that I have highlighted for you. Now let's come back to the question number 1, and then let's keep continuing the question now. So dear, this is what? Okay, now if you look into the options, 2 of the options are directly ticked. Okay, because these are the standard results. Unit step having the Fourier transform 1 by j omega plus pi del omega, correct. Cos omega naught t or cos omega 1 t, any frequency. Pi del omega minus omega 1 plus pi del omega plus omega 1, ये तो correct है. C and D are correct. Okay, what about this one? What about this one? Okay, 1 upon pi t. This is basically related with Hilbert transformer theory. Okay, चलो वो भी यहाँ पे revise हो जाएगा. So guys, if I take up B ना, okay, we know the Fourier transform of signum function. Just now I told you what is the Fourier transform of signum function. The signum t is having the Fourier transform how much? Okay, it is having the Fourier transform that is 2 by j omega. Correct? Signum t का मुझे पता है. ठीक है. So some of you are telling B correct. Let us check. Now let's convert it to the time 2 upon jt. Okay. Omega की जगह j रखा मैंने. At least I want 1 upon t. ना pi तो constant है, that can be manipulated. ठीक है. So 1 upon ये हो जाएगा 2 upon jt. If I put omega equal to t, duality. Now duality says if you convert omega to t, this becomes a time function, and every time function has the transform. And what will be the transform? Okay, the original time domain signal you have to pick up, and there you should put t equal to minus omega. Okay, with the 2 pi multiplication, this is 2 pi signum minus omega. Now dear, what is signum minus omega? What is the signum waveform? Okay, for right side it is 1, for left side it is minus 1. यही होता है ना signum का waveform. For right side it is 1, for left side it is minus 1. Okay, ठीक है. That is even symmetry. That is clearly odd symmetry. Symmetry in first and third quadrant. That is clearly odd symmetric. And odd symmetric signal will be written as minus signum omega. X of minus t is minus xt. Odd symmetry है. यहाँ पे 2 से 2 cancel किया and bring the pi on the left side. That is what I want, ना? 2 cancel. Bring the pi on the left side. Okay, and shift the j on the right side. You have the Fourier transform minus j signum omega. You have the Fourier transform minus j signum omega. Okay, minus j signum omega. Clear? Minus j signum omega. ठीक है. Now this is what is known as the frequency response of a Hilbert transformer, pi by 2 phase shifter. It is nothing but a pi by 2 phase shifter. Okay, अगर if I say ht is equal to 1 upon pi t. चलो पहले option को mark कर लेते हैं. So option number B is wrong. Many of you are telling B, there is a minus sign difference. 1 upon pi t having the Fourier transform minus j signum omega. So we have to be careful. Okay, so this is wrong. Okay, and then option number A. Option number A, is it correct? I know 1 upon pi t. Okay, 1 upon pi t square. If you differentiate 1 by t, you get minus 1 by t square. Na? So we can use the time derivative property now. Okay, we can use the time derivative property. Okay, so we have 1 upon pi t, we are having the Fourier transform minus j signum omega. So when you differentiate 1 upon t, you will get minus 1 by t square. And what is the Fourier transform? Okay, of the derivative, it is j omega x omega. So there will be j omega into minus j signum omega. 1 upon t ka derivative minus 1 by t square. So this is what I want, minus 1 by pi t square. So Fourier transform is now j square. Okay, j square is minus 1, minus is already there, तो ये plus 1 हो जाएगा, तो omega signum omega. This is omega signum omega. Now what is omega signum omega? What is omega signum omega? Okay, by omega into 1, okay, for omega greater than 0, omega into minus 1 for omega less than 0. Okay, that means this is equal to, for positive frequency, it is omega, and for negative frequency, it is minus omega. ये किसका definition है dear? This is like modulus x definition. This is modulus omega. Okay, if it is positive, take directly. If it is negative, place minus sign so that minus minus becomes plus. It is just the modulus definition. Okay, so A option then I think is correct. Modulus omega बोला है. ठीक है, तो देखो C and D are direct. Such MSQ question बन गया. C and D are direct. A property based. Okay. ठीक है. B also you can remember because it's a Hilbert transformer case. Yes. तो मैं B के बारे में आपको कुछ बता रहा था. Okay, so I was telling you that. Okay, a system having the impulse response 1 upon pi t with the frequency response, okay, ht and h omega. So what is the frequency response? Minus j signum omega. Minus j signum omega. Okay, represents a Hilbert transformer. Represents the Hilbert transformer. Okay, this is the impulse response of Hilbert transformer. This is the frequency response of the Hilbert transformer. Correct. Now, when you want to analyze minus j, देखो, what is h omega basically? H omega is minus j, and minus j can be written as e power minus j pi by 2 signum omega. E power minus j pi by 2. E power minus j pi by 2. Correct. Because e power minus j theta cos theta minus j sin theta, cos theta 0 हो जाएगा, cos pi by 2 0, minus j sin theta, तो minus j will come because sin pi by 2 तो 1 होगा. This is the representation of minus j. Okay, so I can say that h of omega is equal to e power minus j pi by 2 if omega positive, but if omega negative, it will be minus e power minus j pi by 2. ठीक है. या इसको ऊपर से ही ब्रेक कर लेते हैं. ओके, आई कैन ऑल्सो राइट इट लाइक दिस. H of omega is minus j for omega positive, but if omega negative, it will become plus j because signum omega is minus omega. Okay, so now let me write this h omega as, now let me write down this h omega as e raised to the power minus j pi by 2 or e raised to the power plus j pi by 2. Okay, for negative omega, for positive omega. Okay, so if you want to write down the magnitude r e power j theta, r e power j theta. Okay, r e power j theta, r e power j theta. Okay, r is 1 for any of the frequency where positive, negative, r. Magnitude part is 1. Okay, it's all pass. Hilbert transformer is all pass. Hilbert transformer is all pass. Okay, and then what is the angle h omega? What is the phase? Phase can be, e power j theta. Theta is the phase, na? Phase can be minus pi by 2 or plus pi by 2. Okay, so angle part if you draw here, na? Okay, it is minus pi by 2 or plus pi by 2. Minus pi by 2 for positive frequency. Okay, for negative frequency it is plus pi by 2. That is why it is also known as a minus pi by 2 phase shifter. ठीक है, चलो डन है. Okay, so the correct answer for the question for the multiple select question is A, C and D. A, C and D. Now let's go ahead to the next question. We have revised important properties, important formula. ठीक है, question number 2. Come on, चलो question number 2. Yeah, yes, and it is definitely all pass because magnitude is constant for all frequency. Come on, tell me everybody. Very simple, but yet very expected. Property based. Okay, choose the correct statement regarding the CTFT of the two functions. Okay, and I think ये यहाँ पे missing है. This is also MSQ. I think ये missing है यहाँ पे. Check. This is also MSQ only. देख लेना. What about the signal F1T? Both of the signals are real. All the values are real, like 0, 1, 1, minus 1. All the values are real. But this is even also. So F1T is real and even. And what about the F2T? Symmetric in the first and third. Symmetric in the first and third quadrant. Okay, symmetric about this diagonal line. So it is odd symmetric. Okay, so this is real and odd. Now we know the Fourier transform property. You have to identify the graphs and then tick mark the correct answer. For a signal which is real and even, Fourier transform is also real and even. तो A correct है, B wrong हो गया. नहीं, C wrong हो गया. अब F2 की बात करेंगे. F2 real and odd. तो Fourier transform will be pure imaginary and odd. Okay, not the B, it is D. So again MSQ question A and D, basic property based. ठीक है, number 3. Let xt having the Fourier transform x omega be the Fourier transform pair. Okay, very basic property based question, but इस type के questions आते रहते हैं. Okay, what is the Fourier transform of minus 2x minus 7t plus 3? xt having the Fourier transform x omega. Then there is the shifting also and there is the folding also. Folding भी है, scaling भी है. Scaling, folding तो एक साथ कर लेंगे. Like I can say there is a shifting and scaling both. What to follow first? What do you follow in the basics when you are sketching the signal? What is the precedence rule? Suppose you want to sketch the signal which has both scaling and shifting. So what do we prepare first? कर दोनों सकते हैं. But there are two methods. But what is simple method so that you avoid error? Shifting first. Precedence rule में हम shifting को first रखते हैं. So if I apply the shift first, same thing I will do here also. And when I am shifting, I will forget this parameter. I will only think about shifting. I will forget that if there is any scaling or something. तो पहले shifting किया and time shift property will be applicable. And as per time shift property, it will be x omega e raised to the power j3 omega. T plus 3, so here also plus. Time shifting में same sign. E power plus j omega 3, j3 omega. Okay, now introduce this parameter. So now let me bring minus 7t plus 3 x of 80. Time scaling property 1 upon mod a. सारी प्रॉपर्टी हमने पढ़ लिया ना पहले ही. 1 upon mod a x of omega by a, but right side there are 2 omega everywhere. That is, we have to be careful. Everywhere you have to replace omega by a. Omega by minus 7. Okay, so this becomes how much? Okay, and then multiply by 2, multiply by minus 2 also. So minus 2 x of minus 7t plus 3. Okay, we'll have the Fourier transform. Minus 2 by modulus of minus 7 will be 7. Okay, x of minus omega by 7 e raised to the power minus j 3 omega by 7. ठीक है, So what is the correct answer? Minus 2 by 7 e power minus j 3 omega by 7 x of minus omega by 7. ठीक है guys, ये नीचे ही होगा. There's a typo error here. X will be downside only. Okay, ये x, it's not on the top. It will be here only. X of minus omega by 7. ठीक है. Answer is B. Very clearly the answer is B. ठीक है. Next question, number 4. Let xt be having the x omega be the Fourier transform pair, then what is the Fourier spectrum of the differentiated signal? Okay, Fourier spectrum of the differentiated signal. Fourier spectrum of the differentiated signal. Okay, MSQ question again. Fourier spectrum of the differentiated signal क्या होगा? By xt having the Fourier spectrum x omega. Okay, then differentiated signal d by dt of xt. What is the Fourier transform? j omega x omega. J omega x omega. ठीक है. Omega can also be written as 2 pi f. So this can also be written in the form of j omega is 2 pi f x of f. X of 2 pi f, but it is ultimately a function of f. So that is x of 2 pi f. So magnitude is definitely multiplied by 2 pi f. Okay, there is the magnitude spectrum which is scaled by multiplied by 2 pi f. Okay, and phase spectrum gets added by j. Now what is this j? J, as I explained you, e power j pi by 2. Minus j is e power minus j pi by 2 and j is e power j pi by 2. Okay, so there is an additional phase term also coming up. Okay, magnitude scaling by 2 pi f and there is a phase that is plus 90 degree. The phase spectrum gets added by 90 degree. Okay, so option number C and then option number A. ठीक है. D नहीं होगा, C and A. Plus 90 degree because it is plus J. ठीक है, it's A and C. Okay, the fundamental property. Okay, next question dear. Okay, determine the Fourier transform of the signal. Determine the Fourier transform of xt equal to d by dt of 2 t power minus 2 t ut. Now, you should know for t power minus 8 ut. You should not only start with e power minus 80. T power minus 80 उससे start करेंगे. So what I know, the Fourier transform for t e power minus 2 t ut, what it should be 1 upon a plus j omega whole square. 1 upon 2 plus j omega whole square. This is known. So now it is simple. Now it is simple. Okay. Now it is simple. Time derivative पे again d by dt of 2t. पहले तो 2 भी multiply कर देंगे. Okay. If 2 is constant, multiplied both the places. Okay. So for multiplied by 2, it looks like 2 upon 2 divided by 2 plus j omega whole square. Then d by dt. Okay. Differentiation in time corresponds to j omega in the frequency domain. And now match your answers. It's option number A, guys. It's 2j omega upon 2 plus j omega का whole square. Clear? 2j omega upon 2 plus j omega का whole square. चलते हैं next question की तरफ. Okay, what is the Fourier transform of the signal t e power minus 3 mod t minus 1? T e की power minus 3 mod t minus 1. T e power minus 3 mod t minus 1. What I should start with? ये good है. What I can start with? I can start with e power minus a mod t. E power minus a mod t having the Fourier transform 2a upon a square plus omega square. चलिए आंसर बताइए इसका quickly. 2a upon a square plus omega square. You can start with this and then some shifting properties applied. ठीक है, चलो. Do it up quickly. Just allow me a minute. Okay, so I hope you have done something. Let's check it out. What have you done it? Okay, yeah. So what is the Fourier transform of the signal t e power minus 3 mod t minus 1? Check करते हैं. 3 e power minus 3 mod t minus 1. Okay, जी. Okay, so you are given xt t e power minus 3 mod t नहीं है, mod t minus 1 है. First little bit manipulation we will do. Okay, little bit manipulation. There is a time shifting t minus 1. Okay, so what I will do is, let me write this also as t minus 1, but if I write minus 1, I will add plus 1 also, so that it remains to be t. Okay, and then I will start solving. Now it becomes t minus 1 e raised to the power minus mod e power minus 3 mod t minus 1 and then plus e raised to the power minus 3 mod of t minus 1. ठीक है, या नहीं और सिंपल कर देते हैं. Why to break into two step? एक ही स्टेप में कर देंगे. फॉरगेट e पावर माइनस 3 mod t से स्टार्ट करते हैं. e पावर माइनस 3 mod t 2a. ओके, 2a upon a square plus omega square. So this Fourier transform is 6 upon 9 plus omega square. Next, here only first let us apply the time shifting separately. कोई प्लस माइनस 1 की जरूरत नहीं, ऐसे ही कर लेंगे. So if I apply the time shifting here ना, t minus 1, what will I do? Time shifting corresponds to phase term there, exponential term there, e power minus j omega. Time shifting by only 1 divided by 9 plus omega square. Okay, now I am going to multiply by t. Okay, and what is multiplication by t equivalent to? T times property, frequency differentiation property. Frequency differentiation property, j d by d omega of the Fourier transform. Okay, j d by d omega of this Fourier transform. Okay, 6 e power minus j omega upon 9 plus omega square. इसको differentiate करना एक बार. Let's apply the numerator by denominator rule. Okay, 6 is outside. Denominator will be squared up. 9 plus omega square का whole square. Okay, then 9 plus omega square constant. E power minus j omega differentiation minus e power minus j omega. Okay, then minus e power minus j omega constant. 9 plus omega square differentiation 2 omega. E power minus j omega anyways constant. So this is going to be equivalent to 6j e power minus j omega. E power minus j omega constant लिया dear, तो you have minus यहाँ पे आ जाएगा minus 9 minus omega square and minus 2 omega divided by the 9 plus omega square whole square. Something like that. Okay, now let's see options कैसे arranged हैं. यहाँ options भी मिल जाएगा यहाँ से. One of them, अच्छा ठीक है, एक में से 9 plus omega square को divide कर दिया, no problem. Okay, if I can divide it ना, तो one of the term is minus 6j e power minus j omega. Okay, 9 plus minus को बाहर लिया, x upon x square, तो one of them is cancelled. Okay, then second one is minus 2. Okay, 2 into 6 12j, तो 12j e power minus j omega into omega भी आएगा divided by 9 plus omega square का whole square. Now you can go and match your answers. Okay, ये भी minus के साथ आ रहा है. Answer number A. Is there any extra minus that I missed by chance? नहीं ना. Denominator constant differentiation of e power minus j omega mod t minus 1 था, या t plus 1 था, t minus 1 ही है. Okay, j d by d omega of x omega. There is one minus sign which is coming extra and it shouldn't be. ये minus extra है ना? You are also telling A, but then where is the minus in this A? इसका minus कहाँ जाएगा रे? I have missed something. Let me check. Denominator constant differentiation of e power minus j theta है. Yeah, I missed this. The differentiation of e power minus j omega is minus j e power minus j omega ना? The coefficient being minus j. I'm sorry. Okay, so now there will be minus. Yeah, ये यहाँ पे आ जाएगा. There is the minus j outside आएगा. ठीक है. And when you take minus j outside, it becomes j square. J square is minus 1 and that is why correct. 6 e power minus j omega upon 9 plus omega square minus 12j omega e power minus j omega upon 9 plus omega square whole square. This can be a good 2-marker question. Property based है काफी. Okay, so correct answer is A only. Yes. Correct answer is A. Everybody okay? Everybody okay? Okay, and yeah, some of you are already giving A. Good going, guys. Good going. Next question, number 7. Okay, a signal is represented by xt equal to 1 for mod t less than 1 and 0 for mod t greater than 1. What is the Fourier transform of the convolved signal x of 2t convolution x of t by 2? Okay. हाँ, that also. Jayesh, पहले मैं वैसे ही start कर रहा था, but I thought this can be easy because ultimately there also you have to apply t times property. वो तो करना ही पड़ेगा ना. मतलब somehow differentiation has to come. Somehow that differentiation has to come. But that's also okay, Jayesh. Now tell me, come on, guys. Look into it. First of all, tell me what the signal it is. What is the signal xt? Xt is equal to 1 for mod t less than equal to 1. Mod t less than 1. Mod t less than 1 means magnitude of t less than 1 means t is between -1 to 1. Okay. Okay, -1 to 1. Okay. Any value -1 to 1, mod t will be less than 1 and the value of the signal is 1 in that case. So what is the signal xt? Now can you define? So Varun, if you see from the beginning, it's not only question, I have given the important concepts also revised, properties, concepts revised है, उसी तरीके से ही कर रहा है almost. Okay, but approach is backward. And no other signal marathon for this year. Let me make it clear, don't wait. Okay, already 51 question, ये भी long होने वाला है, तो be very honest. If you are comfortable with this mode, attend. There is, at least for this gate examination, only 10 days now left, almost. Okay, there is no other signals marathon will be there. Okay. जो है वो यही है आज. ठीक है जी, चलिए आ जाते. After this, some random question practice sessions will keep happening for you. देख लेते हैं. What is the signal? So it's a clearly rectangular pulse. It is clearly a rectangular pulse. Okay, and that is having the width of 2. That is having the width of 2. Amplitude is 1. Width of 2. Rect of t by 2. This is known as rect of t by 2. Clear? This is the rect of t by 2. Done है. चलो बढ़िया है. Rect of t by 2 हो गया ये. It's only rect of t by 2. Done है. Total width 2 है ना. That is why rect of t by 2. Now we know the Fourier transform for rect t by t. Rect t by t. Having the Fourier transform t sampling omega t by 2. Correct? Very, very important pair I highlighted. Okay. So if this is xt, what will be x omega? Rect of t by t. That is t. That means 2. T is 2 here. 2. Sampling omega t by 2. Okay, 2 से 2 cancel. It is 2 sampling omega. It is 2 sampling omega. This is known as the 2 sampling omega. Okay, चलो. Yes, DFT भी करेंगे आकांक्षा. Okay, तो x omega is 2 sampling omega, but now I need the Fourier transform of the convolved signal. Okay, so now y of t is given as x of 2t, convolution with x of t by 2. So again, some properties are coming up here. Convolution in time corresponds to multiplication in frequency. So whenever you calculate y omega, it will be the multiplication of the Fourier transform of these two. So what is the Fourier transform of x to t? Time scaling will come. X a t, 1 upon a, x of omega by a. Okay. 1 upon mod a, x omega by a. Convolution will be represented now by time and then 1 upon half x of omega by half. Time scaling property applied. Okay, so yeah, half and 1 upon half get cancelled. So your answer y omega will be in the form of x omega by 2 multiplied by x of 2 omega. This is omega by half, that is x2 omega. What is x of omega by 2? X omega is 2 sampling omega. So this will be 2 sampling omega by 2 into 2 sampling 2 omega, and this becomes 4 times. But now you see none of the options are in sampling, but they are in sine form. No problem. Sampling theta is sine theta by theta. Okay, so this becomes sine omega by 2 upon omega by 2 multiplied by 2 to the 4. Already कर दिया ना? कर दिया. Okay, sine 2 omega divide by 2 omega. 2 से 2 cancel किया. So this is equal to 4 sine omega by 2 sine 2 omega is divided by omega square. Is divided by omega square. Sine omega by 2 sine 2 omega divided by omega square. Answer is A. Answer is A. Take it, done a property based question. Next question now, dear. Everybody, next question. Number 8. Consider the signal xt equal to 1, mod t less than 1 and 0 otherwise. Same. So, let's not sketch it again, but this xt is again. Okay. Xt is again right. Chalo, इसको छोड़ दीजिए. Find the Fourier transform of the signal yt as shown below. Find the Fourier transform of the yt as shown below. इसको देख लेते हैं. What is the Fourier transform of this signal? It's a straight line. Okay, but from -1 to 1. Okay, there are two methods here. Definitely there are two methods here for this question. Okay, definitely there are two methods here. Method number 1. Okay, by the direct formula. X omega is integral minus infinity से infinity. Okay, but -1 से 1 होगा यहाँ पे. Rather than minus infinity to infinity, -1 to 1. The signal is only from -1 to 1. xt. What is xt? अच्छा, how do I define this xt? How do I define this yt? या जो भी बोल दीजिए. This is a straight line having slope equal to height. Height हुआ यहाँ तक 1, base हुआ यहाँ पे 1, base भी हुआ 1. Okay, so height upon base, slope is 1, passing through origin. So this is nothing but t. mx plus c लिखेंगे. m1 है, c1, c0 है. ठीक है. देखो, this is equal to t. So xt का value, the signal value is t. Fourier transform integral minus infinity से infinity xt e power minus j omega t. So in place of the signal, I wrote t and limit is -1 to 1. Okay, this is method number 1. You can complete this. Okay, I will follow more logical and tricky approaches. ठीक है, ये भी हो जाएगा. Integration by parts. This is also going to be not difficult. This will be simple. Only integration by parts you will apply because the product of two function is coming up. Product of two function is coming up. But if you see the signal carefully now, okay, I can say that this signal yt is equal to t as I already explained you, but only, not always t. It is -1 less than equal to t less than equal to 1. And is 0 otherwise. Other than that तो exist नहीं कर रहा है ना. Other than that it is 0. Okay, other than that it is 0. So इसको ऐसा लिख लेते हैं. -1 to 1 means mod t less than equal to 1, and for mod t greater than 1 the signal is 0. Now, what is this signal equivalent to? t. तो t into 1, नीचे है 0 तो 0 into 1 लिखा मैंने. Oh, sorry. नीचे है 0 तो let me write it as t into 0. Now, forget this t part. Forget the t part. What is this signal equivalent to? t को भूल जाइए एक दिन. Okay. ठीक है. Forget the t. What is this signal? Signal which is equal to 1, mod t less than equal to 1, 0 otherwise. Constant 1 for -1 to 1. Rectangular pulse like the last question. Okay. The same rectangle for reference also given. ये देखो, this may not be given also, but यहाँ पे given है. चलो, यहाँ पे given है. So what is this? It is rect again. Rect of t by कितना? Last question में लिया था rect of t by 2. -1 से 1 है तो total base 2 हो गया. Okay. So this part is already rect. Okay. So what is yt? What is yt? ये थोड़ा सा बेटर है क्योंकि यहां से अब आप बस क्विकली कर लोगे. एक प्रॉपर्टी अप्लाई करना पड़ेगा. That is t times property. That is the t times property. Because we know what is the Fourier transform for rect t by 2. That is 2 sampling omega. अभी solve किया था. So when you multiply by t, there will be the frequency differentiation property j d by d omega of sampling omega. Let me write down for differentiation. Let me write down the sampling as sin omega by omega. So this becomes 2j differentiate किया denominator omega square, omega constant, sin का differentiation cos minus sin omega constant, omega differentiation 1. That should be your answer. Okay, so 2j तो होगा ही. Okay, cos omega by omega. करेक्ट. ओमेगा डिवाइड किया माइनस साइन ओमेगा बाय ओमेगा स्क्वायर. आंसर इज बी. फटाफट आंसर इज बी. एवरीबॉडी करेक्ट. श्वेता आंसर इज बी. डन है. यस जयेश अशोक करेक्ट आंसर इक्वल टू बी. वाईटी इक्वेशन राजीव देखो ना, स्ट्रेट लाइन है. हाउ डू यू राइट डाउन एनी स्ट्रेट लाइन? भाई x एक्सिस पे t है तो इट शुड बी इन द फॉर्म ऑफ mt प्लस c. y इक्वल टू mx प्लस c, बट x नहीं, इट इज अ फंक्शन ऑफ टाइम. तो mt प्लस c. c क्या होता है? y इंटरसेप्ट. इट इज पासिंग थ्रू ओरिजिन तो y इंटरसेप्ट 0. m क्या होता है? स्लोप. स्लोप हाइट ऑफ दिस सेक्शन अपॉन बेस ऑफ दिस सेक्शन. 1 आया ना स्लोप, तो स्लोप इक्वल टू 1. ये है m. ठीक है. सो दैट इज वाई इट इज इक्वल टू t. m 1 है तो 1 इंटू t प्लस 0. इट्स इक्वल टू t. डन है. नेक्स्ट क्वेश्चन पे आएंगे. Here it is, number 9 for you. Okay, again fundamental property. Yes, Ankit Kumar, correct answer. And guys, let me check how many of you have put your attendance by now. Okay, attendance is not only watching, but attendance is, okay, enjoying, listening, concentrating, understanding. That is the attendance. So, attendance for that concentration. Okay, if you're following, if you're enjoying, that attendance is a like button. Okay, hit the like button and let's at least touch the 100 attendance, guys. Come on quickly. Let's be reaching the 100 attendance, and it's a simple question, 2 parts here. So you will feel that actually today more than 51 questions will be there. Not only this, आगे भी आप देखोगे, there will be some parts in different question. Okay. So उसको मैंने एक ही count किया, so effectively more than 51 questions होगा आपके लिए आज. ठीक है? चलो, tell me the very simple answers here. Okay, what is x of 0? Wait, what is this? Very simple question eventually. X of 0, the value of the Fourier transform at omega equal to 0, and this was known as the area under xt, and xt is given to you. Okay, what is the area under this xt? Now, देखो, you may calculate this square area, square or rectangle, जो भी हो, rectangle, then this is a trapezium, this also is a trapezium. But better है, area को आप और simple कीजिए, rather than different parts. Let us assume it to be entirely flat. इसको पूरा flat कर देते. Although there is a depression, but forget, I can assume it to be entirely flat. If it was flat, then it becomes a rectangle, and the area of rectangle will be height multiplied by the base. Base is -1 से 3, हो गया 4. Only thing is there is a difference, there is a depression, there is a cavity. So how much of the area of this cavity that will be reduced here? वो area reduce करेंगे, and that is a triangular shape, half into base. Base देखिए, base है 2 तक. And height of this triangle exclusively 1 से 2, height of this triangle will be 1. Okay, so the answer is 8 minus 1, 7. The first answer is 7, everybody. ठीक है? Yes, Ashok, Ananta, correct answer. Second तो और easy है. Okay, what is the area under x omega? Area under x omega was given by a 2 pi factor additionally, 2 pi x naught. 2 pi x naught. 2 pi x naught. 2 pi into x0, the value of the time domain signal, initial value at t equal to 0. T equal to 0 पे value of the signal है 2, so 2 pi multiplied by 2, and answer is 4 pi. Now some of you were giving answer as only 2, wrong. 2 नहीं है, 4 pi. 2 pi into 2, it is 4 pi. It is equal to the 4 pi. Done है? Done है, good. Next question then. For the function gt, a good question again. It is given that integral minus infinity to infinity gt e power minus j omega t is omega e power minus t omega square. So dear, what is this given to you? Sometimes they don't directly say their expressions. They want you to understand. अपनी ना feelings को वो indirectly बोलते हैं. भाई, what is this expression? They are telling for a signal, for a function, integral gt e power minus j omega t dt. And that is nothing but a Fourier transform formula. That is nothing but the Fourier transform formula. So what is this? This is g omega. That is nothing but the Fourier transform of the signal gt. ठीक है ना? So what is given to you is g omega is omega e power minus 2 omega square for any real value omega. It is also given that yt is integral minus infinity से t g tau d tau. Okay, integration property. By now integral minus infinity से t g tau d tau has the Fourier transform g omega by j omega plus pi x0 del omega, where del you know is the impulse signal in the frequency domain. G omega by j omega plus pi x0 del omega. Done है? Okay, so let me put down the value. Okay, pi x0 nahi, pi g0, because we have integrated g. So of course pi g0 del omega. Okay, so what is this? G omega, omega e power minus 2 omega square by j omega plus pi g0. Acha, what is going to be g0? Omega की value 0 रखोगे यहाँ पे जरा. Okay, the answer itself is 0. So this part is 0 only. Okay, so omega cancel kare, so you have y omega as e power minus 2 omega square by j, and 1 upon j is minus j na. तो सीधे लिखते हैं minus j e power minus 2 omega square. Now the next part is, dear, what is this? Integral minus infinity से infinity yt dt is y0. Area under yt is y0. Value of Fourier transform at omega equal to 0. That is minus j e power 0, omega की जगह 0, तो answer is minus j. Answer for the question is minus j. B is the correct answer. Why I called it as good? Mixture of properties you should be able to relate. Okay, one is the basic integration property and one is the area under curve property. ठीक है, बढ़िया है, good है. Next है number 11. What is the energy, okay, of the signal sampling 2 pi t? Very common question. Okay, very common question. Let me take sampling 80 basically. थोड़ा और generalize करके चलेंगे. Okay, consider the signal xt which is sampling 80. Now for this signal dear, when you go in the time domain ना, अगर time domain से जाओगे integral minus infinity से infinity, okay, modulus ये sin is sin, sampling is sin theta by theta. Okay, तो it's a real function anyways. Okay, so जब square लोगे तो anyways positive आएगा. No need to apply the modulus. Sin square 80 upon a square t square dt. That is what is the energy formula time domain से अगर solve करें तो integral x mod xt square sin square 80 upon a square t square. Now you keep solving this integral. You will be just stuck. Just try, keep solving this integral. You will not be able to come up to an answer in any short amount of time. Okay. For such cases, we will apply Parseval's theorem. For such cases, we apply Parseval's theorem. Okay. So if we solve the problem in the frequency domain में क्या आएगा? Parseval's theorem आएगा. What will be the energy? It will be given by 1 upon 2 pi integral minus infinity to infinity modulus of x omega whole square d omega. But what is that x omega? For sampling 80, we know Fourier transform pi by a rect of omega by 2a. Pi by a rect of omega by 2a. Clear? Pi by a rect of omega by 2a. Now what is this Fourier transform? चलो अगर इसका एक बार sketch ले आए. Rect of omega by 2a. Rectangle pulse. Okay, having the total width 2a. That means minus a 2a. Total width is 2a. Minus a 2a. Total width 2a. And amplitude is pi by a. Amplitude is pi by a. Okay, amplitude is pi by a. Pi by a rect omega by 2a. Okay. Chalo. So if I complete this calculation here, 1 upon 2a. But integral minus infinity से infinity की जगह you will be getting the integral minus a to a. But within that x omega is constant, pi by a. So you will be left with pi by a square d omega. Pi by a constant है, outside कर देंगे. Pi square by a square. D omega का integral omega and upper minus lower limit a minus minus a will be 2a. Solving it completely ना, 2 cancel होगा, 1 of the pi cancelled, 1 of the a cancelled, you will be left with only pi by a. Okay, remember, so that can be a important formula for you. Okay, whenever you have xt which is in the form of sampling 80, you can remember its energy as pi by a joules. Correct? Acha, similarly, if there is the signal which is in the form of sampling square 80, अगर वो सिंक के फॉर्म में तो आप खुद ही कन्वर्ट कर लोगे, sampling square, then you will get the energy dear 2/3 of this, 2 by 3 pi by a. Okay, again by Parseval's theorem it can be deduced. Okay, so you can write down both the results. You can write down both the results. So here what is the answer? Here what is the answer? Pi by a, pi upon 2 pi, 1 upon 2 or 0.5. The energy of the signal 0.5 joules. Sampling 80 is a regularly asked question, so you can remember even the energy, pi by a. Sampling square 80, 2/3 of pi by a. Okay dear. Chalo, done hai. Next question. Now, again MSQ, but filter-based questions are also very important. Okay, some filtering-based questions are all very important. Consider an LTI system. Consider an LTI system whose magnitude and phase response are given to you. Okay, the input to the system is given to you. 3 plus 2 cos 2t plus 3 sin 3t. Okay. 3 plus 2 cos 2t plus 3 sin 3t. Which of the following are correct? Now, this is the input, okay, to a LTI system, or you can call it as filter as well, okay, which will be only accepting the frequency up to 2. It's not an ideal low-pass filter. Okay, it will accept the frequency up to 2, and after that, the gain is 0. Okay, and it has some phase, okay, which is a linear function of frequency. Okay. Acha, can you tell me, dear, can you tell me just a conceptual question? Suppose if I give you the system, a filter with these characteristics. Okay. Is it distortionless? If no, what sort of distortion it will suffer? There are two types of distortion, amplitude distortion and phase distortion. Is it distortionless? तो say ये distortionless है. If it is distorted, तो what sort of distortion will come? Amplitude distortion, phase distortion या both? Tell me. एक concept revise करते हैं यहाँ पे, and then let's come solve the questions also. चलो पहले क्वेश्चन को सॉल्व कर लेते हैं. सो आई हैव गिवन अ क्वेश्चन टू यू. थिंक अबाउट दैट कॉन्सेप्ट एंड लेट मी नो. अब देखो इनपुट. ओके, लेट्स टॉक अबाउट द इनपुट विच इज 3 प्लस कितना है 2 cos 2t प्लस 3 sin 3t. नाउ व्हाट अबाउट द ओमेगा हियर? दिस इज अ कांस्टेंट डीसी टर्म. ओके, cos omega t, omega is 2, and sin omega t, here the fundamental frequency omega is 3. Now, you are able to clearly say that at omega equal to 0, na? Okay, at omega equal to 0, okay, what is the modulus of h omega? The magnitude of the system is 0. It will be passing this term but with a 0 gain. It will be passing this term with a 0 gain. So, ultimately, it will be blocked only. It will not be passed. Okay, similarly, omega equal to 3 पे, when you see the magnitude of the system, that is 0. For any frequency greater than 2, वो तो reject होने वाला है. That is in the reject band. Okay, ये तो आ गया reject band में. Okay, every filter has a pass band and reject band. So this is in the reject band. Okay, omega equal to 0, gain is 0, so that is also rejected. Okay, only thing you have to take care is about this omega equal to 2. Okay, at omega equal to 2, what is modulus of h omega? That is very clear 10. Okay, that is very clear 10. अच्छा, if there was any other intermediate frequency, तो वहां पे magnitude कितना होता? Then you can find by equation of line or find by the slope. But here it is only required at omega equal to 2, and that is directly the maximum gain, that is 10. Okay, in the other two cases, magnitude is 0, so that is why I'm not worrying with the phase. Why, how do you write down any number is r e power j theta? But dear, अगर r ही 0 है, तो entire answer is 0. Okay, so that is why don't worry about the theta. But here you have a non-zero magnitude. Okay, here you have a non-zero magnitude. So what is the angle h omega? At omega equal to 2, angle is minus pi. ये भी दिख रहा है. Angle is minus pi. Clear? There will be a phase shift corresponding to minus pi. So what is the output corresponding to this signal? Okay, the first part is not passed. Second part, the gain is 2. The input magnitude is 2 multiplied by the gain of the system. The phase of the input is 2t. Cos theta, theta is 2t. There will be a phase shift of, minus pi tha ye. There will be a phase shift of minus pi. That is introduced by the system. And third is again 0. Okay. Now cos theta minus 180 या cos 180 minus theta कुछ भी बोल लीजिए. Cos 180 minus theta second quadrant है, minus cos theta, cos is negative, तो ultimately आ जाना चाहिए minus outside, तो minus 20 cos 2t. Output should be minus 20 cos 2t. Minus 20 cos 2t. The output is, हाँ ऐसे भी लिख सकते हैं, cos 2t minus pi into 20. Yeah, this is also correct expression. The power of the output ये बता दीजिए. Impulse response of the system. Impulse response of the system. And the frequency response of the system is conjugate asymmetric. चलो ये थोड़ा सा यहाँ पे मेहनत लगेगा, करते हैं इसको भी. So this is correct. Okay, now what is the power? By for any sinusoid, whatever be the phase, power is given by a square by 2 na Okay, 20 square 400 by 2 200 200 यूनिट पता है वॉट्स होना चाहिए, तो ए और बी तो करेक्ट हो गया डियर, ए और बी बोथ करेक्ट है. ओके, what is the impulse response of this system now? अच्छा नहीं निकालना नहीं, is real. Okay, it is very simple now. It is very simple. देखो now property है. I thought calculation है उसमें time लगता, but ये देखिए, they are only asking whether the impulse response is real or whether the frequency response is conjugate symmetric. Pay attention dear. Okay, the magnitude response, isn't it a even function? On the right and on the left it is identical. Property भी mix हो गया यहाँ पे. This is a real function. And what about the phase response? Symmetric in the second and fourth. Whenever there is symmetry in first and third, or whenever symmetry in second and fourth quadrant, that is an odd symmetric function. This one is odd symmetric. अब ध्यान रखना. What are some properties that whenever xt is real? I told you up to this much na. Whenever xt is real, x omega is conjugate symmetric. ये तो पता ही है हमें. Okay, x omega, okay, which can be broken as modulus of x omega e raised to the power j angle x omega, whenever this is conjugate symmetric na dear. Wait, what is the meaning of conjugate symmetry? Chalo, one line mein. X minus omega is x conjugate omega. Okay, put down x minus omega here. Okay, x minus omega, तो modulus x minus omega e power j angle x minus omega, ये हो गया x minus omega is equal to conjugate r e power j theta का conjugate r e power minus j theta. R e power minus j theta. Now these two are equal. अब अगर ये दोनों equal हैं, तो what is the result you are getting? You are getting that modulus of x minus omega is modulus of x omega. So what is the condition on magnitude? And face to face equate करेंगे, तो angle x minus omega is minus of, वहां पे face है minus of angle x omega. So whenever a signal is real, Fourier transform conjugate symmetric, ठीक है, and if the Fourier transform is conjugate symmetric, its magnitude part, okay, will be even function. देखो ना, minus omega को replace करके same result आया. And face, when you replace minus omega, you get minus outside. Angle x minus omega is minus angle x omega. That is the definition of odd function. Magnitude is real and face is odd. And what is given here is magnitude is real, face is odd. Okay, magnitude is real. ठीक है, ये given है यहाँ पे. Given means we are able to visualize. So I can say that the h omega is conjugate symmetric. The complete h omega, okay, the Fourier transform frequency response h omega is conjugate symmetric. No, not anti-symmetric. Anti-symmetric means minus. नहीं. So D is wrong answer. It is conjugate symmetric. Okay. अच्छा, how is the h omega conjugate symmetric? When xt is real. Xt means ht here. Okay, so the time domain signal ht, which is the impulse response, should be real. It should be real. So C correct हो गया dear. C correct हो गया. Impulse response is real, and if impulse response is real, frequency response is conjugate symmetric, anti-symmetric नहीं. तो A, B, C. So very good question. Filtering भी आ गई यहाँ पे और थोड़ा property भी mix हो गया, isn't it? Filtering and property both mixed. Okay. चलो डन है. Next question. ये था good one. Now based on filtering, okay. One more important question, specially taken from GATE, just to give you a highlight कि इस type के question भी आ सकते हैं, but this is again simple only. A continuous time signal xt4 cos something, that is a signal, okay, is input to a linear time invariant LTI filter given है with the given impulse response. Now what is this given impulse response? Please try to understand. What is this given impulse response? Okay, 2 sine, okay, 300 pi t upon pi t. So if there is 300 in the denominator, if there is a 300 in the denominator, then I can write sampling na sin theta by theta. So 300 divide and multiply karenge to 2 into 300 sin 300 pi t divide by 300 pi t, and sin theta by theta is sampling, so this is 2 into 300 600 sampling 300 pi t, 600 sampling 300 pi t. Okay. Acha, what is the value of sampling 0? What is the value of sampling 0? Always remember, dear, sampling 0 jab bhi aayega na, we know that sampling theta is sin theta by theta, but when you put 0 na, so it becomes the sin 0 by 0, and that is why we solve it using the theta tending to 0 case. Okay, limit theta tending to 0 sin theta by L Hospital rule. Okay, and one of the very standard rules of limit, this is always 1. Okay, the sampling 0 ka value 1 hoga, so 600 into 1 is 600. Even if this is not mentioned, it is understood ki t equal to 0 pe value 600 hoga, but for clarity they have specified. So basically jo impulse response given hai aapko, that is like 600 sampling 300 pi t. Sampling 300 pi t. So what is going to be the h omega? What is going to be the h omega here? What is going to be the h omega here? Okay, so sampling 80, देखो 600 को अलग रखते हैं. Sampling 80 Fourier transform अभी पढ़ा था हमने, pi by a. Okay, rect of omega by 2a, and then I will start sketching. Rect of omega by 2a हो गया 600 pi. So this is basically pi cancel, 600 by 300, that is 2. Rect of omega by 600 pi, and if I sketch it, okay, rect of omega by 600 pi, total width 600 pi, total width will be 600 pi. Okay, so some minus 300 pi up to the 300 pi. And having the amplitude of 2. Okay, having the amplitude that is equal to 2. So what is this? This is basically what is a ideal low pass filter. What is this given to you is basically the ideal low pass filter. Because for any frequency up to 300 pi, the gain is 2. Matlab all the frequencies up to 300 pi will be passed, that too with equal gain, and any frequency after 300 is clearly rejected. So it passes all the low frequencies up to 300 pi and rejects thereon. That is why it is a low pass filter. Ideal because the gain is constant up to the cutoff frequency. This is known as the cutoff frequency. This is the cutoff frequency. Now please notice here, the magnitude of the system is constant for the given frequency range, जो भी desired frequency range है, and this system does not suffer amplitude distortion. मैंने एक और question पूछा था ना previous question में. In the previous question I asked you what sort of distortion will be there. See, what is the distortionless condition? What is the distortionless condition? A system is distortionless if its magnitude response is constant for the given frequency range. If its magnitude response is constant and phase response is a linear function of frequency. Okay, so this is a linear function, straight line है ना? Okay, but magnitude was not constant, and that is why it suffers amplitude distortion. Previous question में मैंने पूछा था. Okay, so answer was amplitude distortion. चलो, yeah. Now the intentionally gate question taken. अब देखते हैं यहाँ पे. So that to give you an idea of gate variety as well from the filter. 4 cos 200 pi t, xt given है now. 4 cos 200 pi t plus 8 cos 400 pi t. Now first of all, if this is the input to the filter, look into the frequency components. Okay, cos omega t, this is omega which is 200 pi and that is less than the cutoff frequency. That is less than the cutoff frequency, so it is going to be passed. ये pass band में है. Okay, but the frequency of the next component of the input is 400 pi, which is greater than the cutoff frequency of the filter. So this is going to be rejected by the filter. That's what filter will do. It will filter out specific frequency. Okay, so what's going to be the output then? Okay, now the gain, okay, of the magnitude of the input is 4, but this is in the pass band. And what is the gain of the system? It is 2. Okay, and it is 4 2. Okay, then 8. Sorry, 4 2 is 8 ho jayega, cos 200 pi t, and the next term will be 0. That is in the reject band, that is not appearing in the output. So the output yt is 8 cos 200 pi t. Question kya pucha hai? What is the maximum value of modulus yt? That is 8. Cos theta minus 1 to 1. So minus 8 से 8 इसका range हो गया. Maximum value of mod yt is 8. Okay. So ये generally याद रखना वाला, such terms can be important. When I take, okay, h omega equal to 1. यहाँ पे 2 था. Gain can be anything, but let me normally take it as 1. H omega equal to 1. Okay, from minus omega c से plus omega c. Any cutoff frequency minus omega c say plus omega c. Omega c is the cutoff frequency. Any frequency can be given to you. Okay, and within that frequency range, h omega is constant 1 and 0 otherwise. Okay, 0 outside it. Okay, this h omega, yeah, especially this modulus of h omega, phase also can be given, but yeah, even if this magnitude is given, this represents ideal low pass filter. Ideal low pass filter. Okay, अभी मैं h omega ही ले लेता हूँ. So if this h omega is given, that is ideal low pass filter, and ht will be in general omega c by pi sampling omega ct. Omega c by pi upon sampling omega ct, impulse response of ideal low pass filter with the gain equal to 1. Okay, this will be the impulse response of ideal low pass filter. Okay, this is the frequency response. This will be the impulse response of ideal low pass filter with the gain 1. Gain to baad mein 2, 3 can be given anything, but I have taken the standard gain of 1 to define the basic definition. So whenever you see this particular form, sampling omega ct, any constant can be there. Constant se to gain change hoga, forget. Sampling omega ct, if the impulse response is sampling omega ct, that represents a low pass filter, ideal low pass filter. Okay. So very commonly questions come up with these, signals given to you. With these signals given to you. Okay. Chalo. So a quick revision of, continuous time Fourier series representation, and then some questions based on that. And there will be some questions based on that. CTFS representation of a continuous time periodic signal. And we know that, there's a term J missing up here. There's this term J missing up here. So the Fourier series is represented in the form of summation Ck, exponential Fourier series le raha hu pehle mein. Then we will come to trigonometric form also. Okay, any signal xt, okay, not any, only periodic signals, that too following the Dirichlet's condition. Okay, nahi band pass kaise tha? Nahi Viray, it is low pass. For filters we only consider defining the bandwidth and defining the range, we only consider positive frequency, na Vinay? That is low pass. Band pass कैसे हुआ? Band pass तो ऐसा होगा. This is a band pass filter. Okay, this represents a base band pass filter. Okay. ठीक है, यहाँ जाते. Okay, so we break any signal as a summation of complex exponential terms e power jk omega naught t. Okay, summation ck e power jk omega naught t. Okay, for all values of k will be the continuous time Fourier series of a signal. यहाँ पे k term missing था, यहाँ पे k लिख दिया, यहाँ पे k लिख दिया. Omega naught can also be written as 2 pi by t. Okay, that is what is the Fourier series representation. And this Fourier series, okay, to define the Fourier series of any signal, we should have the Ck, that is the Fourier series coefficient, and they are given by the formula 1 upon t integral over one time period. Okay, integral over one time period xt e power minus jk omega naught t dt. This integral over one time period, we have to look into the signal. We can take 0 se t also, okay, or we can take it as minus t by 2 say t by 2, or in general any one time period. Signal is periodic, so any one time period will give the similar result, but we take it either 0 say t or minus t by 2 say t by 2. यही दो pattern follow करना. Which one based on signal, how would the signal is spread, what will be simple for integration, वो ले लेंगे हम लोग. ठीक है. Ck 1 upon t integral one time period xt e power minus jk omega naught t dt. Okay, now I will tell you the very simple shortcut to find Ck. Because I'm telling you, na, Fourier transform is one of the very important topic, be you are from EE or whether you are from EC. And all important properties in Fourier transform pair you should always know. And if you know it, na, जैसे क्वेश्चन भी सॉल्व कर रहे थे अभी उसके बेसिस पे, इफ यू नो इट देन CK is just one step ahead for you. What is that shortcut वो मैं बताऊंगा, what is that shortcut I बताऊंगा, but first of all, okay, for the CK to be valid, okay, first of all, for the CK to be valid, have a look into it. Okay, again the Dirichlet's condition will come, very similar to what we were discussing in Fourier transform. Only thing is, whatever observation we will do for the one time period of the signal. Xt should be absolutely integrable. Dirichlet's condition pe aa gaye over any one time period. Okay, that means integral mod xt dt, absolute integration for one time period only, should be a finite answer. Okay, again the same too as we have seen in Fourier transform. Okay, now next. Okay. This CK, as I'm mentioning you, the CK, okay, are defined as the continuous time Fourier series coefficients. Okay, are defined as the continuous time Fourier series coefficient. Okay, the C0 will be the DC term or the constant component. Okay, the C0 will be the DC term or the constant component, because when you expand this actually, when you are going to expand this xt in this summation minus infinity to infinity, let us consider some of the terms. Suppose C minus 1 e power minus j omega naught t. Next will be C naught e power j 0. So e power 0 will be 1. That is why I call it as a DC term. It corresponds to zero frequency term. Okay, then there will be C1 e raised to the power j omega naught t. There will be the C2 e power j 2 omega naught t corresponding to the frequency 2 omega naught. Okay, there will be the term C3 e raised to the power j 3 omega naught t, and etc, out of which the C0 corresponds to omega 0. Okay, and we call it as the DC component. Okay, or also we call it as the constant component of the signal, and it is also known as what? देखो, it is also known as C0 is 1 upon T. देखो भाई, C0 का फॉर्मूला कितना हो गया? ओमेगा को यहाँ पे भी K को 0 रखा तो इंटीग्रल xt dt over one time period. Okay, so 1 upon T integral xt dt over one time period. Okay, integral of xt over one time period divided by the length of the interval. That means you are averaging that particular signal for one time period. Okay, the question can also be in terms of average value. C0 is also known as the average value of the signal for one period, because integration is for one period. Okay, calculations में when the question comes, I will tell you the different variety of expected question from Fourier series. अभी वो extend करेंगे हम. Okay, C0 can be written as 1 upon T integral xt dt. Integral xt dt is area under xt, okay, for one period. Area under xt for one period. Area under xt for one period. Okay, so when you take k equal to +1 or -1, the frequency that will be coming is the fundamental frequency, and they are known as the fundamental components. कभी कभी इस पे language आता रहता है तो पता होना चाहिए. Suppose when I took k equal to 1, okay, I get omega naught, the frequency corresponding to omega naught. Okay, so here omega corresponds to omega naught, fundamental frequency. Here omega corresponds to 2 omega naught. Next term में omega that is coming up in the power, that is 3 omega naught, and etc. Okay, so when you take k1 or -1, okay, we have minus omega naught, that is the fundamental frequency term. Okay, they are known as the fundamental components. They will be the fundamental components, k equal to +-1. And for k equal to ±n, you get the frequency which is n omega naught, and they are known as the nth harmonic component. Nth harmonic component corresponds to the frequency term which is equivalent to ±n omega naught. Okay, like this is the second harmonic term, this is the third harmonic term, and etc. ठीक है? Okay. ठीक है. Then trigonometric form of the Fourier series, but that is only for real signals. यहाँ पे mention करते हुए चलते हैं. Exponential Fourier series can be defined for real as well as complex signals, but most likely आपके लिए question real signal पे ही होते हैं 99%, right? But yeah, in general, exponential Fourier series is applicable for real signal also and for complex signal also. Trigonometric form is applicable for real signals only, and that is given by C0 plus summation k equal to 1 to infinity ak cos k omega naught t plus bk sin k omega naught t. AK cos k omega naught t plus bk sin k omega naught t. Okay, so that is what is the value of xt. Okay, where AK and BK are known as the coefficient of cosine and sine respectively, and C naught is the same DC component term. Okay, hi, good afternoon, Kishore. C naught will be the same, that is known as the DC component term. Okay, and these are the coefficient of cosines and sines. Okay, now what is their formula? What is the relation? Dekho, if you want, you can remember the separate formula AK, BK, or you can also remember the relation with the CK. Like AK is given by CK plus CK star या CK plus C minus K, because for real signal, again properties में बताऊंगा मैं आपको आगे. Whenever you have a real signal, na, the Fourier series coefficient, like the Fourier transform, you will see many properties repeated here. Fourier series coefficient, like the Fourier transform, will follow conjugate symmetry. Now, what is the conjugate symmetry? Fourier series coefficient for negative k will be equal to the conjugate of the Fourier series coefficient for positive k. That is C minus k, Ck star. C minus K will be Ck star. That will be seen for real signals. Okay. So actually AK is Ck plus Ck star, or Ck star is C minus K. Similarly, there is a formula for the BK. Okay. That is J Ck minus C minus K. Solving it, this is the AK and BK formula. आपको क्या याद रखना है? Question कहाँ से आता है वो भी सब clear हो जाएगा. Okay. AK 2 by T integral over one time period xt cos k omega naught T, and BK is 2 by T integral over one time period xt sin k omega naught T dt. Okay. Okay, now very important results. Okay, symmetry based. Before we start the numerics, na, पहले कुछ regular property, not the other property, symmetry property especially. Okay, especially the symmetry property. Okay, if the signal is even symmetric and also real, we are talking about real signal only जब तक हम trigonometric पे हैं. Okay, so even symmetric signal we know x minus t is xt, and for them bk will turn out to be 0. भाई देखो एक सिंपल सा लॉजिक याद रखना, एक सिंपल सा लॉजिक याद रखना. Trigonometric Fourier series has three different terms: DC, cosines and sines. एक बार फिर से दिखा देता हूं आपको. Whenever I am expressing trigonometric Fourier series, I have a DC term, I have some cosine terms, and I have some sine terms. Okay. Now dear, out of these signals, which of them is even signal, which of them is odd signal? We all know that this is even symmetric. Sine theta is odd symmetric. Sine minus theta is minus sine theta. Okay, so this is cosines and this is sines, even and odd. What about the DC term? Whether it is an even or odd function? Dear, when you draw DC, how DC looks like? DC matlab constant, C naught. C naught for all values. Constant means constant. I'm not giving a range. C naught, it is always constant for all values. Matlab, from minus infinity to infinity is a constant. So when you look into the graph, it is definitely even symmetric. Na? It is definitely even symmetric. Left and right identical. Mirror image will be identical to itself. Okay. So we consider DC also under even. Okay, now there is a very simple logic to remember. The most important properties here, ki dear, okay, if the signal that you are defining on the left, if that is also even symmetric signal, so even symmetric signal can only contain even components. Na? How it can contain odd component? So if left side xt is even, ये नहीं आना चाहिए. Vice versa, if xt is an odd signal, so it should not contain any even terms. So then only sine will come. बस इतना लॉजिक याद है ना. very important properties you are able to remember. So that is what, if it is even symmetric, it cannot contain sine because that is odd symmetric. There will be no sine terms. Okay, there will be no sine term. And then what is the trigonometric Fourier series expression? Sometimes they ask the expression also. Then you will have C naught plus summation k equal to 1 to infinity ak cos k omega naught t. Summation ak cos k omega naught t. DC can come, cosines can come. Okay, under certain circumstances, based on the symmetry of the signal, C naught be 0 हो सकता है, but in general C naught can come. Okay, so in general C naught and cosine will come because we are talking about even signal. This is the trigonometric Fourier series simplified expression for even signals. Sometimes they ask this simplified expression, 1 mark के question बन जाते हैं यहाँ से. Similarly, when you are talking about the odd symmetric signal, again next important property, when you are talking about the odd symmetric signal, okay, x minus t is minus xt. Okay, so there odd symmetric means what will not come? Okay, DC even should not come. DC and cosine will not come. Okay, not come का मतलब क्या हुआ? भाई DC नहीं आएगा तो ये 0 होना चाहिए. And cosines not coming मतलब all its coefficients should be 0. 0 into anything will be 0. Okay, so only this will come. Okay, so that is why AK and C naught is 0. Okay, there is no DC or cosine, only odd term will come. And then what is the simplified trigonometric Fourier series expression for odd signal? It will only be written as summation k equal to 1 से लेके infinity xt, sorry, xt sin k omega naught t, only signs will come. अरे यार dt क्यों लिख दिया मैंने, समेशन है ना, सॉरी, समेशन xt समेशन b के sin k omega naught t, ठीक है यार, दिस इज द फाइनल एक्सप्रेशन, ओनली साइन टर्म, समेशन k इक्वल टू 1 to infinity b के sin k omega naught t. ओके, वेयर bk इज गिवन बाय दिस फॉर्मूला. देखो यहां पे हमने इंटीग्रेशन की प्रॉपर्टी भी यूज कर ली है. ओके, नहीं आकांक्षा, फॉर्मूला सब कुछ करेक्ट है भाई. व्हाट वाज जनरल फॉर्मूला फॉर bk, ये भी बता देता हूं. 2/t इंटीग्रल फॉर वन टाइम पीरियड. सपोज इंटीग्रल फॉर वन टाइम पीरियड इज -t/2 से t/2. ओके, बट फॉर इवन सिमेट्रिक सिग्नल मैंने बोला xt ऑड है, साइन भी ऑड होता है, ऑड इनटू ऑड विल बी इवन. ओके, एंड फॉर इवन सिग्नल इंटीग्रल -a to a इज ट्वाइस इंटीग्रल 0 to a. So that is nothing to worry, उसको अलग से याद नहीं रखना है, but just I am telling you how the expression came up. You don't have to remember that separately. Once we solve all questions of Fourier series, वो भी clear हो जाएगा कि what are the terms important for you to remember. Okay, so even symmetry and odd symmetry. Okay, convergence मैंने बता दिया, ठीक है, convergence हमने discuss कर लिया. Now before we go to the properties, okay, yeah, let me have a review and then let's come to the very important half wave symmetry. Many questions are on the half wave symmetry also. Even odd symmetry तो important है, but half wave symmetry is also very important. Okay, first regular properties, many of them are similar to Fourier transform that you have seen. Okay, so if two signals are added, Fourier series coefficient will be added. So I'm assuming that we have signal xt and yt having the Fourier series coefficient ck and dk respectively. The ck and dk respectively. Okay, xt and yt having the Fourier series coefficient ck and dk respectively. ठीक है, the ck and dk respectively. Okay, now if two signals are added, Fourier transforms are also added. If xt multiplied by constant a, Fourier series multiplied by linearity. Time shift corresponds to exponential phase term, very similar. Ck e power minus jk omega naught t, very same. Okay, frequency shifting corresponds to the exponential term in the time domain. Okay, so if I write the Fourier series coefficient ck minus m, then e power jm omega naught t, e power jm omega naught t xt in the time domain, again with the opposite sign. Time shifting में same sign, minus t naught to minus t naught here, but frequency shifting में if I take minus m here, it will be plus m here. Same like Fourier transform, तो ज़्यादा आपको easy हो जाएगा, nothing more to focus here. Okay, conjugation, x conjugate t has the Fourier transform x star minus k, and this already I told you. Okay, if signal is real, conjugate symmetry is again seen in the Fourier series coefficient. C minus k is equal to ck star. Okay, so if signal is similar properties like Fourier transform again coming up, signal real and even, Fourier transform are also real and even. Okay, if signal is real and odd, Fourier transform coefficients are pure imaginary and odd. कोई difference नहीं है, सब कुछ same है आपके लिए. Okay, time reversal. Okay, x minus t will have the Fourier series coefficient c minus k. Okay. Scaling, now very important point, time scaling will not affect the ck. I will explain the logic. मैं अभी इसका logic बताता हूँ कुछ देर में. Okay, time scaling, देखो xt, if suppose it has the time period change होता है but not the Fourier series coefficient. Okay, time period t, xat represents scaling, compression or expansion. So when you compress or expand a signal, the time period will definitely change as t upon mod a. Okay, ठीक है. Why the Fourier series coefficients are similar, I will give you the logic behind this, just wait करना. Okay, then convolution. Okay, what is periodic or circular convolution, वो थोड़ा आगे cover करेंगे. Just right now noted as the convolution formula. Convolution in time, multiplication in frequency, you will get the Fourier series coefficients tau ck dk. Multiplication in time, convolution in frequency domain. Differentiation corresponds to multiplication by j omega, here jk omega naught, here jk omega naught. Integration, ck divided by jk omega naught. If there is an integration of xt, ck upon jk omega naught. Half wave symmetry. Half wave symmetry. Okay, half wave symmetry, very important. ठीक है, very important. ठीक है, Very, very important. The signal is half wave symmetric. If you shift it by half a period, okay, like xt plus t by 2, xt minus t by 2, okay, kuch bhi, xt plus t by 2, xt minus t by 2, right or left, if you half shift the signal, you get minus of xt. I mean, let me write it like this, x of t minus t by 2 yeah plus t by 2, left or right shift, turns out to be negative of xt, and such a signal is said to be half wave symmetric. Okay, and whenever a signal is half wave symmetric, okay, all even harmonics will be absent. Okay, all even harmonics will be absent of cosine and sum. Okay, that means only odd harmonics present. Odd harmonics. I told you what is kth harmonic. Okay, odd harmonic ka matlab only omega naught, 3 omega naught. What is nth harmonic? A term corresponding to n omega naught. So only odd harmonic presents. Matlab whenever you break the signal into Fourier series, it will only contain frequency components corresponding to the frequency omega naught, 3 omega naught, 5 omega naught. These will be present. But any particular time like 2 omega naught, or including 0, 0, 2 omega naught, 4 omega naught, they will all be absent. They will all be absent. Further, a half wave symmetric signal can be even or odd individually. That is also possible. Now let's understand this. Okay, एक चीज यहाँ पे समझेंगे, very important. Let me give you a curve. Then अभी मैंने बोला था ना, there is the shortcut to calculate CK. Okay, उस पे बाद में आएंगे. But first let's understand this symmetry. For the signal shown, find the fundamental period, DC component, वो सब आ जाएगा. Type of symmetry, which terms are present in trigonometric Fourier series, which harmonics are present in the trigonometric Fourier series. First of all, whether it is even or odd symmetry. First, let us classify even and odd. First, let us classify even and odd. पहले ये बता दीजिए. There is clearly the symmetry in the first and the third quadrant. Okay. Negative sign है यहाँ +5 या -5. Means symmetry in the first and third quadrant. It is odd symmetric signal. Okay, the type of symmetry, number one symmetry, half wave है कि नहीं वो देखते हैं हम लोग. Okay, there is odd symmetry. Okay, so which terms are present? Okay, only sine terms are present in the trigonometric Fourier series coefficient. No DC and no cosine. So what is the answer for C0? बताइए. Okay, so what is the answer for C0? 0. मैंने बोला ना only sine. There is no DC, there is no cosines. Okay, so that itself says that DC, don't start calculating the value. Okay, even if you calculate 0 आएगा, we will do some calculation based question also, but यहाँ पे C0 0 है. What is the time period? अरे वो तो यहीं से दिख जाएगा. Time period for this positive triangle to repeat. This is at 0, this is at 10, so time period is equal to 10. Time period is equal to the 10. Yes. ठीक है, तो टाइम पीरियड 10 है, C0 आ गया, सिमेट्री आ गया. ठीक है, नाउ इज इट ओनली ऑड सिमेट्री या समथिंग एल्स? लेट्स अंडरस्टैंड द नेक्स्ट पॉइंट हियर. ओके, लेट्स अंडरस्टैंड द नेक्स्ट पॉइंट हियर डियर. ध्यान से देखना. सो इफ दिस इज xt, okay, what I am now going to draw here is x of t minus t by 2. Now what is the time period? Is 10, so t minus t by 2 would mean x of t minus 5. Okay, that means I'm right shifting by 5. You can do the left shifting also. Okay, let me right shift by 5. If I right shift by 5, this positive triangle itself will start at 5. Okay, and ये -5 वाला यहाँ आ जाएगा. We'll start negative triangle here, and then the positive triangle starts at 5, and then it is repeated periodically as the above one. It remains to be periodic. Only thing is slight shifting has been applied. Now tell me, what is the difference in the two signals? What is the difference in the two signals? Okay, look into any time interval. Suppose 0 to 5. If this is 5, this is minus 5. Okay, here if this is minus 5, this is plus 5. 5 or minus 5, matlab they are just opposite in sign. So this x of t minus 5 is turning out to be nothing but negative of the above signal. Can I say? It is negative of the above signal. So here you clearly have the condition that x of t minus t by 2 turns out to be negative of xt. And such a signal satisfying this property is said to be half wave symmetric. So not only there is odd symmetry in this question, okay, there is also the half wave symmetry. There is also the half wave symmetry. There is also the half wave symmetry. So which harmonics are present? For half wave symmetric, only odd harmonics are present. Only odd harmonics are present. ठीक है? अब देखो थोड़ा इसको अब एकदम सिंपल करते जाते हैं. Let me give you the differences. Let me write down the trigonometric Fourier series formula first of all. The trigonometric Fourier series for a signal is C naught plus summation k equal to 1 to infinity aka cos k omega naught t plus bk sin k omega naught t. I'm starting with the general formula first. But here we have observed that the signal is odd symmetric. First thing that we observed that the signal has odd symmetry, and odd symmetric signal can only contain okay, odd components, and that is sine. Cosine is even, DC is also even, and that is why the expression जो मैंने पहले भी लिखा हुआ है, it becomes k equal to 1 to infinity. Okay, bk, only this much will come, bk sin k omega naught t, k equal to 1 to infinity. ठीक है? But there is a signal which is not only odd, it is odd symmetric undoubtedly plus half wave symmetric. Okay, so if it is odd and half wave symmetric, I will be having xt, which is again written in the form of summation bk sin k omega naught t. Okay, but is it for k equal to 1 to infinity? No, is it only k which is equal to 1, 3, 5, etc. Up to infinity, but only odd k will come. Only odd k will come. Rest of the above formula you know, but this is how you can simplify the expression for a odd half wave symmetric wave. That means B2, B4, B6, all even terms will be 0. B2, B4, B6 0 होगा, but yeah, B1 will be present, B3 will be present. अभी value नहीं निकाल रहे, we will go for the numeric questions also, but first symmetry based properties and questions are important. B1 will be there, B3 can be there, B5 can be there, but B2, B4, B6 without any calculation straightforward I can say it is going to be 0. Okay, clear everybody? So thus such questions are also important for understanding the symmetry. For what? Understanding the symmetry. For understanding the symmetry. ठीक है? चलो. For understanding the symmetry. चलो. Now, before I take up any next question, ये सारा हमने देख लिया है. Let me come back to the exponential Fourier series, the general form once again. Okay. And what is the shortcut for CK? Okay. CK, the Fourier series coefficients, as you know, are 1 upon t integral over one time period xt cos k omega naught t dt, integral for one time period. Clear? हम क्या करेंगे? The shortcut is, because you are clear with Fourier transform, okay, there is one more way, because the formula is slightly related to Fourier transform ना. अरे यार ये cos क्यों लिख दिया? Exponential Fourier series coefficient, sorry. Okay, xt e raised to the power minus jk omega naught t dt. Okay, calculate the Fourier transform. Fourier transform type का formula है xt power minus j omega t, but in place of omega you have k omega naught, and integration is for one time period. So what I will do, I will calculate the Fourier transform for only one time period. Suppose that one time period, यहाँ पे लिख देता हूँ मैं, and then I will explain in the question. Let xpt, okay, be the one time period of the signal. xpt be a signal which is corresponding to one time period of xt. xt तो periodic है, यहाँ पे repeated है. Let me draw it only one time period. Okay, and calculate the Fourier transform of it. Because I want the integration only for one time period. So I will calculate the Fourier transform for one time period, and suppose that is xp omega. XPT 1 period, it's Fourier transform XP omega. Calculate XP omega, but in omega place K omega naught. In omega, I have to place K omega naught. Okay, outside 1 by T. You will feel it is very simple tool. I will make you feel it is very simple tool. Kaise? Okay, I will make you feel it is very simple tool. Okay, so let's go to a question of this nature first of all. Let us go to a question of this nature. ये लीजिए, बताइए. Find the Fourier series coefficient. Normally, for a Fourier series coefficient, you will start applying the formulas one by one once again, one by one once again. Okay, one by one once again. But what is the answer here? Now, what do I mean by one time period? इसको समझ लेते हैं. There is a rectangular repeated. This is the periodic signal. Okay, where there is a rectangle pulse repeated. Okay, there's a repeated rectangular pulse. Forget the repetition. What is in the one time period? Okay, what is in the one time period? One rectangular pulse. One rectangular pulse. अच्छा, by the way, what is the time period? यहाँ से यहाँ center to center mark कर लो. Yeah, you can mark the time period like this also. Time period is 4. So let me take it as -2 से 2. That is also okay. Okay, this is one time period, -2 से 2. That is equal to 4. Or center to center marking also you can take. But within one time period, whatever is the signal, first of all, that is XPT. Understand each and every term. So hope XPT is clear. What is XPT? One time period, which is rectangle. Rectangle. Having amplitude 2. So 2 rect. Okay, 2 rect. T by how much? Total width is 2. -1/7 width is 2. Now tell me, do you know its Fourier transform? One of the very, very important formula of Fourier transform I'm picking up. So if you know that, Fourier series coefficient is just like that, na? Fourier series coefficient is just like that. So what is the Fourier transform of it? XP omega. XP omega. 2 को अलग करते हैं. Rect of T by 2. 2 sampling omega T by 2. So this becomes 4 sampling. ये 2 से 2 cancel. This is 4 sampling omega. That is the XP omega. For sampling omega. Okay, chalo done. So now, as per the shortcut, what I told you, what is CK? 1/T XP K omega naught. यहीं से problem solve कर देंगे. अच्छा, what will be omega naught? Time period तो 4 है. Omega naught is 2 pi by time period, so that is pi by 2. So this becomes 1/T time period 4. What is the XP? 4 sampling omega. Okay. यहाँ पहले K omega naught का वैल्यू रख दें. XP K omega naught as I just explained is pi by 2. So the final Fourier series coefficient formula CK 1/4 XP. अच्छा, XP का वैल्यू रख देंगे. XP 4 sampling omega ना, तो omega की जगह K pi by 2. So your answer is, question is solved. It is simply sampling K pi by 2. It is simply known as sampling K pi by 2. Clear? It is simply sampling K pi by 2. That is the answer. That is the answer. अच्छा, अब अगर इसको देखोगे आप, what is the CK? Question is done. A very simple approach now. Okay, it is sampling K pi by 2. So if you start calculating, suppose C1. Okay, yeah, suppose you start with C0. Okay, what is C0? Sampling 0, 1. What is C1? देखो, इसको लिख लेते हैं ना. This is sin K pi by 2. Divide by K pi by 2. Sin theta by theta. Okay, so what is the value of C1? What's the value of C1? Okay, so sin pi by 2, 1. Okay, upon pi by 2. 1 upon pi by 2. That is 2 upon pi. Okay, what is the value of C2? What is the value of C2? Okay, sin pi. K का value 2 रखेंगे तो sin pi 0. What is the C3? Sin 3 pi by 2 minus 1 upon 3 pi by 2. So this is minus 2 by 3 pi. Similarly C4. Put down C4. Okay, तो 4 रखा तो sin 2 pi बना. Sin 2 pi again 0. C5. Okay, you will get sin 5 pi by 2. It's again like first quadrant to 1 upon 5 pi by 2. Okay, that is 2 by 5 pi, and etc 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 etc. ठीक है? Again you are able to feel that. Again you are able to feel that Ck equal to 0 for E1k. Ck equal to 0 for E1k. You know why Ck equal to 0 for E1k? One more concept here. Ck equal to 0. एक और concept learn करते हैं यहाँ पे. Okay, Ck equal to 0 for E1k. Ck equal to 0 for E1k. Yes, very good, Jayesh. Is it half wave symmetric? Dear, the time period is 2. Sorry, time period 4 था. Time period अगर 4 है, so half of the time period is 2. यहीं पे करेंगे. I'm not drawing another waveform. Half time period is 2. This triangle is centered at 0. Now if you take the triangle at 2, half time period से right shift किया, right या left? Okay. So ये जो 0 वाला portion है, ये यहाँ पे आ जाएगा, and this will be 2, and then this will be 0. Is it half wave symmetric? No. Half wave symmetric means this particular yellow signal जो yellow से बनाया है, this is 0 and above one is 2, but they should be differing in sign. If this is 2, it should go to -2. If this is 0 here, it should be -0, but this is not half wave symmetric. Half wave symmetry यहाँ पे नहीं है. But चलो इसको drawn रहने देते हैं. What is the DC component? What is the DC component? C naught. What is the DC component C naught? It is 1 here ना. DC component अभी हमने 1 निकाला है. हाँ, इसको अभी ड्रॉ रहने देते हैं. DC component is 1. Okay, draw a line passing through 1. Draw a line passing through the DC component. Draw a line passing through the DC component. एक काम करते हैं ना, इस पर्टिकुलर पिक्चर को let me replicate this, okay, so that these calculations are also intact. ठीक है. Let us take this. Let me remove this now. Take a line passing through the DC value. What is the DC value? The DC value is C naught equal to 1. Take a line, okay, which is C naught equal to 1. C naught का value 1 है, तो line passing through amplitude 1. Okay, assume that if this was the x-axis, for a moment assume that this is the x-axis, okay, and then draw, okay, both the signals. ये मेरा original signal है. Let me shade the original signal also. थोड़ा सा bold कर देते हैं इसको. This is my original signal. This is my original signal. This is my original signal. ठीक है. Now let me draw the time shifted version. Okay. If I shift by time period equal to 2, okay, ये यहाँ पे आ जाएगा. It will go like this. Okay. So what do I have? This is representing x of t minus t by 2, and this yellowish line is representing the xt signal. Okay. And now if you assume that if this is the x-axis, if this is the x-axis, so देखो ये 1 above, this is 1 below. Please see, 1 above, 1 below. Okay, then this is 1 below, the 1 above. It's like -1, 1, 1 minus 1. Now they are having symmetry. Okay, now they are having the symmetry. So please note that I can say that x of t minus t by 2 is negative of xt if x-axis is pulled above. अगर x-axis को ऊपर pull कर दें, suppose if this is where the x-axis is. Okay, this is known as half wave symmetry about mean line. X-axis को कितना ऊपर pull किया? Corresponding to the DC component, corresponding to the average value of the signal. This is half wave symmetry about the mean line, and this is known as hidden half wave symmetry. This is known as hidden half wave symmetry. Clear? So whether it is half wave symmetric or hidden half wave symmetric, okay, even components will be absent. The only difference is if it is proper half wave symmetric, DC component 0 आएगा. ओके डीसी कंपोनेंट 0 आएगा, ठीक है। इसको मैं लिख देता हूं यहाँ पे ना, लेट अस राइट डाउन द डिफरेंस बिटवीन बोथ, ठीक है। देखो, इफ इट इज हाफ वेव सिमेट्रिक, ck equal to 0 for E1k, okay, for E1k, and even C0 will be equal to 0, okay. What is hidden half wave symmetry? Okay, the Fourier series coefficients will be 0 for E1k. Only odd terms आएगा, but C0 can exist here. That is the difference. That is the difference going to be coming up here. That is the difference जो दोनों में आने वाला है. Right, everybody? That is the difference जो दोनों में आने वाला है. Done है? अच्छा. Also, one more message to learn from this question is, ultimately this is a periodic rectangular या square waveform. Square भी बोल सकते हैं, rectangle बोलते हैं. Okay, but of what duty cycle? Out of the time period which is 4, how much time it is on? Total time period 4 हमने देखा था. Total time period 4, ठीक है. The on time period is 2, -1.7. On time period 2, how much time it is on? 50%. 2 out of 4, 50%. How much time it is on? 50%. That is a duty cycle, which represents for how much of the time the waveform is at logic high. Okay. There is a 50% duty cycle. There will be, you can feel many questions in competitive exam, GATE or ESC or anywhere, where you are given periodic rectangular waveform with 50% duty cycle. Okay, एक और point मैं यहाँ पे generalize कर देता हूँ. Whenever you have a periodic square waveform, square a rectangle, okay, periodic square wave, okay, with 50% duty cycle, okay, the CK will be 0 for E1K. That means, okay, इसको ऐसे भी लिख सकते हैं, the Fourier series contains only odd harmonics. Even नहीं होगा. The Fourier series contains only odd harmonics. CK will be 0 for E1K. Whether it is half wave symmetric or hidden half wave symmetric, CK will be 0 for E1K. Okay, Fourier series contains only odd harmonics. ठीक है? All right. So, in case of any doubt, Mr. Saint, you can tell me. Already, I think we are running slow only. 2 hours done and not even 50% question done. So, it's going slow only because I am taking up the concept also. As I told you, it will not be only question. हर क्वेश्चन के साथ चीजें लर्न कर रहे हैं. तो इट्स अ कंप्लीट पैकेज रिवीजन. ओके, चलो. सो इफ यू हैव अंडरस्टूड द शॉर्टकट ना, आई होप दिस शॉर्टकट हेल्प्ड यू अ लॉट. ये शॉर्टकट बहुत हेल्पफुल होगा आपके लिए. एंड इफ दिस यू हैव लर्नड, गिव मी वन मोर आंसर क्विकली. इफ दिस इज क्लियर टू यू, गिव मी वन मोर आंसर क्विकली. PDF in my Telegram group, Aditya. I will share you the link. Don't worry. I will share you the link in some time for the Telegram group. मैं अभी चैट बॉक्स में शेयर करता हूँ. टेल मी द Fourier series coefficient. So again, guys, a very quick approach can be applied here. A very quick approach can again be applied here. Noticing the time period. Again, time period is 5. Center to center marking करेंगे. Time period is 5. If I do the center to center marking, time period 5. Within one time period, within any one time period, the signal taken out will be XPT. And what is the XPT? It is a triangle signal. Amplitude height of the triangle is 3. So T try T by how much? T by 2. When I write try T by T, already I explained you. Try T by T goes from minus T se T. So it is minus 2 se 2. So try T by 2. So what is going to be the Fourier transform? Okay. Try T by T. T sampling square. तो यहाँ पे आ जाएगा 2 sampling square. Omega T by 2. Omega into 2 by 2. So this becomes 6 sampling square omega. XP omega is known as the 6 sampling square omega. It is the 6 sampling square omega. Okay. 6 sampling square omega. That is the XT. That is the CK. Okay, XP omega आ गया. चलो, so now I want CK. The shortcut was 1 by T XP K omega naught. Okay, 1 upon T. Time period is 5. Okay, XP K omega naught. तो omega naught 2 pi by time period, 2 pi by 5. Place down the value of xp, that is 6 sampling square function. तो 6 sampling square omega की जगह आ जाएगा 2 pi k by 5. Okay, so what is the Fourier series coefficient? 6 by 5, that is 1.2 sampling square 2 pi k by 5. That's the answer. Very simple. No, Sahil. Very simple, na? If you try to solve by the CK formula, integrate again, it is going to take a lot of time of yours. But this is very simple. Very, very simple. I can call it as very, very simple. Let me know if you like this. If you like this technique. If this is helping you. Come on, quickly everybody, let me know. Okay, 17, 16. एक question शायद बीच में छोड़ा था. 14 कर लिया था. हाँ. So this one, simple. Find a DC component. Find a DC component. Find a DC component of the periodic signal. So sometimes their question is only on DC component. Sometimes the question is only DC component, and that is 1 upon t integral xt dt, and that is area under xt for one time period. Okay. Simple approach. Area under xt for one time period. Time period marking करेंगे. Okay, so this shape, okay, starting at origin seems repeated at 6. 6 पे वापस repeat हो रहा है, तो time period is 6. 1 upon 6. Area. Now area पहले तो आएगा triangle का area, okay, फिर rectangle का, फिर एक rectangle का, तो triangle half base height. Okay, for the next is height into base, 1 into 1 rectangle के लिए. Next is again height 1 and base is 1. Okay, this turns out to be total 1 plus 1 plus 3, 5 by 6 is my answer. Answer is A. Quick यार, very quick. एकदम quickly करते जाना है. Answer is 5 by 6. Clear? Next question. चलो 16, 17 done. अरे 16 दो बार आ गया क्या? अच्छा नहीं, मैंने कॉपी किया था, ठीक है. 17 done. This is the 18. Property based. Okay, let xt be a signal whose Fourier series coefficients are given to you. Whose Fourier series coefficients are given to you. 2 for k equal to 0. J 1 by 2 power mod k for k not equal to 0. Whether the signal is real, okay, whether xt is even या whether derivative is even. देखो, for real or for even, we need to check the Fourier series coefficient given to me. Okay, अब देखना यहाँ पे, if this is ck given to me, okay, what should be the c minus k? What should be the c minus k? देखो, 2, real number, 2, whether you take k 0 or minus 0, that is same. So 2 will remain 2. Okay, but here you have mod k. Okay, so j 1 by 2 power modulus of minus k. But what is modulus of minus k? इसको तो डायरेक्ट लिख सकते हैं ना. What is modulus of minus k? Mod k only. Okay, modulus of minus k will be mod k only. So c minus k will be like 2 for k equal to 0 and j 1 by 2 power mod k only. Modulus of negative number is mod of minus k is mod of k only eventually, ना. Negative तो वैसे भी discard हो जाएगा magnitude में. So this is like ck. C minus k is ck. That means at least I can say that xt is even. Real है कि नहीं है ये पता, but xt is even. ये बोल सकते हैं. xt even है, इतना तो correct है. ठीक है. अच्छा, if xt is even, its derivative will be odd. Basic rules apply करो ना. If a function is even, its derivative will be odd. Yes or no? Basic calculus. No need to prove that. Okay. So this is definitely odd. Okay. ये odd होना चाहिए. ठीक है. Now real है कि नहीं? If the signal is real, Fourier series coefficient should follow conjugate symmetry. So what is ck star? Okay. What is going to be ck star? चलो यहीं पे अगर हम लिखें in front of you. What is going to be the ck star? Conjugate जैसे ही आपने लिया, 2 is a real number, तो conjugate remains to be same, but this is like jy. What is the conjugate of jy? Minus jy. Imaginary part gets negated, na? तो minus jy. Minus j half power mod k. Okay, so definitely c of minus k. यहाँ लिखता हूँ. C of minus k. Okay, is it equal to ck star? No. C of minus k does not equal to ck star. There is no conjugate symmetry. Okay, so xt is not real. xt is not real. So it is only even. It is only even. The answer to be marked is only B. Clear? So fundamental properties पे question बहुत बनते हैं यहाँ पे. Good one, but fundamental property. Next question, number 19. Property again. Let xt be a periodic signal with fundamental period t and Fourier series coefficient ck. Derive the Fourier series coefficient of each of the following signal in terms of ck. In terms of ck. In terms of ck. Derive the Fourier series coefficient of each of the following. ये एक है, एक और मैं दूंगा. Okay. Time shift, basic time shift property. Basic time shift property. Okay. अगर xt suppose has the Fourier series coefficient ak, yt suppose has some Fourier series coefficient dk. What is that dk? Okay, देखो xt minus 1 ck e power minus j omega t naught का वैल्यू 1 है. xt plus 1 टाइम शिफ्टिंग करस्पॉन्ड्स टू फेस टर्म इन द फ्रीक्वेंसी डोमेन. e पावर प्लस j ओमेगा आ जाएगा यहाँ पे. ck को लिया कॉमन, e पावर माइनस j थीटा प्लस e पावर j थीटा. इफ यू डिवाइड बाई 2 यू गेट cos थीटा. ओके, बट डिवाइड बाई 2 नहीं है तो मल्टीप्लाई बाई 2 कर देंगे. सो दिस इज लाइक 2 cos थीटा. ओके, सो 2 ck cos थीटा. 2 ck. ओके, कॉस, अच्छा सॉरी, ये फूरियर सीरीज है. k ओमेगा नॉट e पावर माइनस j k ओमेगा नॉट इंटू टी e रेस टू द पावर प्लस j k ओमेगा नॉट. ओके, तो 2 ck cos k ओमेगा नॉट, 2 ck cos थीटा. सो 2 ck cos थीटा, आंसर इज ए. ओमेगा नॉट को वापस 2 पाई बाई टी लिख दिया. आंसर इज ए. Very clearly answer is A guys, not C. It is A. Be very clear. अच्छा, पिछले केस के लिए कुछ बोल रहे हो क्या आप? Which of the following statement is true? नहीं, पिछला तो B था ना? Any confusion in the previous also? Some of you are telling C. Which of the following is true? नहीं. हाँ. Previous one B. I don't know किसके लिए आपने कमेंट किया है. This one is A. ठीक है? Any confusion? Now you tell me. One more on the same. Okay. What is the Fourier series coefficient of x3t minus 1? xt has the Fourier series coefficient ck. So what about xt minus 1? What about? Again precedence rule. Again precedence rules. First shift and scale. First shift and then scale. Okay, so it will be ck. Okay. शिफ्ट करेंगे पहले तो अगेन एक्सपोनेंशियल टर्म लाइक द लास्ट क्वेश्चन, e पावर माइनस जे के ओमेगा नॉट. ओके, बट देन टाइम स्केलिंग आएगा. आई टोल्ड यू वन थिंग. मैंने लॉजिक भी अब बता देता हूं. अगर xt हैज द फोरियर सीरीज कोएफिशिएंट ck, व्हाट अबाउट x80 हैज व्हाट फोरियर सीरीज कोएफिशिएंट? मैंने कहा था सेम रहेगा. टाइम स्केलिंग डज नॉट अफेक्ट द फोरियर सीरीज कोएफिशिएंट, क्योंकि देखो जो ck का फॉर्मूला है ना, दैट इज 1/t xp k ओमेगा नॉट. इट डिपेंड्स ऑन टू थिंग्स एज पर आवर बेसिक एनालिसिस, 1/t and xp. Okay, it depends on time period and the Fourier transform. If you apply time shifting, time scaling, the period is scaled, Fourier transform भी तो scaled होता है. Both of them are scaled. Okay, that is why Fourier series coefficient not affected. Fourier series coefficient not affected. Clear? So remember that. That is the primary logic. Then there can be detailed derivation also, but logic से मैंने आपको बताया. Okay, so 3t minus 1 Fourier series coefficient not affected, so it remains to be ck e power minus j k omega naught. No, there is one change that is going to occur. Of course, I told you Fourier series coefficient will not change, but time period to change होगा. Okay, time period becomes how much? T by a. Time period divided by 3. But here I am writing a frequency term. The frequency multiplied by 3. Frequency multiplied by 3. So it should be 3 omega naught. Okay. It should be 3 omega naught. And omega को 2 pi by t लिखेंगे. यहाँ पे माइनस है तो माइनस वाला ही ऑप्शन आएगा. C तो नहीं होगा. Some of you telling C. No. E power minus j 2 pi by t. No, D. Okay. It has to be D. 6 pi by t. Because omega naught is 2 pi by t ना. Okay. So overall 6 pi by t होगा. Time period and frequency affected. Okay. ये तो सेम होगा. Time period t dash. T by a. Okay. Suppose if it has time period t, it has frequency omega naught, it has Fourier series coefficient ck. Time period affected. Okay, frequency will be inverse na, to multiplied by a. Okay, ck remains to be ck. ये change नहीं होगा, ठीक है? पूरा elaborate करके लिख दिया. This is not going to be changed. Okay, this is not going to be changed. चलो next. Okay, chalo. So now, before I go to the next, guys, as you know, exam is coming closer. And on the exam day, the team, okay, will be coming up live with the full detailed exam analysis. The team will be coming live with the full detailed exam analysis. With the full detailed exam analysis. Just a second. ठीक है, चलो. Usually it is given in the student response P. Usually you can expect by 15th February easily. तब तक आ जाएगा. Okay, the complete exam analysis like EC is on 11th Feb. Okay, so we'll see you live after the exam gets over. That is the forenoon session is EC. Similarly, there will be live analysis for EE also after the exam gets over. For computer science, for mechanical, for civil, for all the branches, we are going to do that. Okay, and now guys, we are done 20 questions out of 51. 2 hours, 20 questions out of 51. किस पे चलें? I think let us pick up. I think थोड़ा सा पहले और important topic को pick up करते हुए let me first start with the Z transform. Okay, everybody? Let us first target Z transform here, everybody. Let us first quickly target the Z transform, the more important one. Z transform. Z transform. Okay, Laplace को बाद में लेके आते हैं, पहले Z discuss कर लेते हैं, the more important one. Okay, the more important one. Let's discuss the Z transform here. चलो, yeah, let us pick up the Z transform. हाँ, Laplace करेंगे, don't worry. Okay, तो Z transform for any signal xn again, okay, represented suppose in the form of xz, and they will again be represented as a double-sided arrow. Okay, xn having the Z transform xz, and similarly xz having the inverse Z transform, that is known as the xn. And basically that Z transform is given by summation of xn z power minus n. Summation of xn z power minus n. Now there will be many important concepts and properties to be learned here. Summation of xn z की power minus n. लेकिन यहाँ पे, okay, before I take up any other regular question, okay, take up this question. Okay, try to solve this logic. Try to solve this question with the logic. Okay, the inverse Z transform. Okay. The inverse Z transform of xz. Okay, given that xn is causal, assuming xn to be causal, वो आप वहां से भी समझ जाओगे when you expand. Guys, do this. I've given you some interesting question here. Guys, do this. Okay, and just allow me. I'll be back in 2 minutes. Okay, by the time you are solving the question, just give me 2 minutes. Okay, so hope so you have tried something. Let's do this one. And then let's again jump back to the basics of Z transform. So I thought एक क्वेश्चन दे के जाता हूँ. Okay, chalo, let's get moving ahead, dear. Let's get moving ahead. The inverse z transform of xz equal to e power 1 by z with the ROC all z except mod z equal to 0 for n equal to 2 is equal to how much? Okay, is equal to how much? Is equal to the how much? ये देख लेना यहाँ पे. Okay, so when I see this xz, it is e power 1 by z, and if I use the expansion, of the form e power x, it's going to be 1 plus x, that is 1 by z, plus x square by factorial 2. So x square means 1 by z square with the factorial 2 in the denominator. Similarly, next term will be 1 upon 3 factorial z cube, 1 upon 4 factorial z power 4. So if you just see that, this e power 1 by z is 1 plus z inverse. Basically, all terms are in denominator. That means all negative powers are coming up. Okay. Here you have the term 1 upon 2 factorial z ki power minus 2, 1 upon 3 factorial z ki power minus 3, 1 upon 4 factorial z ki power minus 4. Okay, all negative powers are coming up, and the reason is the signal would be causal. Even if not mentioned, it is coming out to be that case. So, dekho, we know the basic z transform formula, that is given by summation of xn z raised to the power minus n. Okay, in general from n equal to minus infinity to the infinity, that is for any signal. But if I consider xn to be causal, पहले इस theory की बात कर लेते हैं. If I consider xn to be causal, okay, so causal means, hey, what is causality for a signal? That xn should be 0 for left side. Okay, xn equal to 0 for the n less than 0, and in that case my z transform xz is going to become summation n is equal to the 0 to infinity, because anyways it does not exist for negative time. Okay, summation 0 to infinity xn z power minus n, and when I open it now, to see, you are going to get the first term, that is known as x0. Okay, z power 0 is 1, then you will get x of 1 z ki power minus 1, then you will get x of 2 z ki power minus 2, then you will get x of 3 z ki power minus 3. So what you are getting? Only negative powers of z? Only negative powers of z? Then what is this x1, x2, x3? Like x1 is the coefficient of z inverse, x2 is the coefficient of z power minus 2. So here in general, what is this xk term? This xk is the coefficient of z ki power minus k. Okay, this xk here is known as the coefficient of the z ki power minus k. It is known as the coefficient of the z ki power minus k. Clear, everybody? That is known as the coefficient of the z ki power minus k. The coefficient of the term z ki power minus k. Hope that is clear to everybody. The coefficient of the term z ki power minus k. Done? ये याद रखना. Okay, that means here what are the coefficients? Okay, here I can say xk या xn को ही define कर देना. Okay, coefficient of z की power minus n. Okay, z की power minus 2, 1 upon factorial 2, z की power minus 3, 1 upon factorial 3. So for any z power minus n, the coefficient is 1 upon n factorial. Can I say like that? Even if they ask what is the complete signal that we have derived, the signal is 1 upon factorial n. 1 upon factorial n. Okay, and that is why it is causal, because we cannot define factorial of negative numbers, na? It is undefined. Okay, so xn is 1 upon factorial n. 1 upon factorial n. The question to make it into a numerical answer type, okay, देखो ROC, अभी ROC पे भी आएंगे. देखो ROC, region of convergence for all z except mod z equal to 0, because mod z equal to 0 means z also equal to 0, and if you put z equal to 0, all the z are in denominator, 1 upon 0 infinity. So this term will not be defined. Very clear. Okay, now for n equal to 2, my question was, okay, find out for n equal to 2. So the value of x2 is 1 upon factorial 2, that is 1 upon 2, that is 0.5. To convert into numerical answer type, that is okay. Okay, but in general 1 upon n factorial, even if they ask the complete signal xn. Okay, so this is something important for the causal signals, that xk is just the coefficient of z ki power minus k. For any xk. Okay, so from this xk, x2 निकाल दिया, या in general xn ही generalize कर दिया. What is that signal? That itself is generalized. अच्छा, also one more thing important from here is, also one more thing that can be important here is, देखो, when you put z equal to 1 specially, what is x1? Okay, that is summation n is equal to 0 to, यहाँ पे लिखते हैं, sorry. What is the x1? That is summation z का value 1 रखा and any power of 1 will be 1. 1 power minus n will be 1. Okay, and then you are only left with summation of xn. So some summation based question can also be solved using the z transform. Okay, but summation always only one sided can converge, na? 0 to infinity or maybe minus infinity to 0. I have taken right sided. Two sided summation तो usually converge नहीं करेंगे. That is why I am writing this formula with respect to causal signal. इसको हटा देते हैं. Okay. So x of 1 also represents summation of x, and some summation based techniques can also be used here in case if there is a mathematical type of question. Summation xn, okay, 0 to infinity, okay, is equal to x1, is equal to the x1. ठीक है, आते हैं गेट में इस टाइप के क्वेश्चन भी आते हैं. They are not mathematical question, they are actually based on the transform theory. Okay, summation of the signals. ठीक है, now let us go back to the fundamental. One question we have solved in between. Hope this is clear. Okay, and we have written the results especially for the causal signal as well. Okay, let us now come back to a fundamental calculation here. Okay, we have only defined right now the basic definition of Z transform, and now let me start with one of the very fundamental signal. And like the Fourier transform, what I will do, okay, let me do some basic discussion, and again I will give you the list of all properties and all important Z transform formula that you should remember, so that you know it becomes simple कि ये तो आपको याद रखना है, इस पे based question बनेंगे, and those questions we will discuss. Okay. So let's start with the very fundamental. This is something directly you should remember. Okay, but to explain you something, I have to take one question here. First question here, a power n un. Although this is something to be remembered directly. So when I take it Z transform, again it is causal only. Un aa gaya na. Okay. So if I start even with the general formula, I will place the signal a power n un, summation xn z ki power minus n. But as I am telling you, un only exists for n greater than equal to 0. Otherwise un will be 1, answer will be 0. Okay, so here again I will modify the limit 0 to infinity a power n z power minus n. So why not to combine power n? A z ki power minus 1 whole power n लिख दिया. A z की power minus 1 whole power n लिख दिया. Okay, now start expanding the summation. Okay, power 0 1. Okay, then a z inverse power 1, then a z inverse power 2, a z inverse power 3. Okay, so there is a particular term which keep repeating up to infinity. So this becomes the case of infinite GP. This becomes the case of infinite GP, whose answer is given by first term upon 1 minus common ratio. That is the answer for infinite GP, but that will only converge if mod are less than 1. Okay, so what is the first term here? Value substitute करेंगे. The first term is 1. And common ratio, this is the factor. AZ inverse, AZ inverse, AZ inverse multiplied every time. But if the common ratio, modulus of R at least, less than 1. Less than 1. Now what does it mean? Mod of AZ inverse, matlab mod of A by Z is less than 1. And that means mod Z के respect में लिखें will be greater than mod A. Mod Z will be greater than mod A. Okay. So what is my Z transform? The first important pair, A power n un. Then I will give you the formula list also. It is having the Z transform, which can be remembered in negative power also, 1 upon 1 minus AZ inverse. Here you can also write it as Z upon Z minus A, converting, multiplying and dividing by Z. It can also be written as Z upon Z minus A. Okay. But with the condition mod Z greater than mod A, otherwise the Z transform will not exist. Because otherwise what will happen? Common ratio of the GP greater than 1 and the GP diverges. The sum of the infinite terms will be infinity. Right? Hi Devdutt. Okay, so that is what it is going to be. Z upon Z minus A. Yeah, 1 upon 1 minus A Z inverse, provided mod Z greater than mod A. Okay, provided mod Z greater than mod A. Now, if you talk about mod Z being equal to any constant, like mod A is also a constant, na? Okay, mod Z equal to mod A, yeah, suppose equal to R. Mod Z equal to R. So what is this mod Z equal to R? We know that mod Z equal to R is the equation of circle. Mod Z equal to R is the equation of circle. Okay, with the center equal to 0, 0 and radius equal to R, circle centered at origin. Okay. So similarly, I know mod Z equal to mod A. So what is the picture that is going to be here? एक rough picture बनाते हैं पहले. Okay. So mod Z not equal to mod A, हमें greater चाहिए. But first, let me draw the mod Z. Okay, equal to the mod A. Okay, that is a circle. ठीक है. pictures approximate hai, that is a circle, but I want all the values of mod z which are greater than mod a. So any point lying on the circle has mod z equal to mod a. I want greater value. That means what I should do? I should move away from, I should move outside of the circle. I should move exterior of the circle. Okay, I should be moving the exterior of the circle. So within the z plane, dear, within the z plane, okay, you have a particular region outside the circle only, okay, where z transform will be defined. If you come inside the circle, mod z less than mod a, GP fail हो जाएगा. Even on the circle R, common ratio 1 भी नहीं होना चाहिए GP के लिए. So if you take any point on the circle या interior of it, Z transform cannot be defined. So there is a specific portion, region where Z transform is defined, and that is what is the concept of what? That is what is the concept of ROC. So ये जो term लिखा है ना, this represents the ROC. Okay, region of convergence. This represents the ROC. Okay, ROC, region of convergence. Region of convergence. Okay, the region of convergence. Okay, the region of convergence, the region in the z plane for which z transform is defined, for which the z transform converges. ठीक है. अच्छा, one more thing, z upon z minus a. तो यहां से मुझे इसका pole बता दीजिए. What is the pole? Pole is that value of z where the function is undefined. Okay, so if I put z equal to a, if I put z equal to a, at z equal to a, you get 1 upon 0 case, and that is infinity. Okay, that is infinity. Z equal to a. For a moment, a को positive ले ले. So this is like z equal to a. Okay. And I'm telling you, my ROC is outside the circle, not even on the circle. If you are on the circle, yeah, within it, GP fail हो जाएगा. Okay, so Z transform is defined only outside the circle. That means Z transform is not containing the pole, and it cannot, because pole is the value where the function is undefined. ROC is those values, those region where function Z transform is defined. So they cannot be together. Na? Always remember, most important point, ROC cannot contain any poles. It is always confined by poles. Sometimes it will go away, exterior of the pole, sometimes it will come interior. How exterior, interior, मैं बताऊंगा आपको पूरा. Sometimes it is exterior, sometimes it is interior. Okay, so if you take the next signal, okay, if you take the next example, two very famous questions and two very famous examples. Number one, a power n un. Okay, having the z transform 1 upon 1 minus a z inverse. ये formula chart में भी आएगा, but these are very important pairs, so I'm writing it separately. Provided mod z greater than mod a. Okay, and next is a power n u minus n minus 1. Okay, left sided. This one is right sided. This one is left sided. Okay, it will have the similar expression of z transform. एक minus sign का difference आ जाता है. Minus 1 upon 1 minus a z inverse, or also known as minus z upon z minus a. But here, when you solve again using GP, not everything we derive here. Okay, but again when you solve GP, you will get the condition as per the common ratio, mod z less than mod a. Mod z less than mod a. That means this particular ROC, when you come and sketch this particular ROC, again let me first draw the circle mod z equal to mod a. Okay, and now I should have a ROC which is interior of the circle. Better हम line से ही बनाते चलते, so that the illustration is clear. So any point within the circle, because on the circle mod z equal to mod a. Okay, you can take any point within the circle. Okay, this is what is the ROC. This represents the ROC, which is mod z less than mod a, interior of circle. Okay, answer again, pole अगर देखोगे तो again pole is z equal to a. So this time ROC is interior of the pole, not including pole, not equal to a, but less than mod a. Okay, but the signal here, that is left sided. The signal here, this one is right sided signal, because un, by un starts from 0 and goes to the right. U minus n minus 1 starts at minus 1, then goes to left. Okay, ये basics of signals है, ये आपको पता होगा. Okay, and this one is left sided. I am not telling that necessarily minus n आना चाहिए, minus n minus 1 आना चाहिए. But if un is right sided, u minus n, any term containing minus n, whether it is minus n minus 1, minus n minus 2, this is the specific formula for minus n minus 1 function. But if it is minus n minus 5 also, minus n matlab folding, right side ka folding, left side, and whenever you have a left side signal, ROC will always be interior. Very very important in Z transform is ROC property rather than Z transform property. Z transform property तो आपको याद हो जाएगा, very simple. But you have to remember the ROC property is very important. Okay, so how does the ROC looks like? The ROC is appearing in the form of circular regions. Circular regions, maybe exterior, maybe interior, but ROC will always look like circular regions, and those circles will be centered about the origin. ऐसा ROC नहीं मिलेगा कभी कि ये रहा आपका circle और यहाँ पे this is no. You will never get it, never ever. There will be circular regions, maybe interior, maybe exterior, या maybe between two circles, वो भी आएगा. But all such circles will be centered about the origin. Okay, ROC does not contain any poles. I explained you already. ठीक है. Now पहले इस पे आ जाते हैं. Okay, if a signal is right-sided, मैंने अभी बताया. Okay, then what is the ROC? ROC is the region in the Z plane outside the outermost pole. Okay, outside the outermost pole. It is the region. Okay, in the form of exterior circle. मैं ऐसा लिख देता हूँ. Exterior of circle लेना है. Exterior of what? Outside the outermost pole. There can be multiple poles sometime. Questions लेंगे सभी पे. Okay, similarly if you have a left-sided signal, okay, ROC, okay, is the region in the Z plane inside the innermost non-zero pole. Okay, which region? Interior of circle basically. इसको interior के form में याद रखे. Interior of a circle, and that circle will be inside the innermost pole. Okay, and if xn is two-sided, अब सबके example देखेंगे ROC will be a ring in the Z plane. Will be a ring in the Z plane. We will take an example for it, don't worry. Okay, and if the signal is of finite duration, neither completely to the right infinity nor to the left minus infinity. Okay, it is finite duration. Only some samples are there. Finite length मान लीजिए यहाँ पे. Basically finite duration in discrete time. Here I mean finite length. Okay, then the ROC is the entire Z plane except possibly Z equal to 0 and Z equal to infinity. We will see with questions why this is coming up. Okay, we will see with the questions why this is coming up. Okay. So before we take up any other question, first tell me the ROC. पहले ROC पे थोड़ा खेलते हैं. Then we will take up the properties of Z transform, but let's be comfortable with the ROC part first of all. For the DT signal shown, find the ROC. For the DT signal shown to you, find the ROC. For the DT signal shown, find only ROC. I don't want the Z transform. I only want the ROC. So one of them is A power n UN. Okay. For the A power n UN, ROC mod Z greater than mod A. So mod Z greater than 1 by 3 हो जाएगा. For A power n U minus n minus 1, ROC mod Z less than mod A. Okay. So less than 1 by 2. Less than 1 by 2. Okay. So Devdet, if you follow today's session, both are comfortably clear for you. मतलब end moment पे जितना कर सकते हो वो आज आपके लिए best हो जाएगा. Fourier transform I have covered. Okay, I started with Fourier transform and Z is going on. If that is left, only watch this much. Complete Z transform now and Fourier transform recording में पहले देख लेना आप. Okay, you don't need to. If you are done with others, then you can skip that other parts like Laplace and all. Okay, तो आज का ही कर लोगे. Sufficiently we have revised. Fourier series is also there. So see, you need to go for Fourier transform, Fourier series जो करना है. Now, logically, I have defined two different parts of the signal. Okay, now when I want to consider the overall Z transform, this Z transform will be only defined for first condition. This signal Z transform defined only for second condition. Okay, now whenever you want to take two signals together, okay, so you should consider, okay, so that both the conditions of Z are happy. Matlab you should take the intersection of them. You should consider only those values of Z which satisfy this as well as this. क्योंकि अगर एक भी condition fail हुआ, one of the Z transform will be infinity and the overall answer will be infinity. So that is why whenever two signals are coming together, maybe plus, maybe minus, maybe multiplication, yeah, whatever. Whenever two Z transforms are coming together, okay, you should always think about intersection. Okay, so let us do the common intersection. Now you want mod Z greater than 1 by 3 and less than 1 by 2. दोनों चाहिए. Okay. Greater than 1 by 3 but less than 1 by 2, that means between 1 by 3 से 1 by 2. Between the 1 by 3 से 1 by 2. और अगर इसका एक rough sketch आपने quickly prepare किया, between 1 by 3 से 1 by 2, let me take two circles, mod Z greater than 1 by 3. Okay, there is a circle, there is the first circle, okay, having the radius 1 by 3. There is another circle, radius 1 by 2. Okay, what is the ROC? Greater than 1 by 3, less than 1 by 2, and that is why when you sketch it up, Again, let me sketch the ROC by this pink shaded lines. How is that ROC coming up? Now tell me whether it is exterior, whether it is interior. No, it is neither completely exterior, not completely interior. It is a ring. Like a wheel aega. It is a ring. Why? Because the signal is two-sided. Because the signal is two-sided signal. It contains a right-sided component also, left-sided component also. So you are given a two-sided signal whose ROC is coming out to be a ring. That is why what I meant by the last point. Okay, ROC is coming out to be a ring. Always for two-sided signal, ROC will be a ring. Yeah, maybe for some of the two-sided signal, ROC may not exist. Aisa bhi hoga. If there is ROC, it will be ring. Okay, ROC hamesha exist ho, not necessary. But if I reverse this, suppose agar isko 1/2 kiya, isko 1/3 kiya, can there be ROC? 1/2 isko kiya, 1/3 isko kiya. So you want mod Z greater than 1/2. Okay, but less than 1/3. Is it possible? You want greater than 1/2, less than 1/3, it will never be possible, na? Think, 1/2 se bada hona chahiye, 1/3 se chota. There cannot be any intersection. Both cannot be satisfied simultaneously. So ROC does not exist there. ROC does not exist there. ठीक है? और जब इसका आप expression निकालोगे ना, so you will get the poles also correspondingly. There will be pole at 1/3, there will be pole at 1/2. ठीक है? चलो. Next question, tell me. Xn, half power mod n minus of minus 2/3 power n un. Find the ROC. पहले ROC का comfort zone. Half power mod n minus of minus 2/3 power n un. Tell me. Half की power mod n minus of minus 2/3 power n un. Okay, so let me write down the ROC for both of them individually. Okay, what is the ROC for this one? A power mod n. अच्छा, A power mod n का ROC. Okay, we can derive again two-sided signal है, but ठीक है. Let me tell you, अब हर कुछ अभी derive नहीं करेंगे. Where is that? Let me come up here. We will come to this formula sheet. ठीक है. But yeah, one signal let me take right now. Okay, A power n. A power mod n. You know how do we write down A power mod n? Okay, A power mod n. Okay, if n is positive, it will be n. A power n un. And if you take negative value of n from -1. U minus n minus 1 लोगे, तो for A power mod n, it will be A power minus n. My negative value के लिए mod x is minus x ना? Okay, and then again, as I am explaining you the superposition, intersection. Okay, mod z greater than mod a, but less than mod 1 by a. ये 1 upon a power minus n है. Okay, so that is what mod z greater than mod a, but less than 1 upon mod a. That will be the ROC. Again, a finite ring coming up. Again a ring coming up. Why ring coming up? Again two-sided signal hai. So for A power mod n, you can directly note the ROC is mod a less than mod z less than mod 1 by a. Mod a less than mod z less than mod 1 by a. So if I go back to my question here, what is the ROC here? Okay, 1/2 less than mod z less than 1 upon 1/2, that is 2. That is one of the ROC. Clear everybody? Now, intersection with, what is the second ROC? Now dear, even if A negative does not matter, what you want? देखो आपको केवल ये देखना है, right or left. It is right. Un means right. U minus n कहीं पे भी आया, that is left. Okay, right means mod z greater, left means mod z less than. तो mod z greater than something. Okay, mod z greater than something. तो greater than what? Greater than 2/3. Greater than mod a होता है ना, तो even if you take mod a, it will be 2/3 only. So don't worry, there can be negative value also. ठीक है, आपको तो mod a लगाना है. You will write 2/3. Now what is the intersection? 1/2 से 2 and mod z greater than 2/3. 1/2 से 2, okay, and mod z greater than 2/3. Mod z between 1/2 से 2 and it should be greater than 2/3 also. भाई देखो ना, what is the common? पहले आएगा 1/2, then आएगा 2/3 and then आएगा 2. You want this much also and you want greater than 2/3. Any value greater than 2/3. So what is the common? 2/3 से 2. ये common में नहीं आएगा. 2/3 से 2. So what is the final ROC? 2/3 is less than the mod z is less than the 2. 2/3 is less than the mod z is less than the 2. Clear? 2/3 less than mod z less than 2. Hope that is clear. Hope that is clear. ठीक है. अच्छा, अब again you will be feeling it in the form of ring. Okay, now let me ask you one question here. Dear, please tell me, before I tell you the answer, please tell me, will the Fourier transform of this signal exist? Link करेंगे आप दोनों को. Let us link and study. Very last moment में it is important to link the topics and learn like that. Will the Fourier transform of discrete time signal, I'm asking DTFT. Will the DTFT of this signal exist? will the DTFT of this signal be defined? Yes or no? बस yes or no बताइए. What is the DTFT? वो मुझे चलो नहीं चाहिए आपसे. But will the DTFT of the signal be defined? Okay, rough sketches बना रहा हूँ. Don't worry about neat and clean sketches. ROCs again, because of two-sided nature of the signal, ROCs again coming up as interior of a circle. Will the DTFT for the signal exist? So it has a pole at 2 by 3 and it has a pole at 2. Yes, the DTFT of the signal will exist. Why? Yes, the DTFT of the signal will exist. Why? Link करके पढ़ेंगे. बहुत easy हो जाएगा. Okay, just have patience. Don't be confused. थोड़ा patience रखना. At the end, you will feel comfortable. At the end, you will feel comfortable. So what is the relation between the DTFT and ZT? What is that relation between the DTFT and ZT? Okay, we know that Z transform XZ is defined as what we are discussing now, summation of xn z ki power minus n from n equal to minus infinity to the plus infinity. From n equal to minus infinity to the plus infinity, where z in general is a complex variable given by r e power j omega. Okay, r e power j omega, where r is the magnitude and omega is the phase we take. Okay, r e power j omega. Okay, this is what is in general the value of z. In the z transform, z being a complex variable given as z equal to r e power j omega. Okay. If you consider special value mod z means r equal to 1. That means if you want to define the z transform only on the unit circle. Okay, only on the unit circle. Okay, so what will be the value of z first of all? R ko 1 rakha to z is e power j omega. So you have the function now equivalent to x of z means x of e power j omega. X of e power j omega. अच्छा, ultimately x of e power j omega is x of omega only ना भाई. अंदर हम क्या लिखते हैं? Function depends on what? Function depends on e power j omega. मतलब ultimately depends on omega. Okay, x of omega. Okay, x of omega. Okay, and that is equal to, now the formula, summation minus infinity से infinity, x of n, z power minus n, z is e power j omega, तो e power minus j omega n, और इसी को मैं DFT में convert करके बताऊंगा. Just wait, we will link everything. Later on, we will convert this formula only to DFT with some specific conditions. Okay, so this is the DTFT formula. But only condition is, you have defined it from Z transform over unit circle. Okay, I can say that DTFT is the value of the Z transform evaluated over unit circle. Okay, over unit circle. Right, mod Z equal to 1 का मतलब क्या हुआ? Mod Z equal to R is circle, but radius 1 लिया है मैंने. So that is unit circle. Okay, this will only exist. Okay, this will only exist if what condition is true? If we are defining from Z transform, पहले Z transform देखोगे. Z transform is defined where? Z transform is defined in the entire ROC, region of convergence. Okay, that ROC should contain unit circle. Logical enough? पहले तो Z transform defined होना चाहिए ना. Z transform is defined for the ROC, and that ROC, if it contains unit circle, you can go and apply this value. Clear? ठीक है. Thank you. God bless you, Adil. Hope you perform best. Okay, so ROC should contain the unit circle. Okay, this is the definition. Same thing. Xn e power minus j omega n, and DTFT will only converge if the ROC of xz contains the unit circle. If ROC of xz contains the unit circle. Okay, if ROC of xz contains the unit circle. Okay, just like the continuous time Fourier transform. Okay, the DTFT, again Dirichlet's condition coming up here. पहले इस पे नहीं आते. Where is the Dirichlet's condition? ये हो गया IDTFT का फॉर्मूला. IDTFT 1/2 integral over one time period x omega e power j omega into omega, where the one time period will be 2 pi. I will explain this point. अभी wait करेंगे. I will explain this point. Come here. Okay, like the Dirichlet's condition for CTFT. Okay, the Dirichlet's condition. Okay, for the CTFT was the signal should be absolutely integrable. Here in discrete domain, the signal should be absolutely summable. Its DTFT will exist. But let us learn from Z transform point of view. This is an individual condition. Okay, if the signal is absolutely summable, that is summation mod xn for all values of n, if it is finite, then the DTFT will exist for sure. Okay, otherwise I can say that ROC should include the, if you think from Z transform point of view, ROC should include the unit circle. Okay, so if I want to talk about important DTFT pairs, I will show you the formula. Okay, but before I show you the formula, let us pick up the same signal that we were discussing in Z transform also. Suppose xn is equal to a power n un. Suppose the xn is equal to a power n un. Okay, what is its DTFT? Again, you solve by the formula. What is its DTFT? So rather than again solving by the summation formula, we know it's Z transform 1 upon 1 minus a Z inverse. But Z transform has the ROC, mod Z greater than mod A. Okay? Ab dekho. What is going to be the DTFT then? What you have to only do is put Z equal to e power j omega. Put Z equal to e power j omega. Okay, so what is x omega? What is x omega? 1 upon 1 minus a, z की जगह e power j omega, तो z inverse is e power minus j omega. That is the DTFT. Answer आ गया. Why to again solve the same summation? Why to again apply GP? Again GP will come. You solve by the DTFT formula. Again GP will come. But why to take GP? Why to take the GP? So 1 upon 1 minus a e power minus j omega. Clear? Okay. But there is a condition. The Z transform can only be converted to DTFT if the unit circle exists. If the unit circle exists. Okay, this is the ROC. This is the ROC of the Z transform. Okay, will it include unit circle? This ROC, will it include unit circle? कैसे बोल सकता हूं मैं? Will it include unit circle? Or not? Suppose, understand like this. If I tell you mod Z is greater than half लिया, unit circle means radius 1. So radius 1 will come. But if you take mod Z greater than 2, if you take mod Z greater than 2, 2 के बाहर गए आप, unit circle तो अंदर छूट गया. Unit circle has radius 1. So if you take mod Z greater than 2, unit circle cannot come. Okay. So you have to take any value here which is less than the unit circle. Okay, that means if this value of mod A is less than 1, ये यहाँ पे भी copy करूँगा. Okay, so x omega will be 1 upon 1 minus a e power minus j omega for mod omega less than 1. That is again your DTFT pair derived directly using Z transform. Similar formula, easy to remember. इसलिए link कर रहा हूँ मैं. Similar formula, easy to remember. ठीक है. So as of now, I'm not thinking for any break. Let's see. Okay, अगर बहुत ज़्यादा uncontrollable होगा तो break करेंगे. Guys, you guys are free. You are watching maybe on the mobile, laptop, whatever. You can have a tea, coffee, some snacks. देखते रहो, no problem. Notes तो आपको मिल ही जाएंगे. Even if you are worst case very hungry, manage with the class. I तो cannot have. Even I am feeling little bit hunger now. Okay, but I cannot eat in between ना. Okay, you have the flexibility. तो आपको तो टेंशन नहीं होना चाहिए. टेंशन मेरे को होना चाहिए. जब मुझे बहुत टेंशन होगा तब मैं ब्रेक कर दूंगा. ठीक है? So let's continue. I don't want to break, at least right now. If possible, I will give a break, but at least not now. ठीक है, चलो देखते हैं. If possible, I'll give the break, but not right now. So this is how important DTFT pairs will come up. I'll show you the formulas list also. Okay, don't worry. So we have a connection. We have a clear-cut connection. Okay, between the DTFT and the Z transform. Okay, now always remember one more important point, that the DTFT spectrum x omega, when you replace omega by omega plus 2 pi, you will again get back omega. In this basic formula, when you put omega plus 2 pi, e power j2 pi का जो extra term आएगा, e power j2 pi always 1. No need to prove, but I'm directly telling you x of omega plus 2 pi will always be x omega. Always. That means DTFT, unlike CTFT. Continuous time Fourier transform periodic होता है क्या? No, I did not say any such result. But DTFT, discrete time Fourier transform, is always a periodic function. Okay, with the period 2 pi. With the fixed period 2 pi. ठीक है? With the fixed period of 2 pi. So I was asking you a question here. Okay. I was asking you a question here. Yeah. Will the DTFT of the signal exist? Now you can tell me, na? Will the DTFT of the signal exist? Okay. 2/3 और 2 के बीच में unit circle आएगा ना? Definitely the unit circle is between 2/3 and 2. Unit circle included है. Unit circle included है. Okay, so for the given signal, DTFT will also exist. सिर्फ इतना पूछा था, exist करेगा या नहीं करेगा. ठीक है, that is what I wanted right now. Okay, so yes, the DTFT will exist for this signal. Okay, DTFT will exist for this signal. ठीक है. ठीक है. Now, time to note down some important Z transform pair. We will solve the questions, but as always, before the questions, you always need what are the pairs which are very, very important for you. That must be known to you. Okay, what are the pairs which are very, very important that directly should be there in your dictionary always? Like impulse having the Z transform 1. Okay, entire Z plane for all values of Z. Okay, A power n un having the Z transform. Already we derived this 1 upon 1 minus AZ inverse and Z upon Z minus A mod Z greater than mod A. ठीक है. A power n u minus n minus 1. Okay, तो negative of the value minus Z upon Z minus A mod Z less than mod A. ROC को याद रखने का एक और तरीका. Even if you don't look into this, what is the way to remember ROC? Pole A. Okay, pole A. ठीक है, but one is right sided तो mod Z greater exterior जाएगा. Another one u minus n आया तो left sided तो mod Z less than mod A. Mod Z less than mod A. Okay, then already I discussed A power mod n. Next, n A power n un. Okay, this is to be derived by Z differentiation property. Property भी आगे बताऊंगा. n A power n un. AZ inverse upon 1 minus AZ inverse whole square या AZ upon Z minus A whole square mod Z greater than mod A. Again देखो ना, un right sided. Pole is still Z equal to A. Repeated pole है, but the location is same. Z equal to AA. Same location, but right sided signal. तो mod Z greater than pole. ठीक है. Now similarly A का value 1 रख देंगे ऊपर वाले में. Nothing. Put A equal to 1 in the above case. Sorry, इसमें नहीं, इस वाले केस में. A power n un में अगर A का value 1 रखेंगे तो you get unit step answer. Okay, so what is the Z transform for unit step signal? 1 upon 1 minus Z inverse. A को 1 रखा या simply Z upon Z minus 1. तो mod Z greater than 1. Okay, and in this formula when you put A equal to 1, so NUN, that will be NUN ramp signal. Okay, so we come to, let me keep writing important. This is for step. This is for, ये वाला नहीं. This is for ramp. NUN. Okay, same formula. A का वैल्यू 1 रख देंगे तो Z इनवर्स अपॉन 1 माइनस Z इनवर्स होल स्क्वायर या सिंपली Z अपॉन Z माइनस 1 होल स्क्वायर. ROC लॉजिक से समझ में आ रहा होगा. ठीक है. Cos ओमेगा n sin ओमेगा n. ओके, फॉर cos ओमेगा n सॉल्विंग बाय, अगेन हाउ डू वी सॉल्व फॉर cos ओमेगा n? हिंट बताता हूं. e पावर j ओमेगा n प्लस e पावर माइनस j ओमेगा n बाय 2. सिमिलरली साइन का भी यूलर फॉर्मूला से सॉल्व करते हैं. वी गेट z इनटू z माइनस cos ओमेगा अपॉन z स्क्वायर माइनस 2 cos ओमेगा प्लस 1 mod z ग्रेटर देन 1. z sin ओमेगा upon z square minus 2z cos omega plus 1. Okay, mod z greater than 1. Okay. Okay, these are only, this is the list that you have to remember. Only few Z transform formula. Fourier transform में many important signals. Z transform में few of them to be remembered. Rest I will deal with the questions. Rest I will deal with the question. अच्छा, now before I go to the Z transform property, before we go to the Z transform property, अब क्योंकि टॉपिक को मिक्स करके हम स्टडी कर रहे हैं ना, so before we go to the Z transform property, what I will do here is, okay, similarly let us learn the important DTFT pairs also. उसका slide भी एक साथ देख लेते हैं. Okay, like for x omega, okay, for A power n un, I derived using Z transform. Now have a look into it. However you derive, I'll give you the final list. Okay, many of the formulas resembling the continuous time Fourier transform. Ultimately Fourier transform में many of them will be resembling here. Impulse having 1 having 2 pi del omega, duality से. Okay, e power j omega naught n. Okay, e power j omega naught n. Okay, 2 pi del omega minus omega naught. Cos omega naught n, same. Pi del omega minus omega naught plus del omega plus omega naught. Sin omega naught n, same like CTFT. Okay, a power n un, 1 upon 1 minus a e power minus j omega. ठीक है, तो मैं एक काम करता हूँ ना. Okay, 1 upon 1 minus a e power minus j omega. ये Z ट्रांसफॉर्म से लिंक करके समझ लीजिए. ओके, a power n u minus n minus 1, सेम आंसर. 1 upon माइनस आएगा, सॉरी I missed that minus here. Minus 1 upon 1 minus a e power minus j omega with the condition mod a greater than 1. n a power n un, a e power minus j omega, like AZ inverse, a e power minus j omega upon 1 minus a e power minus j omega whole square mod A less than 1. Okay, then you have un. Okay, 1 upon j omega plus pi del omega, like the CTFT, 1 upon j omega plus pi del omega. Okay, rect n by 2n. Okay, this is not sampling. Okay, rect n by 2n will give you sine n plus 1 half omega upon sine omega by 2. Sampling an, this is like CTFT. Okay, this is like CTFT. Okay, sampling an, pi by a rect omega by 2a. What is that, Manogna? Pi by a rect of omega by 2a. Only these many DTFT pairs you have to remember, important for the exam. Okay. Now, properties bhi dono ki cover karte hain, then let's go to the question. So, important Z transform properties to be remembered, and then we are starting with the question. Z transform pair हमने complete किया था. Now, important Z transform property. Some of them are very basic again. Okay, like linearity property. Okay. Okay. Rect n by 2n, Ankit. Okay, we'll come back once to DTFT. Okay, rectangle from minus n to plus n. Okay. What, Manogana? What, one more time? Please say what point. Okay, linearity. Okay, if two signals are added, Z transform are added. Acha, in the property of Z transform, nothing to remember about ROC. Kuch yaad mat rakhiye. You will feel, why not to remember? If you have understood these properties of ROC, na, agar aapko ye clear hai, you don't have to separately remember ROC condition. Okay, you don't have to separately remember ROC condition with respect to the Z transform property. ROC ka concept and important points, if you are able to remember, nothing else you have to remember in this table. For formality, for completion of notes, I have given you. Okay, but we will not focus here. And in the question also, you will feel not required. We will solve by logic of ROC. Okay, so for completion of notes, as a formality, I have written. DFT to be not yet started, Manogana. Okay, DFT to not yet started. Okay, time shifting, x of n minus n naught, Z transform will be Z power minus n naught into xz. Okay. Scaling in the Z domain, okay, x of z by z naught corresponds to the time domain signal z naught power n xn. Abhi question aayega sabhi pe. So z naught power n xn has the Z transform x of z by z naught. ठीक है. Time reversal, x of minus n having the Z transform x1 by z. Conjugation, okay, x conjugate n will have the Z transform x conjugate z conjugate, x star z star. Okay, time difference, xn minus 1. This is just like time shift. This is just like time shift result only. Okay. So xn minus 1, okay, out of which xn minus 1 का z transform कितना होगा? Okay, z power minus 1 xz. Okay, so z power minus 1 xz common 1 minus z inverse. This is known as the time difference. Basically, there cannot be any time differentiation for discrete. So we write down the time difference property resultant from time shift only. Okay, then accumulation. Rather than integration, we have the accumulation. Okay, summation of xk. Summation of xk. Okay, from minus infinity to n. xz upon 1 minus z inverse divided by this factor. xz upon 1 minus z inverse. Convolution. Okay, two signals are convoluted. Z transform will be multiplied. xz into yz. Okay, differentiation in the z domain. n into xn. Okay, n into xn, also known as the n times property. जैसे t times property देखते हैं continuous में. This is n times property. n into xn. Okay, n into xn having the z transform minus z d by dz of xz. Minus z d by dz of xz. Okay, these are the properties. केवल इतना focus रखना है z transform की property से. Okay, now we will take up questions to make it more clear. अच्छा, let me also tell you which Z transform properties are more important for question. Okay, वो भी highlight कर देता हूँ. ठीक है. Scaling in the Z domain important one. Time shifting moderately important होता है. ठीक है, मैं mark कर देता हूँ. Then you have time reversal. Conjugation, time difference not important. Accumulation not that important. Convolution is very fundamental. वो आपको पता ही है. Z differentiation important. That's it. So few properties are more important. Okay, few properties are more important. Okay. Which of the Z transform? See, Manogana, very, very clear. I am not deriving any of the property because if I derive each and everything from signals, not even n number of days will be sufficient. We have to cover up. Okay, so which particular property not understood? Question se shayad aur samajh mein aayega, to you can wait for the question also, but you can specify. And why I will repeat all the properties. So be always specific in the doubts. Okay. And nothing, to be very honest, I have not explained the properties, I have listed the properties. ये भी बता देता हूँ. Okay. Whatever needs to be explained, I'm giving time. Whatever needs to be taken down, please take down. Okay, that is how revision will work actually in the last time. So properties मैंने explain किया भी नहीं. I've told you this is the property existing and इसको देखना ही नहीं है. Forget this. Okay. Why you have not to see that? You will see with the question. Not required. Okay. Okay. Similarly, DTFT pairs देखा ना, DTFT property. अच्छा, in the DTFT also you felt many of the Fourier transform pairs are like CTFT, are like CTFT. Okay, are like CTFT. Okay, are like CTFT. Okay, like delta n. Okay, I will keep mentioning for you to remember. Fourier transform पे तो बहुत सारे फॉर्मूले आपने अच्छे से याद किया. Okay, this is also like CTFT. Okay, let me just give a tick mark. Like CTFT, this is also like CTFT, similar to the CTFT formula. Sin omega naught n also similar to the CTFT formula. Okay, then sampling an similar to the CTFT formula. Few are different, few are at least resembling. Now DTFT properties. Okay, again many of them will be like the CTFT properties. Okay, like linearity, those two signals added, DTFT exist. Okay, time shift, exponential term, x of n minus n naught e power minus j omega n naught, very same like CTFT. Frequency shift, e power j omega naught n. Okay, phase in the time domain, shift in the frequency domain, again with the opposite sign, here minus omega naught to here plus omega naught. Okay, so this is also okay. Okay, same like CTFT. Okay, half period shift, ये एक नई चीज है यहाँ पे. What is the period in DTFT is 2 pi. If the period is 2 pi, what is the half period? If the period is 2 pi, what is the half period? Half period will be pi. 2 pi total period, half period pi. So when you put e power, special case है, when you put e power j pi n, e power j pi whole power n कर दिया मैंने, and e power j pi will be -1. Cos pi, j sin pi. Sin pi 0 होता है, cos pi -1. So you get the property -1 power n, and that is coming from, okay, omega naught corresponding to, okay, omega naught corresponding to plus pi or minus pi, anything, both will be equivalent. Okay, so that will be x omega plus minus pi. So that is what is half period shift. -1 power n xn has the DTFT, x of omega plus minus pi. Okay, the shifting corresponding to half of the period. Okay, time reversal same like CTFT, x minus n having the DTFT x minus omega. Conjugation same like CTFT, x conjugate n having the DTFT x conjugate minus omega. Time difference not very important, but this cannot be same like CTFT, na? Because in continuous time we talk about differentiation, in discrete time there cannot be differentiation, so I only write time difference. It is again resultant from time shift. xn ka DTFT x omega, xn minus 1, x omega e power minus j omega. Time shifting. Okay, time shifting. ठीक है, accumulation summation x के x omega upon the factor 1 minus e power minus j omega plus pi x0 del omega plus pi x0 del omega. Okay, frequency differentiation property just like CTFT. txt j d by d omega of x omega same, and xn. Okay, j d by d omega x omega. Convolution in time, multiplication in frequency same. Multiplication in time x1 and x2n, 1 upon 2 pi. Convolution in frequency same like CTFT. Modulation also same like CTFT. Wherever any signal multiplied by cos omega naught n, its spectrum is shifted to higher frequency, x omega minus omega naught, x omega plus omega naught. Right and left shift both, and amplitude whole divide by 2. Same modulation theorem like CTFT. तो properties में आप देखोगे ना, except this difference and accumulation, all the properties are same like CTFT. जहां जहां मैंने tick mark किया, that is same like CTFT. So that means, you know, for mostly you have to remember one side property, others you can directly copy, na? Others you can directly remember. Okay, so the CTFT and DTFT property, most of them are like similar. Okay, are like similar. Okay, so that makes it easy for you to remember. इस तरीके से आप revise करोगे तो ज़्यादा important रहेगा, ज़्यादा helpful रहेगा. See, if you are learning from the first time, for the first time, okay, then you can everything derive from the scratch, everything learn from the scratch. But here you have to link, because you are revising up the things right now, so that connection has to be there with you. ठीक है, next. All the properties, and then Parseval's again like okay, the CTFT Parseval's is there. Energy of the signal in time domain, summation mod xn square. By the Parseval's theorem, in the frequency domain, it is 1 upon 2 pi integral mod x omega square d omega. Again the same, but the only difference is this limit. Okay, limit not minus infinity to infinity, limit is only over 2 pi because the Fourier transform is only periodic, is always periodic over period 2 pi, and it is only sufficient to consider its value for a period of 2 pi. So integral over 2 pi. So when I say integral over 2 pi, again, when I say integral over one time period, you can take it as integral 0 se 2 pi also, or you can take minus t by 2 se t by 2 also. Minus pi se pi bhi le sakte. That is what is the Parseval's relation. Okay, like area under curve, we have the summation property that I explained you with respect to Z transform as well. Okay, summation. Like, you know, x omega, the DTFT basic formula is summation of xn e power minus j omega n. Omega ko kar do 0. Put omega 0, you get summation xn. Okay, and that is also known as the low frequency gain, omega equal to 0, DC gain. That gives you the property sum of series. Okay, the gain at low frequency, okay, that is the DC gain, basically. Gain at low frequency, that is omega equal to 0, will give you the summation of xn. Okay, and gain at high frequency, so what is the high frequency? We know that DTFT is periodic for a period of 2 pi, and one period, if you take minus pi se pi, okay, pi is known as the high frequency. Pi is known as the highest frequency in the discrete domain. So what is the high frequency gain? Whenever I say high frequency here, that means omega equal to pi. Okay, so again in the DTFT formula, when you put omega equal to pi, यहाँ पे जब pi रखोगे तो e power minus j pi n, and what is e power minus j pi n? E power minus j pi already explained to you, minus 1. So you will get here minus 1 ki power n. Minus 1 ki power n, then multiplied by xn. Then multiplied by xn. So what does it basically mean? इसको use कैसे करेंगे? Okay, what is x0? Low frequency gain x0. Okay, low frequency. If you talk about x0, okay, that is summation of xn. Okay, what is summation of xn? Add all the values, x0 plus x1 plus x2, etc. Okay, but when I talk about high frequency, omega equal to pi, what is x pi? It is given by summation of the minus 1 ki power n xn, and what is that value? Okay, that will be x0. Dekho, whenever you take any odd value, minus 1 power odd will be minus 1, so minus x1 aega. But when you again take even value of n, minus 1 ka square will be plus 1, so you get plus x2. Then you get minus x3, and etc, etc, etc. That is what is the x pi. That is what is the value of x pi. Okay, that is what is the x pi. Alternate plus minus, and x0 is summation of all values of xn. It is the summation of all values of xn. Okay, now we will go back to some questions. Okay, Z transform ke bhi and DTFT ke bhi, and then we will take the questions on system based also. Causality, stability of system. But पहले कुछ basic questions से start करते हैं. Find the Z transform of. Okay, चलो. So yeah, Ankit, you had some doubt. I think it is removed. I was waiting for my content to be covered. If you have that doubt, Ankit, once again, I could not read it completely. If you have the doubt, please post it again. If it is clear, then no problem. We'll give you Telegram link bhi denge. Okay. Find the Z transform of 3 power n u minus n minus 4. 3 power n u minus n minus 4. Tell us the answer for this. 3 ki power n u of minus n minus 4. बताइए 3 की पावर n u minus n minus 4. So basically somehow time shifting दिख रहा है ना, somehow time shifting दिख रहा है. Let me start with 3 power n u minus n minus 1. Okay, 3 की power n u minus n minus 1, because we know it's direct formula, a power n u minus n minus 1. What is the Z transform? Okay, minus 1 upon 1 minus a z inverse, 1 minus 3 z inverse. ROC एकदम last में लिखेंगे, don't worry about ROC at all right now. Okay, minus 1 upon 1 minus 3 z inverse, and you can also write it as minus z upon z minus 3. जो भी form में लिखना है, you can look into options whether it is positive power or negative power. ठीक है. Now 3 power n u minus n minus 1 है, but I want till minus 4. Okay, so what can I do is, okay, let me replace, ध्यान देना यहाँ पे, inside the unit step, let me replace the n by n plus 3. Please pay attention first. तो minus n minus 3 minus 1. Minus 3 minus 1, वहां से minus 4 आएगा. That means somehow I have to make n as n plus 3, and that calls for time shifting. Okay, but if I do time shifting, I have to do for the entire signal. So 3 power n nahi, 3 power n plus 3. You have to make n as n plus 3. And as per the time shift property, n plus 3. Okay, so z power plus 3. Right, the z power minus n naught, if it is xn minus n naught, xn plus n naught है तो z power plus n naught, same sign चलेगा, तो z power 3 into this expression minus z upon z minus 3, correct? Okay, now we only need 3 power n, तो उसको split कर देंगे ना, 3 power n into 3 power 3, because 3 power 3 is just a constant. And then this is u minus n minus 4, that is having the z transform, minus of z की power 4 upon z minus 3. So what is your answer now? 3 power n को divide कर देंगे. Okay, 3 power 3 को divide करेंगे, sorry, that is a constant. So 3 power n, u of minus n minus 4 is having the z transform. What z transform? Divide by 27. So you have minus z की power 4 upon 27 z minus कितना है? Z minus 3. Now tell me what is the ROC? Without looking, without following any property, just by looking into the signal, what is that ROC? ROC, देखो पोल आपको पता चल गया ना, that is sufficient. Pole is Z equal to 3. Okay, so ROC, only single pole ना, तो ROC less than or greater than minus n, left-sided signal है. Okay, this simply tells that it is a left-sided signal. So for left-sided, ROC is also left-sided. Mod Z less than 3. खत्म हो गया. Okay. No, nothing like that. No. The DC term corresponds to summation of signal. Pi x0 del omega you are telling, na? That x0 you are talking, yes, that is the DC term. Not the entire term. Pi x0 del omega, that x0. अच्छा वहां पे x omega printed है क्या? I will check it out. It should be pi x0 del omega. आप बोल रहे हो pi del omega x e power minus j omega. Pi x0 आएगा वहां पे. I will check it out. We'll check it out. Okay. That should be DC term. Got it, Ankit? ठीक है? Next है जी. Next question. Okay. Consider a signal whose Z transform is 3z upon z minus 3 whole square mod z greater than 3. Find the inverse Z transform for x of z inverse. Okay. Inverse Z transform for x of z inverse. Tell me. X of z inverse. What is x of z inverse? X of 1 by z. Whose Z transform is x of 1 by z? Time reversal property. Okay. So dear, here you have, okay, here you have yz. Suppose this is yz, which is x of 1 by z. Okay, and that is the Z transform for x of minus n. So the signal yn, okay, whose inverse Z transform for xz is yn, that is x of minus n. That is x of minus n. Okay. Akansha, first of all, in the DTFT, first of all, make the language clear. DFT तो अभी हमने start ही नहीं किया है. It is DTFT. Okay, and in the DTFT there is no ROC. Okay, that is the condition mod A less than 1. You can understand by two logic. Number one, Dirichlet's condition. And number two, I explained already, for DTFT to exist, ROC, if you go back to the Z transform ROC, that should include unit circle. Okay. Any of this logic says mod A less than 1 hona chahiye. Okay. So what is xn? Dear, this is of the form, AZ upon z minus a whole square. AZ upon z minus a whole square. Okay, and that is the DTFT pair. Okay, what should be xn then? AZ upon z minus a whole square mod z greater than mod a. That is n a power n un. What is the value of a? A का value 3 है. That is n 3 की power n un. Question solved. Property based है. Okay, one formula and one property required here. So what is the value of yn here? What is that yn? X of minus n. So place minus n there na. X of minus n. ये हो गया minus n. 3 की power minus n. U of minus n. Okay. So the value of yn is minus n. 3 power minus n को 1 by 3 power n कर देते हैं. U of minus n. Check your answers. It's A. Check your answer. It's A. Clear? It's A. Done hai? Next question. Two causal discrete time signal xn and yn are related. Yn is summation of xm. Okay. If the Z transform of yn is given to you, find the value of x2. Find the value of what? Find the value of x2. Two causal discrete time signals xn and yn are given to you. Okay, and they are related. Summation of xn. Okay. So dear, if yn is summation of xm, okay, from 0 to n. See, actually minus infinity से n भी लिख सकते हैं, but because xn is a causal, okay, both of them are causal. Okay, this is also equivalent to summation of xm from m equal to minus infinity से n. Okay, because of causality. Causal है ना? Even if you write minus infinity to n, calculation will be 0 to n only for positive value of time because of causality. Okay, now when you write it in this form, it is nothing but the accumulation property. What is y omega? What is yz? Sorry, z transform की बात चल रही है. What is the z transform? Yz accumulation property में it is given by x of z. Okay, accumulation of xm, x of z divided by 1 minus z inverse. That was the formula. And yz given है आपको. The z transform of yn is given to you. Okay, we can talk about xn from there. Okay, so देखो, let us link these two now. Y of z, okay, जो कि given है मुझे 2 upon z, z minus 1 square. बेसिक प्रॉपर्टी में ना कई बार 2 मार्कर क्वेश्चन बनते हैं, एंड दैट इज इक्वल टू xz अपॉन 1 माइनस z इनवर्स, xz अपॉन 1 माइनस z इनवर्स एंड मल्टीप्लाइंग बाय z थ्रू आउट, तो z अपॉन z माइनस 1 फॉर्म लिखेंगे xz. वन ऑफ द z गॉट z माइनस 1 कैन गेट कैंसल्ड. व्हाट इज xz बेसिकली 2 z shifting here, तो z square and one of the z minus 1 is only left. 2 upon z square z minus 1. Okay. We can now convert this in the form of z upon z minus a. A का value 1 है. Okay, so let me write it in the form of z upon z minus 1. But if there is z in the numerator that I am multiplying, I have to divide also. तो z cube हो जाएगा denominator में. Now we know whose z transform is. Okay, now we know whose z transform is z upon z minus 1. Whose z transform is z upon z minus 1? Unit step signal. Unit step has the z transform z upon z minus 1, right? Okay, तो 2 तो constant है. This should be unit step if there is no z cube term. But there is a z cube term. अच्छा, what is the role of this z cube term? Okay, this is like 2. Okay, z की power minus 3 into z upon z minus 1. Z power minus n naught corresponds to time shift. Corresponds to time shift. Time shifting by 3. Okay, u of n minus 3 same sign चलेगा. Minus 3 तो u of n minus 3. So your xn is 2un minus 3 and we know what is the unit step signal. Okay, it will be only 1, so answer will be only 2. Okay, for n greater than equal to 3, n minus 3 should be greater than equal to 0. Okay, and that means if you take n less than 3, इसके opposite जाओगे, answer should be 0. Unit step will not exist. Okay, so question में numeric value पूछा है, what is the value of x2, and the answer is 0. Why? क्योंकि यहाँ से मैंने बोला x of 2 when you take n equal to 2. Okay, it comes for n less than 3 case and the answer is 0. And the answer is 0. Okay जी. Next, MSQ question. MSQ आएगा, पासवर्ड भी आएगा. At any time, at any point, at any time, at random password can come up. Consider the following statements regarding an absolutely summable signal xn which is known to have a pole at z equal to half, and choose the correct options. Which is known to have a pole at z equal to half and choose the correct options. Which is known to have a pole at z equal to half and choose the correct options then. Choose the correct options. Okay, there is an absolutely summable signal. Absolutely summable signal है मतलब we can also say that DTFT will exist. पहले तो conclusion बनाते हैं. I told you ना, if a signal is absolutely summable, then DTFT also exists. Dirichlet's condition. And if the DTXZ exists, now link the ROC condition. Okay, that means ROC of the Z transform. Okay, ROC of whatever the Z transform. Okay, will include what? Okay, will include unit circle. So that ROC contains unit circle. Clear? That ROC contains unit circle. And it is known to have a pole at Z equal to half. There is a pole at Z equal to half. अब इनमें से कौन कौन सा ऑप्शन करेक्ट हो सकता है? कैन इट बी ऑफ फाइनाइट ड्यूरेशन? नो, फाइनाइट ड्यूरेशन कैनॉट हैव एनी पोल्स because what is the ROC for finite duration? Entire Z plane. If there is a pole, maybe 0 or infinity in the properties I told you. If there is a finite duration या finite length signal, okay, it may only have poles at 0 infinity. वो भी sure नहीं है, sometimes yes, sometimes no, but no other pole. So this cannot be finite duration. This cannot be finite duration, not at all. Now, can it be left-sided, right-sided, or two-sided? It is known to have a pole at Z equal to half. It is known to have a pole at Z equal to half. It is known to have a pole at Z equal to half. Of course, there is a pole at Z equal to half. अच्छा, did I say Z equal to half पे एक pole है? Okay, so can you take interior? If you take interior, unit circle is missed, na? So interior not possible. Interior comes for left-sided. Interior comes for left-sided. So left-sided also not possible. Left-sided also not possible. Can it be right-sided? Okay, definitely. Okay, this is the pole at half, na? Definitely you can go right to it. Okay, because if you go right to it, then only the unit circle can come, na? Absolutely summable है तो unit circle आना चाहिए. Unit circle आना चाहिए. Unit circle should come. Okay, unit circle having radius 1 will come. So definitely one possibility is it could be right-sided. Yes. Could it be two-sided also? Two-sided के लिए ROC should be a ring. ROC should be a finite ring, strip, okay, or wheel type of structure. But where is the other pole? For ROC is always bounded by poles. Na ring भी होता है तो ring is always between two poles. Dear, in the question it is given that it is known to have a pole at Z equal to half. Did I say in the question there is only one pole and that is at half? There is a pole at half. There may be other poles which are not specified. There may be other poles which are not specified. So there may be, okay, the number one case is, okay, there is only one pole, okay, and that is at half. Okay, next case can be, okay, there is one pole at Z equal to half. Okay, and there are other poles, okay, but they are outside unit circle. इसमें possibility बताता हूँ. There are some other poles which may be outside the unit circle. Okay, first of all, there is a circle passing through the radius half, and suppose there is another pole at 3. Anything let me take. There is another pole, suppose at 3. One of the pole is at half, तो वो तो question में given ही है. Suppose I take another pole at 3, and in that case also unit circle will come, na? Okay. Dear, in that case also unit circle will exist, na? Unit circle will exist, na? Okay. So it could be two-sided as well. It could be two-sided as well. So correct answer is C and D for this multiple select question. The correct answer is C and D for the multiple select question. चलो डन है जी. नेक्स्ट क्वेश्चन देन. नेक्स्ट क्वेश्चन C and D correct answer. This was done earlier only based on the coefficient concept. This was 40. Next question. Yeah, before the next question, guys, important update that the last All India Open Mega Mock for GATE 2024 is live. When I say Open Mega Mocks, okay, that means it is free, available on the BYJU'S exam prep app, and thousands of students are participating. You can also participate, especially mock tests are very important in the last time. Okay, so it is live till 2nd of February. Okay, around 3 more days are there for you. Okay, 3 to 4 days are there for you more. You can appear on any day and any time at per your convenience and see your performance within thousands of students. Get more. You can go to the app. okay, on the Google Play Store, okay, or there is a direct download link in the description of the video. If you're not able to find, go to the description of the video. There'll be a link to download the app. Okay, you can just download the app and appear in the free mock test. Okay, so whenever you free, whenever you find time, you can download and watch it. Next, let xz be the z transform of a discrete time signal minus 1 by 10 power n un. Okay, consider another signal yn and its z transform yz, which is given as yz is equal to x of z square. What is the value of yn at n equal to 3? What is the value of yn at the n equal to 3? What is the value of yn at the n equal to 3? Come on, let's do it quickly. Okay, देखो, there is another signal yz as x of z square. Did we see any property x of z square? Okay, x of z power n. X of z power n. कहीं पे भी ऐसा केस देखा था क्या? Again, you can scan, rewind the video and watch the entire property. There is no direct property for x of z square. Let's make it. Let's make it. Let's understand. I mean, not make the property. Let's understand the concept. Okay, so you are given by the basic z transform formula. इसको break करेंगे. Okay, good question it is. You are given yz is equal to x of z square. Yz is equal to x of z square. Now, what is the yz dtft formula for yn? Yz is a z transform for yn. Na? Okay, so that is summation of yn z power minus n. Okay, from n equal to minus infinity to the infinity. Okay, what is x of z square? Dear, we know what is x of z. Summation of xn z power minus n. That is the z transform for xn. Okay, that is xz. Summation of xn. Okay, z power minus n. I want x of z square. तो z की जगह कर दिया ना z square. Okay, summation minus infinity से infinity. ठीक है? Now, this is summation of yn z power minus n from n equal to minus infinity to the infinity, and this is summation n equal to minus infinity to the infinity x of n z की power minus 2n, and to make both of them similar, so that we can compare, what is that I am going to put on the right side, na? A substitution. Put that n is some variable k by 2. Okay, put n equal to k by 2 and then solve. If you put n equal to k by 2 and then you see, you have summation yn z की power minus n, okay, from n equal to minus infinity to the infinity will be summation of x of k by 2 z power minus 2n, and 2n will become k. Okay, limit of k minus infinity से infinity, but k is 2n ना, तो minus infinity into 2, infinity into 2, limits will be same. Now both the sides you have similar summation yn z power minus n. The name of the variable inside summation does not matter ना, like integration के अंदर भी name matter नहीं करता. So this is also equivalent to, we can also call it as finally summation x of n by 2 z power minus n. Okay, from n equal to minus infinity to infinity. अब तो clear हो गया? Summation yn z power minus n is equal to summation x n by 2 z power minus n. Both are equivalent expression. So this yn is corresponding to x of minus n. Okay, this yn is corresponding to x of minus n. Sorry, minus n को बोल दिया. Yn is corresponding to x of n by 2. Scaling basically. It is basically scaling. Yn is corresponding to x of minus n. x of minus n. ठीक है? x of n by 2 minus n, पता नहीं बार बार slip of tongue हो रहा है, x of n by 2. Okay. So if I apply this here and then let me talk about some more generalization. So yn is given by x of n by 2. I need the value of yn at n equal to 3. So what's going to be y3? That is going to be x of 3 by 2. अच्छा, question का यहीं खत्म हो गया. Question is finished. Dear, xn is a discrete time signal which is given to you. But it is a discrete time signal which is only defined for integral values of time. It is a discrete time signal defined only for integral values of time. Whenever you have a non-integral time, any discrete time signal will be 0 there. Mathematically, it's taken to be 0 there. The correct answer is option number A. Okay, if it was some non-integral point coming up, then xn ka value given hai. We can use that, but not required here. ठीक है, नॉट रिक्वायर्ड है. कोई और वैल्यू होता, से फॉर एग्जाम्पल, okay, if I ask you, suppose what is y4, then okay, it will be x of 2, x of n by 2, and what is the x2? That will be minus 1 by 10 की power 2. Unit step का value तो 1 होगा, because I have taken positive value of time. Okay, so then the answer is minus का square 1 upon 100. Then the answer will be 0.01. If they ask y4, okay, तो वो भी possibility है, ठीक है, वो भी possibility है. अच्छा, if it was, one quick recap, if it was z cube, the z की power minus 3n, and I can take k by 3, and I can take k by 3, limit minus infinity से infinity रहेगा, this becomes k by 3, z की power minus k. Okay, that means generalizing it, if I generalize and give the answer, okay, so I can say that if xn is having the z transform xz, let's frame these properties now. Okay, x of n by 2, okay, we'll have the z transform x of z square. Okay, x of n by 3, okay, we'll have the z transform x of z cube, and etc, etc, etc. Okay, there are time scaling property, but that is only with respect to expansion of the signal. N by 2, n by 3, mod a less than 1 represents expansion. Okay, there isn't any property which we write down for compression of the signal. Okay, why? Because whenever you compress a discrete time signal, there is loss of information. Fundamentals में आपने पढ़ा है. Okay, whenever you compress a discrete time signal, there is a loss of samples, loss of information. Whenever you expand, loss नहीं होता है, zero padding होता है. Whenever you expand discrete signal, there is zero padding. Okay. Okay, so we can only write down, if at all time scaling property, we can only write down with respect to expansion. That is what is mentioned here. That is what is mentioned here. Okay. Next, now there are some questions with respect to Z transform based on, you know, causality and stability of system. Okay, but उस पे जाने के पहले, since we are moving with the property and fundamental questions first, let me also introduce here the question for the DTFT also, because we have linked the DTFT and Z transform. इसके question भी करते हैं, then let's go to the system based question. Then let us go to the system based question. For the signal shown, it's a MSQ question again. Okay, for the signal shown, okay, which of the options are correct? 4 options here will teach you 4 different calculations. Which of the options are correct here? Okay, x of e power j0 is 6, minus infinity is infinity, modulus of x omega whole square d omega is 28, integral minus pi to pi x e power j omega d omega is 4. Okay, and then similarly last option. Okay, नहीं b and d तो same है, 28 या 28 pi में से आपको rectify करना है, तो it's 3 calculations basically. Dear, very quickly, what is the x0? चलो start करते हैं. Okay, option number A. What is x e power j0? Yeah, that is simply x0, and that is given by the formula, as I told you, summation of xn. Okay, summation of xn, summation of all values of xn. Okay, जितने भी n minus infinity से infinity हो, यहाँ पे जितनी भी value हो, summation of xn. Okay, so dear, -1, okay, then 0, लिखते जाना है केवल, -1, then 0, then 1, then again a 0, then again a 1. Yeah, no, 1. No, ये 0 नहीं है, this is 2, sorry. Okay, so let's make it as 2, then 1, then 1, then 1, then 0, 1, 2, 1, 1, 2, 1, 1, 2, 1, 0 and -1. Let us see what are the values. This -1, 1 cancelled, ये भी cancel किया, 2 plus 1, 2 plus 1, 6 and 7. It is not coming out to be 6. Is it coming out to be 6 or did I miss something? 1, 2, 1, 1, 2, 1, after that 0, after that 0, again 1, 2, 1. हाँ ठीक है, perfect. It's turning out to be 7, I think. Okay, check it out. It's turning out to be 7. 6 आ रहा है क्या? Cancel 1 minus. अच्छा, sorry, ये वाला तो cancel कर दिया था. हाँ, it is 6 only, dear. I'm sorry, it is 6. It is turning out to be 6. This was cancelled, basically, this was cancelled. हाँ, 6 it is. 6 it is. So A तो correct है. A तो correct है. Let's come to the C option. Simple वाला करते हैं first. What is the C option? Integral x omega d omega for one time period. Integral x omega d omega for one time period. This was given by 2 pi x0 as per the IDTFT formula. This was simply given by 2 pi x0. So 2 pi into value of the signal at origin. The value of the signal at origin is 2 units. So this answer is 4 pi. What is mentioned in option number C? 4 mentioned है तो ये हो गया wrong. ये था राइट, क्लियर। तो सी तो रॉन्ग हो गया। बी और डी, इंटीग्रल मॉड एक्स ओमेगा स्क्वायर डी ओमेगा बेस्ड ऑन पार्सेवल्स रिजल्ट। ओके, based on Parseval's result. So if I come to B, okay, or D, okay, integral mod of x omega whole square d omega, okay, that will be based on Parseval's theorem. Okay, so what is the energy of a signal in time domain? Basically summation of mod x n square, because what is given to you is the time domain signal. Summation minus infinity to infinity mod x n square, and as per Parseval's, it is given by 1 upon 2 pi integral over one time period minus pi to pi mod of x omega whole square d omega. Correct. So that means if I want the calculation, integral minus pi to pi modulus of x omega whole square d omega is 2 pi summation of the mod x n square. Okay, that will be equivalent to 2 pi. Now summation of mod x n square, okay, मॉडुलस स्क्वायर लगाओगे तो ऐसे ही पॉजिटिव हो जाएगा, तो इन सब का स्क्वायर करते जाना है। ओके, तो 101, लेट मी कीप राइटिंग 101, देन ओके 2 स्क्वायर 410, 410, देन 10 141 अगेन 141 0 and 1. Okay, so after all calculations, 6, 7, 6, 7, 7, 7, 14, 14 into 2 pi, 28 pi is the correct answer. 28 pi. That means out of B or D, D is the correct answer. Okay, so answer for this MSQ question is A and D. Check it out, guys. You should be getting A and D as the correct answer. Overall A and D. Yes, Ankit Kumar. Yes, Sri Shweta. A and D, very correct answer. Overall, the A and D is the very correct answer. Right. A Fourier transform pair is given to you. A Fourier transform pair is given to you. 2 by 3 power n u of n plus 3. 2 by 3 की power n u of n plus 3 as given to you as a e power minus j 6 pi f upon 1 minus 2 by 3 a e power minus j 2 pi f. Okay, where un is the unit step sequence. What is the value of a? Time shifting पे question है. Basic time shifting पे question है. So if I start, I will start with a power n un. I will start with a power n un. 2 by 3 power n un. 2 by 3 power n un. What should be the z transform? Okay, we know that it is 1 upon negative power में है, तो 1 upon 1 minus 2 by 3 e power minus j omega. Now let me do the time shifting, and as I told you, u of n plus 3 है, so I will not only do n plus 3 here, I will do everywhere on the function of n, left side में, तो n plus 3 2 by 3 पे भी आएगा, 2 by 3 power n plus 3 u of n plus 3, and time shifting corresponds to DTFT, time shifting corresponds to the exponential term, just like CTFT. Okay, phase term, exponential term with e power plus j 3 omega plus same sign के साथ upon 1 minus 2 by 3 e की power minus j omega. Okay, so we have 2 by 3 whole cube into 2 by 3 की power n u of n plus 3. Okay, having the given DTFT. Okay, options f के form में expression, तो put down omega equal to f and shift the 2 by 3 on the right side. So you will now be getting your final expression 2 by 3 power n u of n plus 3. 2 by 3 की power n u of n plus 3, and that is having the Fourier transform 3 by 2 power 3 reverse कर दिया, and then you have e power j. Okay, 3 omega will be 6 pi f upon 1 minus 2 by 3 e raised to the power minus j omega, omega again रख दिया 2 pi f. Okay, and if you compare with the given expression, okay, this is what is a. This is what is a. A is 1.5 या 3 by 2 के क्यूब से ही सॉल्व कर लेंगे इसको. That is 27 by 8, so that is 3.375. Check the calculation once. Okay, and ये definitely typo error है. This should be plus. Okay, this should be plus 27 by 8. So 3.375. Done it? Number 47. Next one, number 47 for you. The system whose input-output relation is given to you, okay, whether it is a FIR filter, high-pass filter, band-pass filter, low-pass filter, high-pass filter, okay, or causal system, whether it represents a causal system. So let us check all of them. It's a multiple select question again, MSQ question again, okay. So Yn is given to you, listen to me, okay. Y of n is x of n, ये भी एक important category है, minus 2xn minus 1, minus 2xn minus 1, okay, plus x of n minus 2, plus x of n minus 2, xn minus 2xn minus 1, plus x of n minus 2, ठीक है. Now, what is its Z transform? What is the Z transform? Convert both the sides into Z transform. Convert both the sides into Z transform, YZ, xn Z transform xz, minus 2 xz into Z inverse, plus x of z, z की power minus 2. Okay, now what is the transfer function for any system? For any system, transfer function we define as the ratio of output Z transform to the input Z transform, and that is equivalent to, okay, that is equivalent to, when you divide x on the left side, okay, you get 1 minus 2Z inverse, okay, plus Z की power minus 2. 1 minus 2Z inverse plus Z की power minus 2. Now, number one point is, what is the HN? ये तो हो गया HZ transfer function, okay. Now, what is the impulse response HN? Can we write directly? We know that it is a Z power minus a k pattern, and Z power minus k is the coefficient of xk. Okay, this should be x0. Z power 0 का case है, तो Hn should be 1. The next value is minus 2. The coefficient represents the signal value, na? And next value will be 1. Okay, and this is the origin. ये first value है 1 minus 2 1. Any doubt here? Please let me know. Okay, this is summation of the form xn Z power minus n. Okay. Now, what is the meaning of this FIR? Finite impulse response. Okay, what is the length of this? It has a finite length. It has a finite length, and that length here is 3, the number of non-zero samples. Number of samples between the first non-zero up to the last non-zero, including the endpoints. That is equal to 3. It is finite length. The impulse response contains finite number of samples. If the impulse response was suppose in the form of UN or something, okay, that will be infinite, but this is finite. This one is FIR. So, ये तो correct हो गया. Okay, whether it represents causal system? Yes, causal है, because it is starting from origin. There is nothing left to the origin. यहाँ से भी देख सकते हैं only negative power of Z, तो causal है. I told you this technique also. Only negative powers of Z coming up, so it is causal. Only negative power of Z coming up, so it is causal. ठीक है, तो ये भी causal है. Causal भी है, correct है. Okay, it is causal, it is FIR. High pass या band pass या low pass, कुछ भी हो सकता है. For that, what do we do? You can solve in the Z domain also, you can solve in the omega domain also. मैं आपको बताता हूँ यहाँ पे. What are you going to do here now? What are you going to do here? As I already explained you, what is the low frequency? The low frequency is omega equal to pi. Okay, the low frequency is omega equal to pi. Okay, omega equal to pi. Okay, now, and what is the high frequency? The high frequency is omega equal to pi. Low frequency is omega equal to 0. Low frequency, DC always, that is omega equal to 0. High frequency is omega equal to pi. Okay, we know that Z is equal to R e power j omega, but in the DTFT, in the frequency domain, we take R equal to 1. So Z is e power j omega, ये भी मुझे पता है. So what will be the Z? E power 0 will be 1. Okay, what will be Z here? E power j pi. E power j pi will be minus 1. So, you know, if you solve in omega domain, take 0 or pi. If you solve in the Z domain, take Z1 or minus 1. Low frequency Z1, high frequency Z minus 1. Okay, and then we also take some intermediate frequency. Omega equal to pi by 2. This is some intermediate. बीच की कोई frequency to confirm the results. Okay, so omega equal to pi by 2, so Z becomes e power j pi by 2, and you can put Z equal to j. Okay, these are the standard values that you should remember. Okay. Now, what is the HZ that we have derived? that we have derived. hz आया है 1 minus 2z inverse plus z की power minus 2, isn't it? Yeah, perfect. Okay, or I can write it as 1 minus 2 by z inverse को denominator में लिख देते हैं plus 1 by z square. This is what I have. ठीक है. Finite length, total number of samples, saint, total number of samples, finite in length. Okay. Starting from the first non-zero up to the last non-zero. कितने number of samples है, saint. Okay. Now, if I start with LF, okay, LF means Z equal to 1. What is the value of H1? And that is 1 minus 2 plus 1, and that becomes 0. So definitely it cannot be a low pass filter. It cannot be a low pass filter, isn't it? Na? Because if it was low pass filter, it should pass low frequencies. But the gain at low frequency is exactly 0. So it is not at all passing the low frequency. It cannot be low pass filter. It cannot be the low pass filter. Let me try with high pass now, high frequency now. Z equal to minus 1 rakha. So what is H of minus 1? Okay, so H of minus 1, 1 minus 2 minus 1 aega, and plus 1 upon 1. Minus 1 ka square will be 1. So this is eventually 1, and then plus 2 plus 1. This is 4. If I am correct with the calculation, Z ka value minus 1 rakha. So 1 plus 2 and then plus 1. This is 4. Definitely it is passing the high frequency, high pass filter hai. ठीक है. Even some of the case, what can happen? Some of the case low frequency and high frequency gain दोनों ही 0 आएगा. In some of the cases, you will get low and high frequency gain, both of them equal to 0. That is why we define the intermediate frequency. Low be 0, high be 0. Intermediate where you will get some gain. That means there is some such graph will be there. Some intermediate frequency where the gain is high, at the boundary it is 0. That is band pass actually. That will be band pass. ये तो high pass होगा. चलो here अगर if you want to calculate IF, that you have to put Z equal to J, and then H of J, okay, will be 1 minus 2 by J plus 1 by J square, and that is 1 plus 2J, because 1 upon J itself is minus J, and this is negative 1, this is 2J. Calculate only the magnitude part. Modulus of it will be 2. Magnitude part will be 2. The amplitude response is important for the filter discussions, as we have already known. So, if I sketch up this one, high pass होगा, ये clear हो गया guys. In exam you should only comment high pass and go forward. Okay, but let me draw it out here. And I want to draw the modulus of H omega. Okay, and that is turning out to be how much? That is turning out to be how much? Okay, it starts with 0 and till high frequency it has the gain 4. This is the 0, this is the high frequency, and this is my intermediate. Intermediate you can pick any. I have exactly chosen to be midpoint. You can choose any of them. And let's say approximately it is of this kind, where this gain is equal to 4. At pi by 2 I found the gain, which is equal to 2. Okay, because the given signal is real, signal means impulse response here, it is real, and for real signal we know magnitude spectrum is even symmetric. Magnitude spectrum even symmetric है. वैसे इतना sketch कर लिया sufficient है, but I can sketch on the other side also. It's going to be something of this kind. Okay. And for any DTFT, only one time period information is sufficient. This is just an approximate curve. Okay, clearly suggesting you that this is a high pass filter, because as you go, not an ideal high pass filter, definitely not ideal. Okay, because gain is not constant throughout, but as you move towards the high frequency, the gain of the system is more. That means the high frequencies are being passed with a considerable gain, and the low frequencies, they are also passed. Okay, but with a very small gain. You know, we have the concept of 3 dB bandwidth. When we don't have ideal filter, we define the 3 dB bandwidth as well. That frequency such that the gain, okay, the output power is at least greater than 50% of the input power. Okay, is at least greater than the 50% of the input power. Okay? That is what is the story here. It's a high pass filter. So coming back to this MSQ question, dear. Coming back to the MSQ question, understood a lot of things here. It is not band pass, it is high pass. So correct answer is A, B, and D for the MSQ question. A, B, D. Okay. If you by chance, okay, if you by chance, ठीक है, कोई भी check कर सकते हो, you know, any of the frequency आप with, okay, an intermediate. अच्छा, if you by chance had, say for example, impulse response may be of the format half power n un for a system that will be, now how many samples will it have? Un we know goes from 0 to infinity. Okay, 0 to infinity, and that will contain infinite number of samples. This will be IIR. This will be infinite impulse response. This will be infinite impulse response. That can be example of IIR. Okay, that is IIR. Acha, specifically telling you, now from the gate syllabus, okay, the digital filter design has been removed. Since 2021, IIT Bombay modified the syllabus. Digital filter design has been removed. Okay, but some basic questions about filter, ye zarur aata hai aur aata bhi hai. Even in the last 3 years, you can check. The digital filter design part has been gone. By identifying the very fundamental, whether it is a high pass filter, low pass filter, that is expected. Very electronics, electrical ko to pata hi hona chahiye na what is high pass, low pass filter. That fundamentals can be expected. Only digital filter design has been removed. Okay, so don't discard this topic. Okay, clear everybody? Clear everybody? Okay, चलो अब कुछ system based question भी करते हैं. A quick revision of some system properties, and then let me take a question here. Okay, so say for example, let me pick up another MSQ question here. Okay, so there is a DT-LTI system. Okay, input Xn, I feed to the system having the impulse response Hn. This is the system having the impulse response Hn. This is my input, this is my output. Okay, and Hn having the Z transform Hz. So if Hn is the impulse response, we know that the Z transform is the transfer function. Okay, so the transfer function of a system is given to you. 6 into 5z minus 2 upon 6z square minus 5z plus 2. Okay, the system is stable and causal, or causal for what conditions? For what conditions? Let me write down the poles of the system first of all. Let me write down the poles of the system. What it is? 6 into 5z minus 2 is divided by 6z square minus of 5z plus 1. 6z square minus of 5z plus 1. Okay, 6z square minus of 5z plus 1. Okay, 6z square minus of 5z plus 1. Okay, so chalo, let's do it. Now, first of all, what is important is the pole calculation here. Okay, is the pole calculation here. Okay, 6z square minus of 5z plus 1. ये तो factorize हो जाएगा, I think. Yeah, it can be broken directly as 6z square minus 6z plus z plus 1. Or you can apply the quadratic formula also. Okay, so that is 6z common liya minus 6z common liya. So you have z minus 1. And this was minus 6z plus z. So यहाँ पे आएगा z plus 1. 6z square minus 5z plus 1. Minus 5z to minus 6z plus z नहीं. Am I doing any error here? Minus 6 plus 1 सही तो लिखा है. And then I don't get the common factor. चलो ठीक है. Maybe some irrational roots coming up. If I take z, 5 plus minus under root 25. नहीं यार, irrational भी नहीं आ रहा है. Maybe I was doing some fundamental mistake there. Forget. चलो आगे बढ़ते हैं. Okay, 5. Okay, plus minus under root of b square minus 4ac. Okay, divide by 2a. So it is 5 plus minus under root of 1, that is 1 by 12. Okay, so z is equal to 5 plus 1, that is 6 by 12, 1 by 2, 5 minus 1, 4 by 12, 1 by 3. ठीक है. अच्छा, that gives me an idea कि इसको भी break करना चाहिए था. That is okay, fine. ठीक है, हाँ, that is okay. 3-2 में break होगा. ठीक है, fine, that's okay, whatever. So we have got it as 1 by 2, 1 by 3. कहीं से भी poles आ गए ना, वो important है. Poles आ गए, वो important है. So that is 1 by 2 and 1 by 3. Okay. Now with respect to these poles, what is the condition? With respect to these poles, the condition are, with respect to any two poles, how many types of ROC can be seen? How many types of ROC can be seen? There are two poles here. Okay. There are two poles here. One by 2 and 1 by 3. Okay, the possible ROCs, let me draw for you. ठीक है, चलो एक क्विक स्केच लेते हैं, ज़्यादा नीट एंड क्लीन पे नहीं जाएंगे. ओके ओके, आई विल एक्सप्लेन यू द, आई एम नॉट रीडिंग द ऑप्शंस राइट नाउ. मैं आपको सब कुछ सारी स्टोरी बता दूंगा यहाँ पे. ओके, So I have the two poles, that is 1 by 2 and 1 by 3. Now listen to me. What are the possible ROCs? Okay, what are the possible ROCs? Don't worry, they know that there is no scientific Casio calculator now, so they will give the question accordingly. Either it will be factorizable. Okay, without factorizable, wala third order polynomial nahi hoga Satvik. Don't worry. Okay. What can be the possible ROC? See, there are definitely poles. The ROC cannot be entire Z plane. So ROC may be right-sided, maybe left-sided, or maybe a ring between two poles. So what is the first possibility, dear? Let's take right-sided. And right-sided is exterior ROC, exterior circle, but exterior of what? Exterior of the largest pole, outermost pole. Because ROC cannot contain any other pole. So I will take a circle passing through the outermost pole, and this is what is going to represent your ROC. Right-sided signal. Okay. The first possible ROC, mod Z greater than 1 by 3. With respect to two poles, always these three ROC will be there. Next is what? Interior le lete. Interior lies where? Interior will always lie to the inside of the innermost pole. Interior will be always inside of the innermost pole, जो smallest pole है, इसके अंदर लेना पड़ेगा. So that is the next possible ROC. That is the next possible ROC, and this ROC mod Z less than 1 by 2. And third possibility is, okay, between both the poles, that creates a finite ring. Between both the poles, and that creates finite ring. Okay, two-sided signal. Two-sided signal. Two-sided signal. Okay, two-sided signal. अच्छा ये हाँ मैंने reverse लिख दिया. Call it as typo error, and mod Z greater than half, of course. Okay. ये मैंने उल्टा क्यों लिख दिया? What is the logic behind that? Am I so hungry now? ठीक है, चलो anyways, now come here. अब देखो यहाँ पे now this is what is the condition on ROC, and a lot of time we are discussing ROC. This definitely corresponds to right-sided, this corresponds to left-sided, this corresponds to two-sided. Now what is the condition for the system to be causal? यहाँ पे causal anti-causal stability की बात हो रही है. Okay, causal anti-causal stability की बात हो रही है. What is the condition for the system to be causal? Again, not deriving, quickly revise करेंगे इसको. Okay, a system is causal. We know that Hn equal to 0 for n less than 0. अगर time domain पे चले जाए. Okay, so Hn only exists for n greater than 0, right side. And for a right-sided signal, what is the ROC? For a right-sided signal, ROC is the exterior of a circle outside the outermost pole. So whenever you have an exterior ROC, that corresponds to causality. One more thing for causality, the order of numerator cannot be greater than that of the order of denominator. If expression wise given, here only ROC is given. The expression bhi hai yahan pe, ROC of numerator should not be greater than that of denominator. What is the order of numerator? Z. It's only Z power 1. Okay, first order, denominator is second order. Numerator order less than denominator. Equal to bhi chalega. Order of numerator should not be greater than order of denominator. Okay, and for the case number 1, dear, where you have a right-sided ROC, okay, exterior ROC, that corresponds to causality. That corresponds to causality. Okay, and if you have exactly opposite to it, exactly opposite of causality will be anti-causal. This is neither right nor left. This is in general. इसका ROC भी लिख देते हैं पहले. This is a finite strip ROC. 1 by 3 less than the mod Z less than 1 by 2. And this will be in general non-causal. Okay. ये तो हो गया causality. ये तो हो गया about causality. Okay, so it is causal, anti-causal and non-causal for 3 conditions. Now, what is the condition for the system to be stable? Okay, if and only if ROC includes the unit circle. Because stability की condition भी क्या होती है? Okay, in the time domain you study that the impulse response is absolutely summable. The impulse response is absolutely summable. If the impulse response of a system is absolutely summable, then the system is stable. And then we know if the impulse response is absolutely summable, DTFT will exist. For DTFT to exist, ROC should include the unit circle. सब कुछ mix कर दिया. So final condition for stability is, okay, the ROC should include the unit circle. The ROC should include the unit circle. Okay, तो कहाँ पे unit circle आया? In the first case, definitely unit circle will come. Okay, so this is stable also. No need to draw the unit. चलो इस case में draw कर देते हैं. Only in this case number 1 unit circle is coming. Okay, but in the next case, unit circle cannot come. In the last case also, we stop at 1/2. Unit circle cannot come. So case number 2 and 3 corresponding to unstable system. ठीक है. Okay. Okay, तो HN is stable and causal for first case. Correct answer, very correct. First case में stable causal दोनों था. For ring case में it is causal, no. Okay, for mod Z less than 1/3 interior anti-causal, perfect. Mod Z greater than half it is causal. ये तो repetition ही हो गया ना. A और D are just subparts. But A में stable plus causal बोला है, D में causal बोला है. तो D is also a subset of A. We will mark D also as correct. Causal तो है but causal and stable है. अच्छा, for a system, for a causal system to be stable, for a overall नहीं, overall तीनों ROC हो सकता है. That has to be specified. If it is not specified, we are considering all ROC. Overall कुछ नहीं होगा. Any one of the ROC can only exist, Ankit. There cannot be more than one ROC ना. Either this or this or this. इनको combine नहीं कर सकते. They are all different cases. Okay. Now ये देखो. Case number A is causal. Case number 1 is causal. And both the poles are inside the unit circle. It is stable also. For a causal system to be stable, if all poles are inside unit circle, then the system is stable also. That means what is the combined condition for causality and stability? What is the combined condition for causality and stability? Causal and stable LTI system. Okay, for a causal system to be stable, okay, matlab it should satisfy both if and only if all the poles lie inside unit circle. If all the poles lie inside unit circle. Like Laplace mein what you study? All the poles on the left half plane. Here all the poles inside unit circle. In Laplace, whatever we study with respect to imaginary axis, here it is converted to unit circle in the discrete domain. Here it is converted with respect to unit circle in the discrete domain. Clear? Finite length bounded system, Ankit. Maybe one of the values unbounded. Finite length bounded system is always stable. ठीक है? वो अलग condition हो गया. ठीक है? So for the system to be both stable and causal, all poles should lie inside the unit circle. All the poles should lie inside the unit circle. देखो, कई बार स्टूडेंट्स गलती कहां करते हैं? You know, there is a place where you commit mistakes, and for that, let me go to one of the question. इस पे आ जाएंगे. Okay, suppose such a ROC is given to you in the question. Suppose such a ROC is given to you in the question, and they ask you whether the system is stable. Listen to my question very carefully. Okay, they ask you whether the system is stable. Many students say no. Many students say no because the poles are not inside unit circle. The poles are not inside unit circle. You say not stable, but this is stable. Difference क्या है दोनों concept में? I ask you only stability. I ask you only stability, and only stability unit circle should come between the ROC. ROC should contain the unit circle. It is containing, it is stable. Problem is it is non-causal. Problem that it is non-causal. Okay. So all poles inside unit circle, students remember it as the condition of stability. No, it is the condition of stability of a causal system. For a system to be both stable and causal, ROC includes the unit circle. Oh, sorry. All the poles inside unit circle. I repeat, all the poles inside unit circle. If only stability is to be checked, ROC includes the unit circle. इसलिए मैंने सबको अलग अलग लिखा था. यहाँ पे आप देखेंगे Okay, the conditions, if you see, for causal we need an exterior type ROC. For stability, if only stability required, ROC should include the unit circle. And for a system to be stable and causal combined, then that pole conditions come, all poles inside the unit circle. Then that pole condition come, all poles inside the unit circle. ठीक है जी, डन है. ओके, ये तो हो चुका था. चलो. So guys, can I give you this as homework? Simple one. Okay, find the values of K for the system to be stable and causal. Stable and causal combined. That means you can try the pole method. If they only say stable, ROC includes unit circle. Stable plus causal simple हो जाएगा, poles पे आ जाएगा. All poles of the system should be inside unit circle. But what are the poles? For poles, you need the transfer function. What is the transfer function that you have to get from this block diagram? You can get it easy. You can get it easy. Just go with the flow of variables, get the relation. Okay, first, the transfer function. That is the ratio of output Z to output Z transform to the input Z transform. YZ upon XZ. पहले तो ये पता कर लीजिए. What is the YZ upon XZ? Clear? Go for this. Okay, go for it. Okay, everybody, let's go for this. So you can complete this as homework. Okay. Any confusion? Bata dijiye, but I hope you can do it out. Let's move to the next chapters also. Almost all the questions of Z transform done. Just one more formula that needs to be revised from Z transform. That is the initial and final value theorem. Okay. Initial and final value theorem. If xn having the Z transform xz, x0, that is the initial value of the signal, is given by limit z tending to infinity xz. Limit z tending to infinity xz. Okay, limit z tending to infinity xz. Okay, provided xz must be causal. Okay, xz must be causal. Okay, that means degree of numerator, as I just mentioned, should be less than or equal to degree of denominator. उससे बड़ा नहीं होना चाहिए. Degree of numerator less than equal to degree of denominator. Okay, that means xz, in this case it is also said to be a proper function. What is a proper function? Whenever the degree of numerator less than equal to degree of denominator, it is proper. Whenever degree of numerator more, that is an improper function. If degree of numerator strictly less than degree of denominator, that is strictly proper. Okay, so initial value theorem. Okay, limit z tending to infinity xz, slightly different from Laplace, है ना? Laplace जैसा नहीं है ये. Then final value theorem. Final value of the signal, limit n tending to infinity xn. Limit n tending to infinity xn. The final value of the signal is given by limit z tending to 1 minus z inverse xz. यहाँ पहले ही बता देता हूँ, in some of the books you might be looking at something like this. In some of the books it is written like this. Limit z tending to 1 z minus 1 xz. Baba equivalent है. Okay. Okay. 1 minus 1 by z is z minus 1 by z. Na? Okay, this can create a 0, but denominator z is strictly 1. So z को 1 रख दोगे तो ये हट जाएगा. These are equivalent. Okay, it's just representation. So limit z tending to 1 minus z inverse xz, or limit z tending to 1 z minus 1 xz. Okay, z minus 1 xz. ठीक है. Again, this is applicable if and only if all poles of xz lie inside unit circle. Okay, with all poles inside unit circle, with at most maximum one pole allowed on unit circle. With at most one pole allowed on unit circle. ठीक है, मैं कुछ conclusions भी दे देता हूं आपको dear. I will give you some conclusions also. Rather than solving a question, you can solve the question. अरे ये MSQ नहीं है, forget. This is a NAT question only. ये MSQ नहीं है, typo error है. Okay, rather than solving a question, I will give you straightforward. Okay. आप अभी solve कर लेना. Let me know if you have any confusion. But what is more important is, okay, some straightforward conclusions. आपके सारे question खत्म हो जाएंगे with respect to final value. With respect to final value. Look into the relation of poles and final value. देखना यहाँ पे. I will tell you more important rather than solving that question. Okay, poles. Number one, suppose all inside unit circle. Suppose all the poles inside unit circle. Okay, next condition I will take. Okay, just one pole. Okay, on the unit circle. Next condition I will take. Next condition ले लेंगे. Repeated poles on unit circle. One pole on unit circle and that one pole is z equal to 1. Okay, repeated pole. Okay, at z equal to 1. Z equal to 1 पे multiple poles आ जाए. Okay, then next. Complex conjugate pair of poles on unit circle. On unit circle. Fifth, इसी का repetition. Repeated complex conjugate poles. Repeated complex conjugate pair of poles on unit circle. Last but not the least, even a single RHP pole सब कुछ खत्म कर देगा. Even if there is a single RHP poles. Okay. All poles inside unit circle, final value always 0. Okay. One pole on the unit circle, then the final value will be finite. Repeated pole at z equal to 1, final value in unbounded, infinity आएगा. Complex conjugate pair on unit circle, final value indeterminate, oscillatory basically. Indeterminate से मेरा मतलब है oscillatory, sinusoidal terms आते हैं. Because of sinusoidal term when you take the inverse Z transform. Repeated complex conjugate pair on unit circle, again infinity. Even if a single RHP pole, infinity. Infinity यहाँ भी लिख देता हूँ. ठीक है? Okay, what is this finite value? So देखो सारे conclusion है. Only one case it is finite. In only one case it is finite. Okay, whenever you have a single pole at Z equal to 1. What is that finite value? You have to calculate that x infinity is given by the formula limit of z tending to 1 z minus 1 xz. Okay, z minus 1 xz. Xz, देखो, it can be any example. Suppose what I am telling, one pole on z equal to 1. Suppose you are given the xz, that is 2z upon z minus 1. तो यहाँ पे value रख देंगे ना. Limit z tending to 1 z minus 1. Okay, 2z upon z minus 1. So there is a single pole at z equal to 1. So z minus 1 cancel होगा ना. Then only finite will come. And the answer will be 2z. Z का value 1 रखा. Answer is 2. Then the answer is 2. Only one case it is finite. Rest is results. Rest is results. So if you remember this condition, similar, okay, will be for Laplace also. Similar will be Laplace. Only thing is wherever I have written unit circle, it will be replaced by imaginary axis. Okay. Wherever I have written unit circle, that will be replaced by imaginary axis. Okay. Okay, guys. So it's almost 4.5 hours of session. Okay, it's almost 4.5 hours of session. Okay, so yeah, definitely you can, Ankit. Very, very related with the stability criteria, absolute stability criteria. So let's take a break. I think it's going to take some more time. 4.5 hours continuously done today. 11 to 3.5, 3:30. Okay, so let's go for a break right now. Okay, you will take this question as homework क्योंकि सारी conditions मैंने आपको बता दी हैं. सारी conditions मैंने बता दी हैं. There is one pole on the unit circle coming up. Easily you can go up. Okay, but I'll not prefer a long break here. Okay, let's go for a lunch break now. I thought कि one stop में complete करेंगे, but it'll become evening. Okay, it'll become evening. Okay, so lunch break. Okay, resume करते हैं. Okay, at 3:45. Okay, 3:45. Okay, just approx 20 minutes, a little less than 20 minutes. Okay, let's resume at 3:45. जल्दी से चलेंगे, जल्दी करके आएंगे, because evening I have another class. Okay, so I need to, Laplace transform and DFT. ये दो चीजें करनी है. Laplace and DFT करना है अभी. Okay, at least in the transforms I told you, all transforms I will cover. Okay, so and evening I have another class also. So Okay, bye bye. See you. Yes, guys, ready once again? Okay, let's continue if you're all ready after the lunch. Okay. Yes, ready. Cool. Let me see what is the attendance after the lunch. How many of you are still motivated after the lunch? So let me look into the DFT related with the DTFT and then let's go to the Laplace. उसके बाद हम Laplace कर लेंगे. With the DFT, discrete time Fourier series also I will explain you there itself. Ready. Chalo. So I'm also ready. Let's get moving ahead. Okay. The DFT. Discrete Fourier transform. How it is different from the DTFT? DTFT is the Fourier transform, basic Fourier transform of a discrete time signal. Already we have defined the Fourier transform of a discrete time signal. Why another Fourier transform? So if I go back and jump again to the DTFT. अगर वापस DTFT की तरफ चले जाएं, so what is the DTFT, dear? X of omega is given by summation minus infinity to infinity xn e power minus j omega n. Okay, where omega, okay, of course it is periodic, okay, and omega is a continuous parameter. This frequency, we are talking about the Fourier transform of discrete signal, okay, but the frequency representation of it is continuous in nature. Omega is continuous in nature. That means this x omega is a continuous function. Okay, the signal is discrete, but the Fourier transform is a continuous function. This Fourier transform is a continuous function of frequency. It is a continuous function of frequency. To discretize it, we define the concept of discrete frequency. Okay, we first of all define the concept of discrete frequency. And before I define the concept of discrete frequency, let me now consider a signal which is finite in length. Because, say for example, any computations you are ultimately going to handle through digital computers. Okay, for small values often you can calculate manually. But suppose if I give you signals having large length, so ultimately those computations have to be fed to digital computers for the quick calculations. Okay, and that is why we have quick algorithms also. What is the quickest way to calculate DFT? Is the FFT, fast Fourier transform. Now GATE has removed the FFT from syllabus, but yeah, we know that FFT is a tool to calculate the fast Fourier, to calculate DFT quickly and efficiently. Okay, that is what FFT is. Okay, so ultimately we'll be moving towards the digital computation. We'll be moving towards the digital computation of this. Okay, and for digital computation, of course, we need a signal which is finite in length, because if any signal has infinite samples, we cannot store infinite samples within a machine. We cannot store infinite samples within a machine. Okay. We cannot store infinite sample within a machine. Okay, so first of all, now we will be taking xn, okay, which will be finite in length. Which will be finite in length. Okay, which will be finite in length. Which will be basically finite in length. Okay, so xn, okay, will be existing only between the length, that is, suppose 0 less than equal to n less than equal to n minus 1, and suppose that finite length I take n 0 to n minus 1. Okay, the total length will be n. Okay, it will exist only between them, and definitely outside this interval, xn will be equal to 0. Okay, here it can take any value. Okay, here it can take any value. Okay, so that is what is a finite length signal. Okay, and if I have a finite length signal, okay, now I define the concept of discrete frequency. इस concept से समझोगे तो it will be easy to remember the DFT formula. it will be easy to remember the DFT formula. Okay, so then I go with the concept of discrete frequency. As I'm telling you, omega is a continuous function of frequency, and I discretize it. I define a discrete frequency, and to discretize it, we also know that any Fourier transform is a periodic function, and the spread of the frequency is over 2 pi. I mean, for any calculation that we were looking at also previously, we need only one period information of the Fourier transform, and one period is over 2 pi interval. Okay, so the total spread of the frequency is 2 pi, of course, which is continuous. Of course, which is continuous. I divide that total frequency range by the number of samples in the signal. Okay, and then I take a parameter k, 2 pi by n into k. 2 pi by n into k. Okay, this is what is a discrete frequency. Now see, okay, this is equivalent to what? If I take k equal to 0, okay, k can be 0, 1, any frequency up to n minus 1. So we take the number of frequency equal to the length of the signal basically. And if I take k equal to 0, I get 0 frequency. If I take k equal to 1, I get the 2 pi by n. If I take k equal to 2, I get the next frequency 4 pi by n, and etc, etc, etc. So now not all frequencies will be considered, only some discrete frequency considered, and they are 0, 2 pi by n, 2 pi by 4 pi by n, etc. Okay, only a specific set of frequency. How many frequencies? Total n frequencies equal to the length of the signal. Okay, we now discretize the frequency axis such that the frequency now can take only n possible values given by respectively 0, 2 pi by n, 4 pi by n, etc, 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 etc. Such a Fourier transform in which the frequency will also be discrete, okay, will be the DFT. So if I again take the DTFT, and give you the final formula, it's easy to remember this way, okay? If I give you the final formula, okay, it is summation xn e power minus j omega, and this is the DTFT. This is the DTFT. Okay, now put down omega as omega k. So now let's call the function of discrete frequency x of omega k. Okay, that is equal to summation. Now in the DTFT, in general, the limit n is minus infinity to infinity, but now as I told you, signal can only exist between 0 to n minus 1. Outside that it is 0. I am considering a finite length signal. So n is also equal to 0 to n minus 1, x of n e raised to the power minus j omega k n. Okay, acha, what is omega k? As I explained you, 2 pi by n into k. Okay, 2 pi or n constant, n is the length of the signal. So omega k depends on the value of k. Okay, x depends on omega k depends on k. So that is basically a function of k. Let us say x depends on k, and that x as a function of k. Final formula, summation n equal to 0 to n minus 1, x of n e raised to the power minus j, put down the value of omega k, e power minus j 2 pi by n into kn, and that is what you must have seen as the DFT formula. That is what you must have visualized as the DFT formula. Okay, summation xn e power minus j 2 pi by n into k, and that is what is the basic DFT formula. Okay, that is what is here in front of you. Okay, xk, summation 0 to n minus 1 xn. Okay, e power minus j 2 pi by n into kn is the DFT formula, and then IDFT formula also respectively written. दोनों को ही highlight कर देते हैं. IDFT formula respectively, xn is 1 upon n summation xk e power plus j 2 pi by n into kn for n equal to 0 to n minus 1. These are the Fourier transform and I for inverse Fourier transform formula. Okay, considering a discrete frequency range. Okay, the same thing is written which I have mentioned all these points. We call such the DFT as n-point DFT because the DFT will contain total n points. DFT is a function of k coming from the concept of discrete frequency, and how many possible values of k? 0 to n minus 1. Okay, so that particular Fourier transform is going to contain, okay, the analysis for k n different values of frequency, and it is a n-point DFT. Okay, it is known as a n-point DFT. Clear? It is known as a n-point DFT. Okay, ji. Okay, so I hope the basic formulation, how it is coming up is easy. Sometimes it is also expressed in the form of twiddle factor. We know that this is the constant term coming up every time. Rest n and k are variable. Okay, n is the time, k is the discrete frequency parameter. But e power minus j 2 pi by n is a constant, and we call it as, hey, yaar, who's this? Okay. We call it as the twiddle factor e power minus j 2 pi by n, and that is also equivalent to, when you go and evaluate, it will also represent nth roots of unity. Okay, that will be representing the nth root of unity, and in that nth root of unity format, xk is given by summation 0 se n minus 1 xn w power kn. Summation 0 se n minus 1 xn w raised to the power kn. Okay, in terms of twiddle factor, or otherwise you remember the basic formula, that is also okay. Okay, say for example, especially the twiddle factor for n equal to 4 will be very important. Many questions are based on 4 point also for exam. In exam, that will be e power minus j 2 pi by n, or e power minus j 2 pi by 4 ho gaya. That is e power minus j pi by 2. And what is e power minus j pi by 2? That will become minus j cos pi by 2 minus j sin pi by 2. Okay, so the value of W4 is equal to minus j. Okay, similarly you can calculate W8 or others as well. Okay, so in terms of twiddle factor, these are the formulas. Okay, these are the formulas in terms of twiddle factor. Okay, sometimes they are written in the form of matrices as well. Sometimes they are also written in the form of matrices as well. Okay, like DTFT, DFT, and similarly IDFT, both of them will be periodic with the period fixed, that is equivalent to n. And that is why we always consider the result for one period, 0 to n minus 1. Whatever results we write is within the range 0 to n minus 1. Okay, property ke jaane ke pehle, okay, before I go to the property, let me take up the property and then let's mix up some concepts. Okay, let's mix up some concepts. Sometimes ये जो matrix का structure भी आप देखते हो ना. Okay, suppose you take n equal to 4. Okay, so then the DFT representation becomes summation n equal to 0 to 3, 0 to n minus 1, xn W4 raised to the power kn, where W4 का value as we just now calculated is given by minus j raised to the power kn. Minus j raised to the power kn. Okay, so dear, okay, this will be applicable. Okay, n equal to 4 hai, to k also 0 to 3, 0 to n minus 1. If I combine all the results in a matrix, let's say I have a vector containing all the DFT values x0, x1, x2, x3, this will be equivalent to x0, x1, x2, x3. Okay, when you start with k equal to 0, anything power 0, 1, you only get summation xn. Okay, summation xn. So here you will get x0, x1, summation of xn. So here we have only 1, 1, 1, 1 as the coefficient. 1 into x0, 1 into x1, 1 into x2, 1 into x3. अगर k का value 1 लोगे ना, अगर k का value 1 लोगे, so you will get summation xn minus j power n. Minus j की powers multiply होंगे, but minus j power 0 will be 1. Then you will have minus j power 1. Then minus j का square minus 1. And देखो, minus j का square जहाँ पे भी आएगा, that is ultimately j square but minus 1. Minus j cube, that is minus of j cube. Okay, but j cube itself is minus j, so that will be plus j. Okay, तो यहाँ पे आ जाएगा plus j. Okay, next when you solve, you will get 1 minus 1, 1 minus 1. Okay, why alternate plus minus aa raha hai? I'll take up that point also. Okay, and eventually, okay, the last row, fourth row will be conjugate of second. 1 and then plus j, and minus 1 and minus j. Conjugate kiska loge? Complex number ka. For real number, the conjugate is as it is. Okay, 1 remains 1, minus j becomes plus j, minus 1 is 1, j becomes minus j. Okay, so what you can also do is, maybe you can only remember one row. Okay, why only one row? Chalo, let me explain how to remember this one quickly. Because if you talk about direct calculation, dear, with respect to exam point of view, if you talk about the direct result, if you talk about the direct question based on the formula, okay, up to 4 points will be important. Otherwise, most of the questions are based on properties. They are more important. Property based यहाँ पे कई question बनते हैं, वो भी हम देखेंगे यहाँ पे. We can also write down this DFT xk as some matrix W, okay, multiplied by xn. Okay, let W be this matrix. Okay, let W be this matrix, or any particular name you can give to this particular matrix. Okay. Similarly, and then if you want to derive xn, that will be nothing but W inverse of this. Okay, W inverse of 1 upon n के साथ, ठीक है? W inverse for this. ठीक है, now let's go to the, we will explain, we'll learn this calculations more with the questions. Okay, now properties. Some of the properties are very similar. If two signals are added, DFTs are added, nothing new. Okay, so let's go forward. Okay, now time shift. Properties again similar. See, if there is a time shift, there will be an exponential term in the phase domain. Remember the DFT, देखो DTFT में क्या होता था? अगर आप DTFT के एंगल से याद रखोगे ना, सब कुछ इजी होगा. xn having the Fourier transform x omega. Okay, so x of n minus n naught should have got Fourier transform. Time shifting corresponds to a exponential phase term. Okay, e पावर माइनस जे ओमेगा एन नॉट, यही आना चाहिए. अब यहां पे आपको केवल क्या करना है, ओके, इफ यू रिमेंबर दिस प्रॉपर्टी, रिप्लेस ओमेगा बाय ओमेगा के नाउ एंड दैट विल बी 2 पाई बाय एन इंटू के. वो देख लीजिए. सो दिस इज द प्रॉपर्टी, e पावर माइनस जे 2 पाई बाय एन इंटू के, ओके, इंटू एन नॉट. इजंट इट सेम? So nothing new for you. That is why if you relate the DTFT and DFT, things will be simple. Okay, so xk e power minus j 2 pi by n into k n naught. But what is this x of n minus n naught mod n? What is x of n minus n naught mod n? This is known as circular shift. Okay, so before I explain you any other property, just one example I will take. Let me explain you circular shift and circular folding. Let me explain it to you for once and all, because you know it is going to be used in the question also. प्रॉपर्टी के पहले ही लिख देते हैं. ओके, लेट मी गिव यू अ सिग्नल हियर. ओके, suppose this is a signal given to you, 8-point signal. Okay, 8-point signal. Okay, 8-point signal. Okay, dear, what is x of n minus 2 mod 8? When it is 8-point, I will write mod 8, and whenever mod 8 is written, it means circular shifting. What is circular shifting? Okay, as I told you, all the results are considered only in the window 0 to n minus 1. अब आप ये सोचो, आपको right shift करना है ना, n minus 2, basically you know right shift. Okay, now you right shift. Okay, so these two samples will go here. These two samples will go here. But I want to write down the signal only from 0 to n minus 1. उसके बाहर जाना नहीं. You have a small window here, 0 to n minus 1, like 0 to 7. If you talk about the value of n, this is 0, 1, etc., up to 7. All your results should be between 0 to 7. Okay. Now, dear, because of periodicity, I told you DFT and IDFTs are both periodic. So, because of the periodicity, same structure would have been repeated here also, would have been repeated there also. So, अगर इसके पहले जाके झाके, so -5 and -4 and 5 will be here also, considering repetition. So now when you are shifting, what will happen? -4 and 5 will come here. Na? If you are shifting twice, so these two samples will come and then 2, 1, etc. shift hoga, isn't it? So better, let us not think what is before or what is after. Now let me make it simple. आपको क्या करना है? You just have to remember one logic, whether you are solving circular folding, circular shifting, circular convolution भी आएगा यहाँ पे. Just remember one logic. Everything should be 0 to n minus 1. Okay, so let me try shifting now. Okay, let me try shifting now. Okay, but I don't have space to shift it here. If you don't have space, then shift the samples to the first. That is why we call it as circular folding. Why -4 and 5 will come here, I explained you. Okay, but now remember it by the logic of circular folding. Okay, what it is like, you are shifting right, but you can't go outside the bracket. This is your window. So जो बाहर जा रहा है उसको घुमा के circularly rotate and bring to the front. Bring to the front. Okay, so -4 and 5. Okay, then 2, 1, -3, 6, 2, 0. Finish. Finish everybody. ठीक है? Similarly, okay, if I ask you, draw x of n plus 3 mod 8. Now, अब बिल्कुल without any explanation, you should be able to write down. Techniques learn करना है आपको अभी. So, n plus 3 is left shifting. You don't have any place to the left. So, whatever are the first 3 samples, कितना shift करना है? 3. So, first 3 samples as it is, take to the last. तो start करेंगे 6 के साथ. तो I have 6, 2, 0, -4, 5, and then 2, 1, -3. Exactly in the same sequence. From the beginning to the last copy कर देना है. That is what circular left shifting is. So very simple to understand circular shifting. अब folding भी बता देते हैं यहीं पे. Okay, folding भी यहीं पे बता देते हैं. What is x of -n mod 8? What is circular folding? So dear, circular folding में again what will you do is, circular folding में again what will you do it? What will you do is, listen, what you have to do, final technique I am telling you. Okay. The first sample will be as it is. Origin हमेशा origin पर आएगा ना. X of -0 is x of 0. Okay. Then take a mirror at central value. What is n? N is 8 here. 8-point signal है. Okay. So what is n by 2? 4. Okay. This is n equal to 0. 1, 2, 3, 4. इस पे आ जाएंगे. Okay. This is n by 2. which is equal to 4. Okay, then 5, 6, 7. ठीक है. What is n equal to 4? यहाँ पे कौन सी वैल्यू है? n equal to 0, 1, 2, 3, 4. ये it's like central point for me. Excluding the origin, this is like central point for me. Take the mirror image about this central point. Take the mirror image about this n by 2 point. Mirror image means ये जो अब value है, other than this, the 3 values to the left, these 3 left values to the right. Clear? Okay, so ये जो 3 values है, that is 0, 4, minus 5. Now whatever is closer to the origin remains closer to origin. एकदम swap करना है. Image of these like this. ठीक है, 2 वाला नहीं, 1 के साथ आएगा, सॉरी. ठीक है, तो सबसे पहले आएगा, रिवर्स कर देना है, 0, then minus 4 and then 5 and then 6 minus 3, 1. Whatever goes left, now take it to the right. 6 minus 3, 1. Clear? That is circular folding. That is circular folding. Then what is circular convolution? वो भी explain करता हूं मैं. ठीक है. What is going to be the circular convolution? Okay, and how to solve the circular convolution? ठीक है. We have xn convolution hn, okay, as the linear convolution given by the formula summation xk h of n minus k. Okay, from k equal to, for all values of k, that is k equal to minus infinity to infinity. This is what is your regular linear convolution. This is your regular linear convolution. This is your regular linear convolution. Okay? So, what is circular convolution? X of n, circular convolution with h of n. For periodic signals, we follow the circular convolution, also known as the periodic convolution. Okay, this is for periodic signals. Periodic, or also known as circular convolution, applicable for periodic signals basically, because for periodic signals, okay, the linear convolution will never converge, it will always give you infinite result. Okay, so for periodic signals we consider the circular convolution, and that is given by, देखो, first of all here I take xk, okay, but the xk या xn जो भी है, it is only defined between 0 to n minus 1, तो limit change होगा, 0 to n minus 1. Okay, because of the finite length constraint. And then x of n minus k is a shifting case. Again, what shifting we will follow? Circular shifting we will follow. Everything has to be between 0 to n minus 1. So circular shifting will be followed. This is what is circular convolution. How to solve circular convolution? How to solve circular convolution? Okay, I will explain with the question. Wait, how to solve circular convolution? अभी question के साथ explain कर लूँगा. ठीक है, so yeah, let's go with the properties. Linearity we took, time shifting we understood, similar to DTFT, similar to the time shift, there is a frequency shift. If there is a shift in frequency, there is an exponential term in the time domain, e power j omega naught n, but omega is 2 pi by n into k naught. Okay, frequency shift, which shift? Circular shift, understood. Okay, circular fold, like again DTFT, folding in time is folding in frequency. So x minus n gives the DFT x minus k. ये capital X है, x minus k. But both of the shifting are circular shift. Both of the folding are circular folding. ठीक है. Then symmetry property. ये next important आ गया, very important. Symmetry property. Okay. Symmetry property says that x of k will always be equal to x conjugate n minus k. Okay. And because of the symmetry property, if I suppose take n equal to 8, then I will explain you this point. This is very, very important. If I take first n equal to 4 लेते हैं, चलो, let me start with 4. When you are taking n equal to 4, you need to only compute x0, x1, sorry, DFT की बात कर रहा हूँ. You need to only compute x of 0, x of 1, x of 2. Okay. Then, whenever the calculation comes to x3, okay, whenever the calculation comes to x3, that can be written as x star n minus k, and n minus 4 minus 3 here will be 1. x1 is already calculated, so x3 will be just conjugate of it. x3 will be just conjugate of it, not to be calculated. Okay, but this symmetry property is definitely coming up from the conjugate symmetry idea only, and that is applicable for real signals. Okay, so we need to compute up to what? Basically, here we need to compute up to the value of k, which is n by 2. Up to n by 2. Now this will, now you are able to see only one calculation saved. If you take n equal to 8, if you take the n equal to 8, हाँ यहाँ पे लिखा हुआ है ऑलरेडी, so let's save that time. Yeah, so if you take this n equal to 8, so for n equal to 8, compute up to what? As I told you, for n equal to 8, you need to compute DFT up to k equal to n by 2, which is 4. Compute up to 4, and then beyond it, x5, x conjugate 8 minus 5, that is x conjugate 3, x3 निकाल चुके. Similarly, x6 is x conjugate 2, x7 is x conjugate 1. हमें तो यहीं तक निकालना है, वो तो लास्ट केवल शो किया है. Okay, so that means these three calculations are saved for you. इसका टाइम बच जाएगा, इसका टाइम बच जाएगा. Okay, so you have to calculate up to 4. Okay, then the value of 5 related to 3. Okay, but not exactly equal to the conjugate of it. Okay, so now you can call this as, like folding में हमने इसको mirror बोला था ना, this is the n by 2 point, and call it as the conjugate mirror, not a perfect mirror, but call it as a conjugate mirror, which will create the conjugate image, not the exact image, but conjugate image. That means whatever is the value here, its conjugate should come up here. उसका conjugate यहाँ पे आएगा. Okay, so these two are conjugate pair. These two also will be conjugate pair. Whatever is x2, the conjugate of it will be x6. Similarly, whatever is at 1, the conjugate of it will be x7. So they are conjugate symmetric. They are conjugate symmetric with respect to each other. Okay. Okay. So yeah, up to n by 2 exactly. Okay, I know, Ashok. Okay. That means how many calculations you are doing? Okay, how many you save? How many values you calculate? You compute up to n by 2. Up to n by 2 starting from 0. ये याद रखना. तो you are actually computing n plus 2 values. n by 2 plus 1 values. n by 2 plus 1 value, एक extra. But how many you save? By this property, you save n by 2 minus 1 values. Like 8 by 2, 4, 4 minus 1, 3 values. 3 calculations are saved. 3 calculations are saved. So now when n becomes large, na, this will be more dominant. Suppose अगर आपने n का value ले लिया 512, तो how many you do? 512 by 2 what? 256. So you do 257 and you save 255 calculations. You will do 257, but you save 255. So I can say na, nearly half you save. That is how the property is powerful for you. You can say that nearly half of the values are saved. Okay. So suggest that we need to compute only around half the values. For large value of n, it is just approximately half only. Okay. To find the entire DFT sequence. Okay. Okay. So symmetry, again, same properties, xn real and even, DFT also real and even, xn real and odd, DFT also pure imaginary and odd, just like the other Fourier transform. Convolution in time, multiplication in frequency. Circular convolution मैं अभी आपको explain करूंगा. Formula already I told you, but the calculation I will explain you. Very simple calculation. Convolution in time, multiplication in frequency, multiplication in time x1 and x2n, convolution in frequency 1 upon n, x1 के circular convolution x2 के. ठीक है. Central ordinates ये भी important property है. देखना, central ordinates important property. The central ordinates important property. What is that here for me? Okay, x of 0, okay, is summation of xn. Okay, when you take k equal to 0. When you take k equal to 0. Okay, summation xn, w power kn, that is the DFT formula. Na? But k को 0 ले लिया आपने, तो summation xn आएगा. That is summation xn. And what is summation xn? Let me open it very clearly. What is summation xn? It is simply x0. We start summation from 0 only. x0 plus x1 plus x2, etc. up to the last value xn minus 1. Okay. Then central ordinate property, of course, we take n as 2 power n and n can be even mostly. Okay, so what is the central ordinate property? Okay, when k equal to n by 2 and you calculate the twiddle factor value, it will come up to be minus 1. Minus 1, आप check कर सकते हैं. So it is summation minus 1 power n xn. Okay, that will be x0 minus x1 plus x2 minus x3. So here alternate plus minus 1 will come. Okay, क्योंकि n even है तो n minus 1 odd है, तो we will stop at minus of xn minus 1. Because for any odd power, minus 1 power odd is minus 1. For any even power, minus 1 का square is plus 1. Minus 1 power even is plus 1. Okay, that is the order. Okay. हाँ, वो पूछ सकते हैं अनंता फंडामेंटल क्वेश्चन में. नॉट बहुत ज्यादा पूछते नहीं है, बट दे कैन डिस्कार्ड दैट. ठीक है. अब देखिए यहाँ पे, दैट मीन्स व्हाट, That means what? Whenever you want to calculate the first sample of DFT, it is summation of xn and central ordinate, alternate plus minus. That is why when I have written that twiddle factor, na, जब मैंने वो twiddle factor वाला, जब मैंने matrix वाला case लिखा था, come to that matrix. Okay. The first element of the DFT is summation of all xn. That is why 1, 1, 1, 1. And the central ordinate, this one is central. x2. For n equal to 4, 4 by 2 is 2. Okay, alternate plus minus. You have to just take alternate plus minus. Okay, and then you just have to basically remember one row. That is the second row. 1 minus j minus 1 plus j. 1 minus j, okay, and then opposite sign. Minus 1 plus j. 1 minus j, बस इतना याद रख लो, opposite sign, minus 1 plus j. Do the opposite sign here. Fourth row also not required because conjugate symmetry. Okay, take the conjugate of second. Real है तो as it is रहेगा. The plus j and plus j becomes minus j. Simple. Okay, simple. Okay, we'll apply this to the question very shortly. Okay, तो conjugate symmetry हमने देख लिया है, central ordinate देख लिया है. There is also the duality, although not much important here in DFT, but you can note xn has the DFT xk. So when you put k equal to n, capital Xn will have the DFT n x minus k, n being equal to minus k. ठीक है. One last result and then we take some questions. That is the Parseval's energy relation. Energy, summation mod xn square. Energy written by the formula summation mod xn square is given by 1 upon n summation mod xk square. Okay. In the DFT, in the frequency domain, the energy is 1 upon n summation for all values of k mod xk square. ठीक है. चलो. Now, first of all, let's start with the direct question. Okay. उसी में कुछ properties भी देखते जाएंगे. Consider the xn 2, 3, 2, 1 and find the DFT of xn. First question solve करेंगे. Find the DFT of xn. Find the DFT of xn. First question, let's make it very simple because I have length 4. So what is that DFT? What is that DFT? x0, x1, x2, x3. Any confusion in remembering, you can let me know. Okay, write down the signal here. Now the values are given. Directly write down the values. 2, 3, 2, 1. What is the first sample? Summation of all. Summation of all मतलब यहाँ पे 1, 1 fill कर दीजिए. And third row, I mean central ordinate value, alternate plus minus. Okay. Then you have to only remember second row. That to 1 minus j. And now दोनों का sign opposite कर दोगे तो minus 1 plus j. Whatever is the second row, take the conjugate. 1 is 1 minus j का conjugate plus j. Minus 1 remains same plus j का conjugate minus j. Now solve and write down the answer. Finish na? So direct question point of view n equal to 4. Okay, otherwise property based question. तो अब देखते हैं. What is that x0? So 1 by 1. x0. 2, 3, 2, 1. Summation of all values na. Even if you multiply row and column, same result na. 1 into 2, 1 into 3, 1 into 2, 1 into 1. Summation of all the values and that becomes equal to 8. Okay. पहले आप central ordinate पे आ जाते हैं. Okay. What is x2? पहले central ordinate. तो alternate plus minus. मैट्रिक्स भी देखने की जरूरत नहीं है. सेंट्रल ऑर्डिनेट, ऑल्टरनेट प्लस माइनस, फर्स्ट ऑर्डिनेट, all addition. Okay, so this is 2 minus 3, 2 minus 1. Alternate plus minus I do. Okay, so this is minus 1 plus 1. I think this is 0. Check it out. ठीक है? Okay, then what is x1? Only second row and that too how to remember ये मैंने बता दिया है. तो now multiply corresponding row, second row with the column. तो 1 into 2 minus j into 3. तो minus 3j. Okay, minus 1 into 2. Okay, and j into 1. तो ये कितना हो गया? 2 minus 2 cancelled. Minus 3j plus j minus 2j and x3. भाई कुछ नहीं करना है. Don't even look into the matrix. Don't look into the matrix. Don't even look into the matrix. Okay, what is that? Okay, just take the conjugate of minus 2j. Direct result लिखेंगे ना. Minus 2 की जगह conjugate plus 2. No calculation, no matrix required. Take the conjugate. So what is your DFT? First one is simple ना. So 4-point DFT पे direct question भी आएगा. It is very simple for you. It is very simple for you. Okay. So the first answer xk in the sequence format now, क्योंकि ये भी discrete function है, and that is equal to 8. Then minus 2j. ये है x1. पहले मैंने x2 निकाल लिया था for ease. Minus 2j, then 0 and then plus 2j. 0 and then plus 2j. Clear everybody? This is xk completed. That is the DFT of the signal obtained. Simple. Okay. They can ask direct also. और उसके अलावा most of the question from here are property based. If yk is xk minus 1, find yn. Second start करेंगे. सेकेंड स्टार्ट करेंगे. गिवन y of k is equal to x of k minus 1, find the yn. Of course, x of k minus 1 means x of k minus 1 mod 4. Even if it is not mentioned, it is circular folding only. It is circular shifting only. Okay, now what should be yn? This is shifting in the frequency domain. So in the time domain xn, there should be an exponential term. In what format? Okay, opposite sign. Frequency shift में sign opposite चलता है, तो e power j omega naught n, यही होगा ना, e power j omega naught n. How do I write? I don't remember any DFT property. I have got this derivation from the DTFT only. ठीक है, अब omega naught क्या लिखोगे? Omega is 2 pi by n into k, तो omega naught कितना हो जाएगा? e raised to the power j omega naught will be 2 pi by n into k naught into n, whatever is the amount of shifting. Okay, whatever is the amount of shifting. अब आप place कर देंगे values को. K naught shifting is by 1 unit. Okay, and n is 4 as we already know. So dear, what is the yn? Yn पूछा है ना, तो that is xn into e power j 2 pi by 4, ये हो गया 1, 2 pi by 4 is pi by 2, तो e power j pi by 2n. This is equivalent to xn e power j pi by 2 whole power n. And what is e power j pi by 2 is j. So j power n xn. So what is the answer? ये लीजिए, yn is j power n xn. xn आपको पता है 2, 3, 2, 1. That is xn ना, multiplied by j power n, multiplied by j power n. तो ठीक है, मल्टीप्लाई कर दीजिए j power n से, तो j power 0, j power 1 correspondingly मल्टीप्लाई करेंगे ना, then j square, then j cube. Now write down the result. j power 0 is 1, तो ये हो गया 2. Okay, then the next answer is 3j. Then next the 2j square minus 2 and j cube is minus j. This is the signal yn for the second question. Tell me now. Shifting property ही apply किया है. I mean Shweta, this is shifting which na frequency shifting property applied here directly. That is what is done. Anything else you are referring, Shweta? Isn't it? So second part done. Simple. Property is clear है. Simple. 2 minus 3. 2, 3j minus 2 and minus j. I mean you want to shift first. देखो, not suggestible. You can, but not suggestible. Because you now calculate xk. You now calculated xk. First you will shift and then you want yn. So then you can again calculate IDFT. One more calculation you will start, IDFT. One more matrix type calculation will start. Not required ना. Not required. Lengthy हो जाएगा. Because yn चाहिए. Ultimately I don't want yk. I need yn. So you have to calculate IDFT there. ठीक है. अच्छा, also very important point. Forget this reason also, Shweta. All of this can be individual question in gate. मैं तो आपको variety बता रहा हूँ. Okay, suppose this is the only question. Then why to find DFT? The approach that you are telling, first you will calculate DFT and then you will shift. Why to calculate DFT? We only need to relate yn and xn is given to me. Any one of them will be there in the question. ना सारे तो नहीं आएंगे. Conventional paper तो है नहीं आपका. Okay, so that is why the approach I told you, property based, that is suggestible. Then next is find DFT of yn equal to x minus n. Third वाला ये भी simple है. Third में dear, you are given that y of n is equal to x of minus n. Of course mod n. So what should be yk? Time shifting corresponds to frequency folding. Sorry, time folding corresponds to frequency folding. Okay, frequency folding. X minus k mod 4. Now what is the xk, dear? Xk calculated in the first case. Yeah, here definitely xk is required and that was calculated as 8 minus 2j 0 and plus 2j. Now what we only need to do is create its folded version, x minus k mod 4, and that will be your answer yk, and that is equivalent to, how do you fold? क्या बोला था फोल्डिंग के लिए? लीव अपार्ट द ओरिजिन एंड टेक द मिरर एट द सेंट्रल वैल्यू. n इक्वल टू 0 1 2, ये है सेंट्रल वैल्यू, इसको मिरर माना हमने. ओके, एंड लीविंग द ओरिजिन यू हैव प्लस 2j माइनस 2j. मिरर इमेज की वजह से दे विल स्वैप, तो 8 एंड प्लस 2j मिरर ऑन इट्स ओन पोजीशन एंड देन माइनस 2j. दैट इज योर आंसर. फोल्डिंग इसलिए पहले ही एक्सप्लेन किया था. 8 एंड प्लस 2j 0 एंड माइनस 2j, दैट इज योर आंसर. ओके, वही चीज अभी अनंत श्वेता को बोल रहा था, जस्ट लिसन टू दैट सेम पॉइंट ओनली। ठीक है, थर्ड क्वेश्चन हो गया। फोर्थ, नाउ हियर कम्स अ सर्कुलर कॉन्वोल्यूशन। डू यू नीड टू कॉन्वोल्यूट? नो, here you don't need to convolute. One way is convolute the signal and then find the DFT again. No, I will again take it as property. Yn is xn, circular convolution xn with itself only. Okay, convolution in time, multiplication in frequency, xk convolution xk. So what is yk? It is nothing but x square k. Multiplication in frequency, x square k. Okay, so what is going to be the answer? What was xk? पहला था 8, तो 8 square, then minus 2j square, then 0 square, then plus 2j square. Okay, so final answer here for the fourth question, yk is given by 64. Okay, j square is minus 1, तो ये minus 4 आएगा, then 0, again j square minus 1, तो this will again be minus 4. So 64 and minus 4 and 0 and minus 4. 64 and minus 4, 0 and minus 4. Done है? 64 minus 4, 0 minus 4. (64 minus 4, 0 minus 4). Done है? Let's go ahead with the next question then. Okay, fifth word. Yeah, here it is. Yn is equal to x square n. Yn is equal to x square n. तो चलो वो भी कर लेते हैं. Fifth part. What is x square n? It is xn multiplied by xn. Multiplication in time. So now there will be convolution in the frequency domain given by the formula 1 upon n xk circular convolution with xk. So here you definitely do the circular convolution. Okay, n ka value 4 hai, and then let me write down the result of the circular convolution. Xk circular convolution with itself. What is the result of circular convolution? Let's learn here. How do you do the circular convolution? Okay, so we have xk as 8 minus 2j, 0 and plus 2j, and I need to convolute with itself. How do you do the linear convolution? Same technique. Linear convolution के लिए क्या करते हैं? We do a tabular method ना, sum by column method. Write down any one signal on the top, 8 minus 2j, 0 and plus 2j. Write down another signal as a list here, vertically, 8 minus 2j, 0 plus 2j. Here they are same, it may be different also. ठीक है. Then what do we do? Multiply elements of the top by this first element. Okay, पहले first रो लिखेंगे. 8 8 is 64. 8 into minus 2j is minus 16j. 8 into 0, 8 into 2j, 16j. Next we multiply by minus 2j. ध्यान देना. We multiply by minus 2j into 8 and we write down the result. Everywhere we write down the result 1 unit right. पहले एक शिफ्ट करेंगे, second next, then next. So minus 2j into 8 minus 16j, but 1 unit right से start करेंगे. This will be empty. This will be empty. Okay. Minus 2j into minus 2j, तो ये हो गया 4j square minus 4. Minus 2j into 0. Minus 2j into plus 2j minus 4j square. ये plus 4 होगा, but now comes the very important point. This right shift in the periodic signal domain represents circular right shift. And how do we deal with circular right shift? We cannot cross this boundary. So whatever element is going outside, circular shifting was applied, that comes to the front. So plus 4 यहाँ आ जाएगा, यहाँ से erase कर देंगे. Clear? Then 0. Okay, 0 into anything is 0, but normally you multiply by 0, you will start the result 2 unit right shift. 0 0 0 0, but those two zeros will come here. Okay. Now multiply by 2j. 2j into 8, 3 units right shift. ये यहाँ से लिखते हैं 2j into 8, 16j. Okay, 2j into minus 2j minus 4j square plus 4 यहाँ आ जाएगा. Circular shifting. 2j into 0. 2j into 2j, 4j square minus 4, and now add up the column, sum by column, just like linear convolution. Okay, but only thing is circular folding I am applying. Circular folding I am applying. Okay. Of course, I have assumed that you are clear with that linear convolution tabular method. ये आपको पता होगा कि how you apply tabular method for the regular convolution. तो ये हो गया 72. This is minus 32j. This looks like minus 8 and this is 32j. Okay, let me write down these values here. Okay, so we have got the value as 72 minus 32j minus of 8. Correct? Minus 8 and plus 32j. Okay, so dividing by 4, final answer for this question is 18, then minus 8j, then minus 2, and then eventually plus 8j. This is your answer. So hope the circular convolution is also clear with this example. Chalo. Next question. Quickly. Consider two real valued sequences with the time origin marked by the bold values. ये दिख रहा है ना bold में. Okay, that is the time origin. I mean the first sample, of course, it is the origin. By default also we consider. x1n and x2n is given to you. Okay. अब देखना. Let x1k, x2k be the 4-point DFTs of x1n and x2n respectively. Another sequence x3n is derived by taking the 4-point inverse DFT of. देखो, what is x3n? इस language को समझ लेना. x3n is the inverse Fourier transform of IDFT of x3. तो यहीं से देखते हैं ना. What is x3? x3 is x1k into x2k. मतलब x3k is derived by multiplying two Fourier transform, 2 DFT. Multiplication in frequency comes when you are convoluting in time. Okay, so what should be x3n? So what should be x3n? Okay, these two Fourier transform multiplied. So definitely the signals in the time domain, that is x1n and x2n, must have been convoluted. x1n convolution x2n. Circular convolution x2n. Okay. Now what is the value of x32? आप तो पूरा x3n निकाल सकते हो ना. This is again a circular convolution question only. But property आपको बस read करना है. Okay, the x3n is the IDFT of x3k, where x3k is x1k into x2k. 2 DFT are multiplied. So their signals in the time domain correspondingly are convoluted. x1n convolution x2n. अब ये पूरा convolution कर देंगे ना. क्या जा रहा है? What is the complete circular convolution? One more circular convolution practice will come for you. Nothing more. Just one more circular convolution practice है ये. And that is 1 2 3 0. किसी भी एक को top पे लिख दिया. 1 2 3 0. And then next is 1 3 2 1. You can swap them. Convolution is always commutative. You can swap them also. Okay. Now, again, if you have any doubts for circular convolution, again understand this problem. First, I will multiply by 1 all the elements. So 1, 2, 3, 0. But when I multiply by the next term 3, I will write down the result 1 unit right. Okay, so 3 into 1, 3 2s are 6, 3 3s are 9, 3 into 0. But outside नहीं जाना है ना, तो circular folding to be applied. तो 3 into 0 comes here. अभी आ गया 2 into 1, 2 2s are 4, 2 3s are 6. Come back here, 2 into 0. Now आ जाएगा 1, 1 into 1. Last 3 unit right shift ना. Then 1 into 2, 1 into 3, 1 into 0. सब कुछ add करेंगे. This is 9. This looks like 8. This looks like 11. And this looks like 14. Okay. So what is the x3n? पूरा ही आ गया ना. What is the x3n? Okay. So x3n on solving, I have got it as, let me write down the result since we have calculated. तो लिख लेते हैं पूरा. 9, 8, 11, 14. Check the calculations. 9, 8, 11, 14. What is the value of x32? By this is n equal to 0. 0, 1, 2, 11. Answer is 11. Right. This is n. n के respect में mark करें तो 0, 1, 2, 3. So for n equal to 2, it's 11. Correct answer 11. Yes, Shweta. Yes, Ankit Kumar. Correct answer 11. Very correct answer is 11. The very, very correct answer is 11. Okay. Chalo. Number 50. Let xk is k plus 1. Okay. The DFT is given k plus 1, 0 less than equal to k less than equal to 7. Be the 8-point DFT of a sequence xn, where xk is the DFT formula we all know. ये read करने की जरूरत नहीं है. What is summation 0 to 3 x of 2n? Summation n equal to 0 to 3 x of 2n निकालना है. भाई fill कर दीजिए एक बार इसको. Fill. You will get x of 0. n equal to 1 रखा तो you will get x of 2. n equal to 2 तो x of 4 alternate samples आता जाएगा, n equal to 3 तो x of 6. We need what is the value here. We need what is the value here. Yeah, Ankit, it's close to 51, but बीच में एक portion missing है अभी Laplace का. Okay, rest all we have done, but we need to take up the Laplace as well. Okay, now, you know, sum of sample property, central and first ordinate से अगर relate करें, okay, if I want to take the first ordinate property, देखो, but the first ordinate property, k equal to 0 लेके अगर चलेंगे, okay, k equal to 0 लेके चलेंगे, तो what is the first ordinate property? First ordinate property, sum of all samples, not only alternate, x0 plus x1 plus x2, okay, etc 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 up to x7. It is sum of all values क्योंकि 8 point है तो x0 to x7. Similarly, now if you take, ये तो हो गया first ordinate. If you take central ordinate now, that will be 4. So what will be x4? That is alternate plus minus x0 minus x1. Now you might have got the hint. Minus x3 etc 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 up to minus x7. The good part here is, okay, alternate plus minus is in odd samples only. Now, minus is in odd samples. So when you add these two results, all odd samples get cancelled and you need that even sample summation. Na? तो इन दोनों को जैसे ही add किया, okay, now what is this equivalent to? This is equivalent to add these two results, x0 and x4, because as soon as you add them, as soon as you add x minus 1, x minus 3, सारे odd वाले cancel होंगे. You will get x0, x2, x4, x6, but you will get twice of x0, twice of x2. हमें तो एक ही बार चाहिए. Okay, so I will divide by 2. I will divide by 2. Now, dear, what is the answer? What is x0? xk is k plus 1. Any xk is k plus 1. So x4 will be 4 plus 1. Okay, whole divide by 2. ये total हो गया 5 plus 1, 6. 6 by 2. Answer is 3. Brilliant techniques. ठीक है जी. $51st question of the Super 51, but not the last. Beach में some questions, there are some questions in middle also. The DFT of 4-point sequence xn is xk given to you. DFT is given to you, xn and xk. If x1k is the DFT of 12-point sequence, okay, now what is this? देखो 3 2 3 4. Okay, 3 2 3 4 is appearing, but in between zero padding coming up. Zero padding कब आता है? When a discrete time signal is stretched, expanded. Okay, so ये जो signal x1n है ना, okay, it is the expanded form of the given signal xn. Expanded by how much? Okay, expanded by how much? Okay, 2 zeros are coming, so we can write it as x of n by 3. Okay, x of n by 3. Okay. Now, dear, you can note down the properties. One more properties, like Z transform में भी मैंने explain किया था. Okay, if xn having the DFT xk, as I mentioned in the Z transform also, because we are dealing with the discrete domain signal, we can only talk about expansion, not the compression. Compression means loss of samples occur, and we cannot say any definite property here. Okay, but at least in the case of expansion, like x of n by 2, what is the DFT x of n by 2? You know, it will be just replica xk twice. xk twice. Okay, x of n by 3. Okay, when you solve, that will be replica xk thrice. xk thrice. Okay, similarly, x of n by 4, so xk 4 times. So, you know, what is this answer? This x1k will be nothing but xk, 3 बार replicate कर दीजिए. What is xk? It is already given to me. 12, 2j, 0, minus 2j, again 12, 2j, 0, minus 2j, one more time 12, 2j, 0, minus 2j. What is the value of x11, x8? देखो यहां से k का वैल्यू काउंटिंग होगा 0 1 2 3 4 5 6 7 8 9 10 11. So what is the value of x1 8? That is 12 divided by x1 11. 11 पे है minus 2j, and then the modulus of this. Okay, तो ये आ गया 6. The answer is 6. The answer is equivalent to 6. Chalo. Zero padding represents expansion. Try to sketch x of n by 3, Tithi, yourself. How do you expand a signal? You will get dead zeros. Reverse soch ke dekho, your doubt will be clear, Tithi. Time is almost 5. That means 6 hours completed overall. It's 5 p.m. and almost 6 hours completed. I thought we'll finish in around 5 hours, but it's 6 hours and we are left with Laplace. Problem is I have another class, after it. Okay. So, going beyond 5:15 will be difficult. So, kya kare? Going beyond 5:15 will be difficult. So, either to leave Laplace or either let's take up some important questions at least from here, because properties and all will be now on a similar theme. You have revised all transforms, na? If you go through, like I was explaining you, if you go through the list of properties, na, you can do it yourself also. You can do it yourself also. Okay, so rather than leaving it, because I have limited time right now and I've given 6 hours, the time to काफी दे दिया है. Okay, so at least let's go to some question. देख लेते question किस nature के हैं. What do you say? Either to leave it completely or either to go for some questions. Okay, I'll give all slides, don't worry. Every slide will be given to you. Laplace transform में जितना है. Okay, we all know the basic definition, some integral xt e power minus st dt. Okay, Laplace transform for e power minus at ut. Let's not derive, but yeah, one of the most important, e power minus at ut. Okay, has the Laplace transform 1 upon s plus a. But again, there is a condition for the integral to exist, and that comes up from in the form of ROC. Like Z transform में ROC, here also there will be ROC. Okay. So all important points and notes I will give. PDF में पूरा दूंगा आपको. Okay. So sigma greater than minus a. Okay. Now sigma. Sigma means the real axis. See, what is S? S is sigma plus j omega. That is like x plus jy. So this sigma corresponds to x axis known as the real part of S. Okay. So when I take x equal to constant, यहाँ पे याद रखना. When I take x equal to constant, is a line parallel to y axis? X equal to constant is a line parallel to y axis. So x greater than minus a, sigma greater than minus a. Okay, so when you want to sketch sigma greater than minus a, कैसा आना चाहिए? So firstly, have a look into this. Firstly, I take a line minus a, sigma equal to minus a, sigma equal to constant. Minus a negative value लिया है. So that is a line parallel to y axis, but I want sigma greater than this. इसके बराबर भी नहीं चाहिए. So when you sketch this condition, sigma greater than minus a, means again you are getting a region in the S-plane where Laplace transform is defined. The region in the S-plane where Laplace transform exists, converges, is ROC. Same idea like Z transform. Same idea like Z transform. ROC will again come up here. ROC will again come up here. Right, ROC will again come up here. For left-sided, two most important case. Left-sided में ROC will also be left-sided, sigma less than minus a. तो ROC की property के पहले, forget. Let's go to them signals. Let's go to them signal. एक बार I will give you the brush up also. I will just go through the slides and then we will take up the questions. देख लेना. Okay, ये देख लेना once again. Delta t having the Laplace transform 1, just like always. E power minus at जो just बताया 1 upon s plus a, sigma greater than minus a. E power minus at u minus t, minus 1 upon s plus a, minus 1 upon s plus a, but sigma less than minus a. Okay, this one is known as right-sided. This one is right-sided. This is left-sided. When you take e power minus a mod t, e power minus a mod t is e power minus at ut plus e power plus atu minus t, again two-sided signal, you will get the Laplace transform minus 2a upon s square minus a square, but ROC will be a finite strip. Like a ring, you will have a strip. Okay. Something of this kind. You will have a finite strip. Okay. Not a ring, but finite strip. In the S-plane, you will have a finite ring between two poles. The poles will be minus a and plus a. Okay, t e power minus a t ut 1 upon s plus a ka whole square. Okay, again, now, do I need to remember these ROC separately? नहीं. तो अब यहाँ पे ROC की property को mix करेंगे. So what are the important ROC property? You will feel lot of similarity. You will feel the lot of similarity. ठीक है. So like in the Z transform, ROC was consisting of circular regions. Here it will be strips. Okay, all the strips parallel to the y-axis, but maybe right, maybe left, but parallel to the y-axis. Parallel strips parallel to j omega axis. Y-axis मतलब j omega axis. आप y-axis से भी याद रख सकते हो. ROC of course cannot contain any poles. ठीक है. Now once again, if signal is right-sided, Z transform में क्या study किया? ROC is exterior. Here ROC is right-sided, right of a line. वहां पे सर्कल के रिस्पेक्ट में देखते थे, यहां पे लाइन के रिस्पेक्ट में देख रहे हैं. लाइन पैरेलल टू वाई एक्सिस, वो भी क्लियर है. ओके, सो व्हेन द सिग्नल इज राइट साइडेड, आरओसी इज आल्सो राइट साइडेड एंड लाइंग वेयर देयर कैन बी मल्टीपल पोल्स. अभी तो सिंगल पोल आया, देयर कैन बी मल्टीपल पोल्स. ओके, लाइंग टू द राइट ऑफ द राइट मोस्ट पोल. Lying to the right of the rightmost pole. Simple logic is ROC cannot contain any pole. Similarly, if a signal is left-sided, okay, ROC is also left-sided and lies to the left of the leftmost pole. Lies to the left of the leftmost pole. ठीक है? Again, if a signal is two-sided, ROC will be not a strip, not a ring, but a strip. So, if a signal is two-sided, okay, ROC, okay, is a strip between two poles, sigma 1 to sigma 2. It is a finite strip. Finite width की एक strip होगी, just like I have shown you. Okay, ठीक है. Then if the signal is of finite duration, then again the ROC is entire S plane. Here zero infinity का condition भी नहीं आएगा. Finite duration signal, ROC will always be entire S plane. अच्छा, now what we learned in Z transform and DTFT connection, whenever the Z transform ROC contains unit circle, DTFT will be defined. Here unit circle will be imaginary axis, matlab the counterpart, the analogous part of it. So whenever the ROC contains j omega axis, okay, Fourier transform, continuous time Fourier transform will also exist. भाई उसका logic भी है ना, उसका clear cut logic है, the basic definition. As I told you, in general S is sigma plus j omega. Okay, so if you take sigma equal to 0, you get S equal to j omega, and sigma equal to 0 means only S equal to j omega, pure imaginary. So when you calculate the Laplace transform on the imaginary axis, what do you get? You get integral xt e power minus st, but s to hai j omega. You get e power minus j omega t dt, and that is what is your Fourier transform formula जो हमने आज सुबह study किया है. So what is Fourier transform? It is just the Laplace transform evaluated on the imaginary axis. Okay, that is why the ROC of Laplace transform, if it includes the imaginary axis, Fourier transform will also exist. Fourier transform will also exist. That is the connection between Fourier and Laplace. Okay, then we were talking about some important Laplace transform pair. पहले उसको complete कर लेते हैं. ठीक है? हाँ. So t e power minus at ut derived using txt property, free s differentiation property, 1 upon s plus a whole square. Now right sided pole is minus a, तो sigma greater than minus a directly बोल सकते हो. ut next important step and ramp. Okay, ut Laplace transform 1 upon s, ramp Laplace transform 1 upon s square. Okay, next t power n ut. T power n ut, it could be parabolic, cubic, any term, any polynomial term given up. Okay, factorial n upon s ki power n plus 1. Cos omega t ut s upon s square plus omega square. Important sinusoids का भी important होता है. Sin omega t ut omega upon s square plus omega square. These are the important pairs to be remembered. ठीक है. Now Laplace properties also, if you see, let's go back, and if you see the Laplace properties also, many of them you can relate with what you have studied. Linearity, signals are added, Laplace transform added. Okay, ROC logic, if it is clear. What is the logic of ROC to be remembered? ROC cannot contain any pole. It will be always containing strips parallel to y-axis. Right-sided signal, ROC right-sided. Left-sided signal, ROC left-sided. two-sided signal, ROC is a strip. Finite duration signal, ROC is entire S-plane. कोई pole नहीं आता, entire S-plane. So then this is not to be remembered. Formality के लिए notes complete किया, but this is not to be remembered. Just like I told in Z transform, the approach similar है. ठीक है. Time shifting corresponds to exponential term e power minus st not xs. Time scaling x of at 1 upon mod a x of s by a. ऐसा ही कुछ फूरियर ट्रांसफॉर्म में भी देखा था. x minus t, x minus s. Conjugation x star. Differentiation s into xs, d by dt of xt, s into xs. Integration property, integral x tau d tau, xs divided by s. S differentiation, yeah, also known as t times property. Also known as t times property. Txt minus d by ds of xs. Okay. S shifting, shifting in s. Exponential term in time. तो e power s naught t, opposite sign के साथ again. E power s naught t xt, x of s minus s naught. Convolution in time, multiplication in frequency. बहुत सारी चीजें repeat ही हो रही हैं. Okay, divide by t. Okay, integral xs ds. यहाँ से भी question बन जाता है कभी कभी. So xt divide by t, integration. Like, you know, when xt multiplied by t, t times differentiation in frequency. Divide by t, integration in s domain. So xt by t, integral t से infinity xs by xs ds. Okay, बस इतना है. अब कुछ क्वेश्चन देखते हैं हम लोग. So all these slides will be there in your PDF. Don't worry. Okay, first ROC based question. Although ROC based questions are more important for Z transform, Laplace में भी आ सकता है, but not that important. But ROC based question are very very important. Pure only ROC based question Z transform में very important. Repeatedly question keeps coming. चलिए बताइए. Okay, so e power minus 3t ut, what is the ROC? For e power minus 8t ut, ROC is sigma greater than minus a. Okay, for e power 2tu minus t, sigma less than minus a, and that will be 2. Okay, sigma greater than minus 3, and whenever two signals are added, मैंने क्या बोला था? When two Laplace transforms are to be coming up together, whether addition, multiplication, subtraction, both ROC should be satisfied. That means you have to take the common ROC. Common means intersection, so you have to make them intersect. So what is the answer? Sigma greater than minus 3 but less than 2. So minus 3 less than sigma less than 2. ये याद रखना, I am comparing it with e power minus 80. I am comparing with e power minus 80. That is why a minus 2. Sigma less than minus a. तो minus a will become plus 2. ठीक है. I don't want this Laplace transform. Laplace भी निकाल सकते हो आप, but I only wanted ROC here. ठीक है. Next, Laplace transform for e power minus 5t sin 80 ut. Simple, important and simple. देखो, we know for sin 80 ut. Let us take this. What is the Laplace transform for sin 80 ut? Sin omega t formula, important one. Sin omega t formula, omega upon s square plus omega square. So 8 upon s square plus 64. Now exponential term in the time domain, e power minus 5t sin 80 ut. Dear, exponential term in the time domain corresponds to s shifting. S shifting. Okay, opposite sign के साथ. So if it is e power minus 5t, there s plus 5 has to be done. There s plus 5 has to be done. So 8 upon s plus 5 whole square plus 64. Okay, direct answer. Simplify भी नहीं किया गया है. Even we can simplify the denominator and options can be made, but this is direct. 8 upon s plus 5 whole square plus 64. Done है. चलो next question की तरफ चलते हैं. Laplace transform for t sin 80 ut. T से now t multiplication property. Okay. Sin 80 ut. Sin 80 ut. Just now we have seen that the Laplace transform is a upon s square plus a square. Okay. So for t sin 80 ut, t times, that means s differentiation minus d by ds of xs. Remember the clear property. So उसके लिए आपको notes को एक बार और revise करना पड़ेगा so that all properties are in place. Minus d by ds of xs. Okay, numerator तो constant है. 1 upon x differentiation first of all will be minus 1 by x square. तो minus को हटा देंगे. Minus 1 by x square, minus minus cancel. So s square plus a square whole square. Then by the chain rule 2s will come. Okay, so it is equal to what? Option match कर लीजिए ना. It is equal to 2as upon s square plus a square का whole square. Answer is a. Finish. 2as upon s square plus a square का whole square. That is simple and finished. ठीक है, next. Okay, u of 1 minus t, u of 1 minus t. ut से स्टार्ट करें. देखो u of 1 minus t, first of all I can write it as u minus t plus 1. And how will I deal? There is folding and shifting both as per precedence. जैसे फोरियर में अप्लाई किया था, फर्स्ट शिफ्टिंग देन अप्लाई स्केलिंग और फोल्डिंग वॉट एवर. तो पहले ut लाप्लास ट्रांसफॉर्म इज 1 by s, उसमें तो कोई डाउट नहीं है. ओके, सो देन u of t plus 1, only first I do the shifting. Okay, time shifting corresponds to exponential term in the s domain. Same sign के साथ time shifting में same sign, तो e power plus s upon s. Okay, so now u of minus t plus 1, time folding corresponds to s folding, x minus t, x minus s. तो ये आंसर आ गया. तो आंसर should be e power minus s upon minus s, दोनों तरफ minus s. Okay, so it is answer D, minus e power minus s upon s. Done है, सिंपल ना. इट इज डी, बी नहीं होगा डी. अच्छा, बी और डी सिमिलर हो गया है. ओ, बी और डी गॉन सिमिलर. चलो, तो लेट मी टेक बी एंड लेट मी चेंज दिस ऑप्शन. लेट दिस बी ई पावर प्लस एस. ठीक है, इसको थोड़ा सा मैनिपुलेट कर दिया. ठीक है, बी और डी हैव टाइपो एरर, बोथ हैव कम अप टू बी सेम. ओके, सो आई हैव चेंज्ड द डी. ठीक है जी, ठीक है जी, ठीक है जी. चलो, अभी और प्रॉपर्टी बेस्ड क्वेश्चन करेंगे. बट या let us come to the next important case, differential equation. Differential equation analysis, getting the transfer function or the impulse response of the system. The input xt and output yt of a LTI system are defined to you. d2y by dt square minus dy by dt minus 2yt equal to xt. What is the impulse response? What is the impulse response? What is the impulse response? Okay, first, before the impulse response, let us calculate the transfer function. Okay, so we have d2y by dt square. Okay, minus dy by dt minus 2y is equal to xt. Okay, first of all, take the Laplace transform on both the sides. So now here you have to apply differentiation properties. Okay, what is the Laplace transform for d2y by dt square? S square ys minus then s into ys. Okay, minus 2 yt Laplace transform ys is equal to xt Laplace transform xs. xt Laplace transform xs. Okay, now what is ys? I take common, so s square minus s minus 2 is equal to xs, and then we all know that transfer function, first as we defined the transfer function in the discrete domain also, z ke form mein, here we have the transfer function, suppose hs, and again that is the ratio of output Laplace transform divided by the input Laplace transform, and y upon x here will be equal to 1 upon s square minus s minus 2. It will be 1 upon s square minus s minus 2. 1 upon s square minus s minus 2. Okay, so with this, let me move forward. I have h of s is equal to 1 upon s square minus s minus 2. That will be further equivalent to, factorizable hai, s minus 2 and s plus 1. Minus 2 plus 1 minus 1, minus 2 into 1 minus 1. 1 upon s minus 2 into s plus 1. Clear everybody? Okay, let me also break it into partial fraction. All the poles to aa gaye hain mere paas. The poles are s equal to plus 2 and minus 1. Plus 2 and minus 1. And if I break it into the partial fraction, dear, I should be getting, let me try first, 1 upon s minus 2 minus 1 upon s plus 1. If I subtract it directly, तो s plus 1 minus s minus 2, s तो चला जाएगा, 1 minus minus 2, 3 आ जाएगा. Okay, so let me divide by 3. ठीक है. Now, if there are two poles, what are the possible ROCs? If there are two poles, dear, what are the possible ROCs? I have the pole at plus 2, I have the pole at minus 1. What are the possible ROCs? Think. There are three possible ROC, na? Right, left, finite. Right-sided, left-sided, finite strip. Okay, so what is the first possibility for ROC? What is the first possibility for ROC? Let me rewrite this HS for you once again. HS is 1 by 3, 1 upon S minus 2 minus 1 upon S plus 1. Okay, what is the first possibility for ROC? Case number 1, ROC. Right se start kare. Right, if it is right sided, it should be right of rightmost pole. Okay, you cannot take right of -1. If you take right of -1, the beech mein pole aa jayega. Pole is not allowed. That is why I clearly told you, if it is right sided, right of the rightmost pole. Okay, the first possibility, sigma greater than 2. Okay, sigma greater than 2. Second possibility, dear, ROC ke liye, sigma left sided. But left sided, left of what? Left of the leftmost pole. Leftmost pole is -1. So sigma less than -1. Third possibility of ROC will be, okay, ROC is between them. -1 less than sigma less than 2. -1 to 2. -1 less than sigma less than 2. Finite strip. Acha, in which of the case system now can be stable, can be causal? So what is the condition for causality? Z transform se yaad karo. Condition for causality was ROC exterior. Here also ROC exterior. Exterior means right sided here. I'll make it revise. I'll make it revise for you. Ek baar go through it. Okay. Because the condition for causality is HT equal to 0 for T less than 0. That means impulse response is a right-sided impulse response. And for any right-sided signal, ROC of Laplace transform is also right-sided. Okay, that is why the ROC associated with the transfer function is right-sided for a system to be causal. For a system to be causal. Next condition is stable. Okay, stability. Z transform se recall karenge. So stability means ROC including unit circle. Here, stability means ROC including j omega axis rather than unit circle. J omega y axis आएगा. तो ROC including j omega axis. Okay, इस तरीके से भी देख सकते हो. Stability means impulse response should be absolutely integrable. And if the impulse response is absolutely integrable, this is the Dirichlet's condition for Fourier transform also. This means Fourier transform will exist. For Fourier transform to exist, ROC includes the unit circle. ये अभी explain किया था ना. For a system to be both stable and causal, Z transform, ROC, all the poles inside unit circle. For both stable and causal, only poles condition, forget ROC. For a system to be both stable and causal, all poles inside unit circle, here I will say all poles, okay, lie to the left half plane. Okay, for a system to be stable and causal, combined condition for causal and system, all the poles lie in the left half of S plane. That is left of j omega axis. Okay, left half plane में सारे poles होने चाहिए. Left half plane में सारे poles होने चाहिए. ठीक है. So by virtue of this, if I just complete the answer, okay, तो सबसे पहले not necessary to calculate inverse. There can be question on inverse Laplace transform. There can be only question on stability and causality पे comment. तो पहले वो कर लेते हैं. So if sigma greater than 2, that means definitely right-sided, it is causal. But dear, if you take sigma greater than 2, if you take this ROC, sigma greater than 2, do you include the j omega axis? Not included. Not included. Okay, so that is why it is unstable. First case, causal but not stable. Second case, sigma less than -1. Sigma less than -1. Exactly left-sided. Exactly opposite of causal is known as anti-causal. Exactly opposite of causal, anti-causal, but here also j omega axis not included. So second case, it will be anti-causal, but yet unstable. Third case, ROC finite strip. ROC finite strip between -1 से 2. Neither right nor left. So nor it is causal nor it is anti-causal. It is general non-causal system. For third case, it will be non-causal, but it included y-axis in between. Okay, and that is why it will be stable. So it will be non-causal and stable. Dekho, here, in any condition, causal and stable together not happening. If it is causal, it is unstable. If it is stable, it is non-causal. Together ho hi nahi sakta. Why? For the system to be together stable and causal, all poles must lie in the left half plane, left of j omega axis. All poles must lie here, but one of the pole is at the right, na? It may be individually stable, it may be individually causal, it cannot be together. नहीं हो रहा है. All the three conditions are in front of your eyes. ठीक है? अच्छा, then final answer, what is the impulse response? भाई इसका इनवर्स लाप्लास बताना है ना, तो 1 upon s minus a, whose Laplace transform? देखो sigma greater than 2, that means you are considered right, both the right side formula. Sigma greater than 2, तो greater than -1 automatically. तो answer is 1 by 3 e raised to the power 2t ut minus e raised to the power minus t ut. Dear, e power minus 80 ut formula. ठीक है, e power minus 80 ut formula. Next case में it is 1 by 3 e power 2t. देखो यहाँ पे सिग्मा लेस देन -1 तो ऑटोमेटिकली लेस देन 2. दोनों में लेफ्ट साइडेड फॉर्मूला. व्हाट इज द लेफ्ट साइडेड फॉर्मूला? माइनस ई पावर माइनस एटी यू माइनस टी. ओके, यहां पे आ जाएगा माइनस माइनस प्लस ई रेज टू द पावर माइनस एटी यू माइनस टी. थर्ड केस, सिग्मा इज ग्रेटर देन -1 बट लेस देन 2. ओके, लेस देन 2, इसके लिए लेफ्ट साइडेड, इसके लिए राइट साइडेड. ओके, सो व्हाट इज एच टी? 1 by 3. For sigma equal to 2, sigma less than 2. Less than means sigma less than minus a means left-sided formula. Minus e power minus 80 u minus t. Sigma greater than -1. Sigma is ahead of -1. So when sigma greater than -1 with respect to this right-sided formula, e power minus 80 ut. Basic two formulas are applied here. You can note down all the answers. You can note down all the answers. अब देखो, option match करेंगे. If it is stable, if it is causal, देखो पहले एक एक करके. स्टेबल मतलब थर्ड केस में हमारा जो आंसर आया है -1 by 3 एंड -1 by 3. ठीक है, e power 2t u minus t, e power minus t ut, करेक्ट है. ओके, causal में हमारा आंसर करेक्ट आया है. लेट मी जस्ट मैच इट लाइक दिस. लेट मी ओपन द स्लाइड पैरेलली. इट्स टेकिंग अ लॉट ऑफ टाइम. ओके, हाँ, तो causal में आया है 1 by 3 e power 2t and minus e power minus t. ठीक है, and if it is neither causal nor stable, okay, that means anti causal वाला केस ले सकते हैं. तो -1 by 3, ठीक है, and then +1 by, ये 1 by 2 नहीं आएगा, ये गड़बड़ है. ठीक है, आई थिंक दैट्स अ टाइपो एरर. 1 by 2 का तो कोई लॉजिक ही नहीं है. ओके, आई विल टेक द आंसर एज C also and let me correct this to 3. 1 by 2 का तो लॉजिक ही नहीं है. ABC, let's take ABC correct. Okay, but this equal to 1/3. ठीक है, तो इट्स अ कंप्लीट क्वेश्चन विद कॉजलिटी एंड स्टेबिलिटी कंडीशन रादर देन द इनवर्स लाप्लास. देखो मैं अगेन बोलता हूं, ओके, मे बी दे डोंट आस्क दिस फॉर्मूला. यहां तक निकाला एंड व्हाट इज द आरओसी फॉर कॉजल स्टेबल, दैट इज वेरी इंपॉर्टेंट. दैट इज वेरी इंपॉर्टेंट. इनवर्स लाप्लास पूछ लिया तो भी इजी है. जस्ट द बेसिक फॉर्मूला e पावर माइनस 80 ut एंड e पावर माइनस 80 u माइनस t, राइट एंड लेफ्ट. वो हमेशा याद रखना. टू मोस्ट इंपॉर्टेंट फॉर्मूला ऑफ लाप्लास. But these conditions are actually more important. Causal, non-causal, anti-causal, stable, unstable. ठीक है, चलो. Next important type of question from Laplace transform is the waveform containing maybe some amplitudes or ramp. Okay, so what is the Laplace transform for this signal? देखना, rectangular signal can anytime be expressed as the difference of two unit steps. So what is this signal GT equivalent to? Okay, let a unit step start from t equal to 3, that is ut minus 3. Okay, but that ut minus 3 actually will go to infinity. Let another unit step start at t equal to 5. Okay, let another unit step start at t equal to 5. Okay, and now you subtract. So you subtract, तो ये जो common वाला है, ये 1 minus 1 0, you will only get this much of the portion. Subtract this. Okay. Any confusion with sketching of the waveform, identification of the waveform? I think I don't remember the name, but you know, you can just search my YouTube video. मैंने लिया है fundamentals of signals में. Okay, step ramp signals के साथ. Okay, you can search that. Very helpful if you are not clear with the sketching part and all. अभी तो मैं थोड़ा सा quickly बताते जा रहा हूँ. Okay, so what's going to be the Laplace transform? Unit step Laplace transform 1 upon s, time shift apply करना है. ut minus 3 to e power minus 3s. Again unit step 1 by s, t minus 5 to e power minus 5s. Okay, so answer is e power minus 3s minus e power minus 5s whole divided by s. e power minus 3s, अच्छा इसमें से e power minus 3s को कॉमन लेके लिखा है हमने. So if I take the e power minus 3s common out of these two, if I take it common na, okay, and then divide by s भी common ले लिया, तो 1 minus e power minus 2s portion will be left. Then I am think C is the match. C is the match. Correct है? Okay. Find the Laplace transform of this waveform shown below. Find the Laplace transform of this waveform shown below. First of all, it's a straight line. That's like a ramp. Okay, so we start with the ramp. What is the slope? What is the slope here? Okay, पहले इसका slope निकाल लो. Slope, that is m, and height. Height up to this point ये हो गया 10 and base up to this point is 2. The slope is height upon base and that will be 5. Okay, slope of unit ramp signal is unity, so it is 5 times ramp starting from origin. So what is the xt? Okay, let me call it as rt. Okay, but of slope 5. Okay, the 5 rt. But if you only write rt, ramp signal goes from 0 to infinity. The ramp signal goes from 0 to infinity. So if I only write 5 rt, it is incomplete, na? Okay, so we have to stop the signal here. अब देखो, what is the signal beyond it? If you trace it up completely, इसको ध्यान देखना. Okay, it rises like ramp. Okay, but then at t equal to 2, dear, इसका value भी drop हो गया, and after that the slope also becomes 0. After that the slope also becomes 0. What is the slope of this portion? Of course. What is the slope of this portion? Now it is 0 because you are running on the x-axis. X-axis means 0 slope. So at t equal to 2, slope also changes and value of the signal also dropped. Change in the value, like previous question. At any point when you want to drop the value suddenly, you have to subtract step signal. यहाँ पे क्या किया? The value was 1, suddenly dropped to 0. So at t equal to 5, I started a step signal and उसको मैंने subtract किया. ठीक है? Same thing I have to do here. I have to subtract slope also. Slope 5 tha. Okay, slope is subtracted by ramp. So here I start a ramp. Ramp starting at t equal to 2. Right shifted ramp. Right shifted ramp rt minus 2. And that ramp has the slope 5. Whenever ramp signals are added or subtracted, their slopes are added or subtracted. So slope ho jayega 5 minus 5, 0. But if you only subtract ramp, na, what will happen? From here slope will become 0. But bhai 0 slope to ye bhi ho sakta hai. At here slope will become 0. 0 slope is parallel to x-axis also. So the signal should go like this. What I am telling you, the value also should drop to 0. How much is the value now? 10. The value to be dropped to 0. And to change this value instantaneously, you have to subtract unit step. Unit step starting at t equal to 2. So ut minus 2. Okay, how much value to be dropped? 10. So you should take 10 unit step. You should take 10 unit step. And now your answer. Laplace transform. Ramp. 1 upon s square. Again ramp 1 upon s square, but time shifting e power minus 2s. Step 1 upon s, time shifting e power minus 2s. Answer combining the terms. Let's take the denominator as s square. So you have 5 minus 5 e power minus 2s minus 10. एक बार s multiply करेंगे तो 10s e power minus 2s. That's your answer. So, you know, Laplace transform is very common, these waveform based question, and the important thing is you should be clear about either sketching a waveform or vice versa here, analysis of the waveform. And again, if you have any doubts in the sketching part, especially combining step and ramp signals, so you can search my videos. थोड़ा सा ही time लगेगा, आधा एक घंटा देके आप समझ सकते हो उसको. Okay, you can search my earlier videos on the, you know, step and ramp signals. Okay, there you can find the sketching and all. So guys, a very similar question of this kind we have done in the Z transform. You please try for Laplace transform. Okay, consider the following statement regarding an absolutely integrable signal which is known to have a pole at s equal to 2. I did not say only pole at s equal to 2. There is a pole at s equal to 2. Maybe it is the only pole. Maybe there are some other poles. Possibility, signal left-sided, right-sided. Exact similar question in Z transform. But wahan pe the conditions are of unit circle here. The conditions are with respect to imaginary axis. But if you have got that question, ye bhi hona chahiye. You can refer to that Z transform question. You can refer to that Z transform question. Right hai ji? Usko ek baar zarur aap refer kar lena. Then this is also done. Then this is also done. I think just few more questions left. How do you solve convolution of step with ramp? Mathematically बहुत complicated होगा by the convolution formula. What is the convolution of ut plus 1 convolution rt minus 2? Step convolution step is okay. Step convolution step is ramp. But step convolution ramp to be taken by Laplace transform. To be taken by Laplace transform. So dear, we should only know that ut is having, यहाँ पे start करते हैं चलो उसको. We know that ut has the Laplace transform, that is 1 upon s. rt has the Laplace transform, that is 1 by s square. Okay, so first time shifting भूल जाइए. Let me form a general formula. What is step convolution ramp? So when you convolute, what should be the Laplace transform? When you convolute two signals, Laplace transforms are multiplied. Okay, so multiplication of 1 upon s with 1 upon s square, that becomes the 1 upon s cube. That is 1 upon s cube. ठीक है, 1 upon s cube, ut convolution rt. Okay, now that is the Laplace transform. What is the time domain result? देखो एक चीज recall करना. t power n ut has the Laplace transform factorial n upon s की power n plus 1. s की power n plus 1. तो जैसे ही मैंने t square लिखा, t square ut should have the Laplace transform factorial 2 upon s cube. तो s cube कहाँ आना चाहिए? t square में. But there is only 1 by s cube. तो 2 को divide कर लेंगे. 2 को divide कर लेंगे. So this is known as the Laplace transform of t square ut divide by 2. Divide by 2. Okay, that means what is ut convolution rt? What is ut convolution rt? It is t square by 2 ut. As a general formula, future के लिए भी आप याद रख सकते हैं. Okay. Step convolution step तो पता होगा ना? ये इसके पहले ही मैं कहीं लिख देता हूँ. Dear, this is directly solved by convolution also. Step convolution step is ramp. Step convolution step is ramp. That can be done by Laplace and that is done by direct convolution also. This is easy. But step convolution ramp by direct convolution formula will be very lengthy. So this is easy. T square by 2 ut. So if I use this now, let us use this formula and let's make it as a standard result. So what is step convolution ramp? Okay, step convolution ramp is given by t square by 2 ut and now convolution property. Again you can apply the Laplace property or I will solve by convolution property. Convolution property ये बोलता है कि whenever there is shifting in any of the signal, the same shifting is reflected to the output also, and if both the signals are shifted, okay, combination of both shift will be reflected here. So plus 1 minus 2, plus 1 minus 2, how much is the total shifting? Minus 1. तो यहाँ पे लिखेंगे t minus 1. मैं पूरा लिख देता हूँ, t plus 1 minus 2, like that it should be. So hence your answer, t minus 1 whole square, u of t minus 1 whole divide by 2. Whole divide by 2. Answer is C. Answer is C then. ठीक है जी? All clear? Answer is C. Done. Laplace transform of e power t d by dt of e power minus 2t u minus t. Just two-step property. Hi Yash. A two-step property to be applied here. Let us start with u minus t बाद में लेके आएंगे. Okay, or you can start with the left-sided formula also directly. E power minus at u minus t. E power minus at u minus t. What is the formula? What is the formula? Minus 1 upon s plus a. Minus 1 upon s plus 2, e power minus at u minus t minus 1 upon s plus 2. Okay. ROC एकदम last में लिखूंगा. I told you ना ROC exactly at the last. Don't worry, ROC step by step. Okay. Then d by dt. D by dt. Okay. So will produce the Laplace transform s into xs. So minus s upon s plus 2. Last but not the least, e power t exponential term in the time. Okay, corresponds to s shifting property, e power t d by dt of this signal. Okay, so s shifting opposite sign के साथ it is e power plus t. So here I will write s minus 1. S will be replaced by s minus 1. तो ये हो गया 1 minus s upon s plus 1. करेक्ट. नाउ ROC बताइए. नाउ ROC, I told you ROC के लिए no remember any property, just remember the basic points about ROC. What is the pole? S equal to -2. So what is the ROC? Right, there is only one pole. There is only one pole. So ROC right or left? Eventually left sided signal है ना, U minus T you are talking about. Left sided signal है, तो ROC left sided sigma less than. Okay, तो 1 minus S upon S plus 2. 1 minus S, अरे कहाँ गया? 1 minus S upon S plus 2. अरे कुछ सॉरी. 1 minus S upon S plus 1. टाइपो एरर. S minus 1 plus 1 था, तो 1 minus S upon S plus 1. ये क्लियर है? ओके, 1 minus S upon S plus 1. बट ROC ये देख लीजिए, लेस देन -2. आंसर इज बी, बिकॉज ये दोनों एक्सप्रेशन सेम है, ये तीनों एक्सप्रेशन सेम है. ओके, ROC ऑल्सो मैटर्स. ओके, अच्छा सॉरी, अरे बाबा वो मैंने टाइपो एरर वहां पे भी आ गया. आंसर इज सी देन, बिकॉज आई डिड द टाइपो एरर हियर. तो पोल भी चेंज हो गया ना. सो व्हाट इज द पोल डियर? -1 सिग्मा लेस देन -1. खत्म. सो आंसर इज सी. आंसर इज सी. डन है. ठीक है. फाइंड द इनवर्स लाप्लास ट्रांसफॉर्म. फाइंड द इनवर्स लाप्लास ट्रांसफॉर्म. Okay, S power -2 d by ds e power -3s upon s. Okay, now let us start with 1 upon s. Whose Laplace transform is 1 upon s? Hey, whose Laplace transform? Inverse चाहिए ना, तो whose Laplace transform उल्टा start करेंगे. 1 upon s is the Laplace of ut. Then what is the next term I need? E power -3s चाहिए मुझे. Exponential term in the s domain, तो time shifting is required. Time shifting is required t -3. So u of t -3 having the Laplace transform e की power -3s divided by the s. ठीक है. अच्छा जी. Note down the password also parallelly, otherwise I will forget. Okay, so many of you have been consistent. Mornings 11 a.m. to 5:30, 6.5 hours. We are about to close because I have another class, so I will be closing now very soon. But almost all questions done. I think सारे ही हो गए. Okay, सारे questions हो गए. 51. RAMP. The password for today's PDF will be RAMP. RAMP everything in small. RAMP everything in small. ठीक है? Please note down the password and let it be with you. Okay. It's a secret to you because you have been consistently sitting 6.5 hours non-stop. You deserve it. I only want, okay, those who are attentive, those who are ready to give the same energy since I am giving from morning. ठीक है, उन्हीं के लिए password होता है. Don't disclose the password anywhere in groups and all in my Telegram at least. ठीक है, आ जाते हैं. Let's complete the theory now. So e power -3s by s तक आ गए. Next is d by ds. S differentiation, t times property. तो if I multiply by t now, t -3. That has the Laplace transform minus d by ds actually. Minus d by ds. ठीक है, माइनस तो चलो बाद में एडजस्ट कर लेंगे. Now what I need is s की पावर -2. 1 upon s square. 1 upon s square. 1 upon s square एक्स्ट्रा चाहिए. डिवाइड xs by s कब आता है? इंटीग्रेशन. So देखो ध्यान रखना. Okay, now you will integrate. Integral -∞ से t. Integral -∞ से t tau u tau -3 d tau. Okay, that will have the Laplace transform. Okay, -1 by s. 1 upon s आएगा ना इंटीग्रेशन की वजह से. d by ds of e power -3s by s. ठीक है. So what is the value of this integral? चलो quickly बताएंगे. Okay, ये हो जाएगा u tau -3 ना. That starts from only 3. तो 3 से t tau d tau. ओके, टाउ का इंटीग्रल टाउ स्क्वायर बाय 2, लिमिट लिया 3 से लेके t. सो दिस इज लाइक t स्क्वायर -9/2. ओके, t स्क्वायर -9/2. ओके, सो आई हैव t स्क्वायर -9/2 इंटू u ऑफ t -3. u ऑफ t -3 तो चलेगा बिकॉज द इंटीग्रेशन ऑल्सो शुड बी वैलिड फॉर t ग्रेटर देन 3. ओके, तो t स्क्वायर -9/2 u ऑफ t -3. This will have the Laplace transform -1 by s d by ds e power -3s by s. One last step. I need 1 by s square. I need 1 by s square. So one more integral -∞ से t tau square -9/2 u of tau minus 3. This will have the Laplace transform minus 1 by s square d by ds e raised to the power minus 3s by s. So what is your answer, dear? What is your answer? Okay, हमें चाहिए 1 upon s square term minus. Okay, minus को आप नीचे कर लीजिए, माइनस को आप लेफ्ट साइड पे ले. योर आंसर विल बी माइनस इंटीग्रल माइनस इंफिनिटी से टी टाउ स्क्वायर माइनस 9/2 u ऑफ टाउ माइनस 3 डी टाउ. दैट शुड बी योर आंसर. दैट शुड बी योर आंसर. ठीक है, मैं एक सिंपल लाइन में आंसर लिखूंगा. अगेन इंटीग्रेशन विल बी फ्रॉम 3 से टी. ओके, माइनस को आउटसाइड लिखेंगे. ओके, 1/2 को आउटसाइड लिखेंगे. टाउ स्क्वायर इंटीग्रल टाउ क्यूब बाय 3 देन माइनस 9 टाउ. ओके, एंड लिमिट इज 3 से लेके टी. लिमिट इज 3 से लेके टी, तो माइनस 1/2. ओके, टी क्यूब बाय 3 माइनस 9t माइनस ये हो गया 27/3 9. ओके, माइनस माइनस प्लस 9 3s are 27. ओके, नाउ गो एंड मैच योर आंसर्स. 3 को भी अगर बाहर ले ले ओवरऑल तो 1/6 टी क्यूब माइनस 27t एंड 54. Minus is running outside. T cube minus 27t plus 54. Minus था ना बाहर? Yeah, correct answer is then C. Correct answer is C. Done. ठीक है dear, we are done. We are done with all questions and I will take a stop here now. I will take a pause now. That's it, and all questions done basically. Basically, actually all questions are done. सारे क्वेश्चंस हो चुके हैं. ओके, पीडीएफ यू विल गेट इन द टेलीग्राम ग्रुप. वन मोर इंपॉर्टेंट अनाउंसमेंट फॉर यू डियर, वन मोर इंपॉर्टेंट अपडेट फॉर यू इज दैट टुमारो same time 11 a.m. okay, one more session. Okay, for practice of mathematics, MSQ questions. Dear, maths MSQ questions. Maths MSQ question. Okay, गेट 2021 से 23 में पूछे गए सारे previous year. Okay, there are a lot of questions from maths coming up in the MSQ format. Okay, so all questions discussion tomorrow 2021 to 23, only MSQ from the maths. So it will be practice also, and you will see how the variety of MSQ is coming up from the mathematics. Okay, tomorrow 11 a.m. on the same channel. Okay, stay subscribed if you want to attend all of them without any miss. Okay, last but not the least, let me share the Telegram link, and by that also let me start saving my file. चलो बाद में करते हैं इसको, because I need to rush up for the next class. Yeah, let me save the PDF because I need to rush up quickly now. I'll share you the Telegram link once, dear. You can join using the Telegram link. Okay, I have shared with you. Okay, there you will get the PDF and also updates about other classes and etc. Bye bye. Thank you. Stay safe and take care of yourself.